Hi everyone, welcome to this new tutorial. Today we will be building a Zelda-like game using JavaScript and also the Kaboom.js library. So Kaboom.js is, I think, the most intuitive library for making games. Now it's not perfect, but yeah, I've been making a lot of tutorials on it recently. Now the game today we're going to build is a Zelda-like, and we're going to do it a bit differently from what you're used to if you're familiar with the channel. And if you're new, you're also welcomed. I'm going to go over all the concepts you need. The only prerequisite you need to have is some fundamental level of JavaScript. So at least the basics of JavaScript. All right. So in this game, we're going to build this Zelda-like. But unlike the previous tutorials where I would draw the map layout using an arrays of string, so multiple arrays of string, which would become quite tedious, and this is the current way supported by Kaboom. In this tutorial, will be using Tiled, which is an editor for making your levels that is graphical. So it's much easier to just take a tile and put it on the layout and then export that into a JSON file that you will then load in Kaboom.js. Now, it isn't known how to do this, so it's exclusive information that I've discovered, I guess. So stay tuned, I guess. Now, before we go on, I just want to showcase like the actual project we're going to build. So it's, like I said, it's a Zelda-like. Initially, you start here. You don't have a sword at all. You can already see some slimes walking around. Now I can enter a house. So this is going to be basically our second scene, and you can talk to the old man. And what you'll notice is that we have a dialogue system going on here. And I'm going to show you how to implement this. And also when you come back, he says different things. And then if you go back again, different things. And then it will start over from the second line instead of the first, where he give you the sword. Now also, if you've been reading the text here, basically he's saying that he's going to give you a sword. And now you have it, so you can use it. Now we can start our adventure. So the whole goal of the adventure is just to go save his son that is trapped in a dungeon. So here you'll see that I can hit enemies like that. And at the top left corner, you can see that my heart, I lost half of it. So you're going to learn how to build this as well, how to manage health for your player and how to display it, update the UI for it. If I go inside the dungeon, this is basically our second scene, and this is the son that is trapped. If I go here, he's going to tell me to help him, and he's held prisoner, and that the keys are held by a ghost in the next room. And this ghost is going to basically be the boss. And now this is just a nice transition that looks like older Zelda games. I wanted to include that to show you how to do it. Now let's try to fight this boss. So to fight this boss, basically he follows you everywhere. So he has two phases. When he dashes towards you, and when he moves back after you start attacking him. So he's slightly smart. Now I only have one heart, so I have to whoops, I think I died. All right, let me defeat him, because after that you're going to see how we're going to keep game state, so that the old man knows that you saved his son, and yeah, so that the game can progress and you can finish the game. Now I'm just going to put myself here. Come on. I need to hit the keyboard a lot. I don't think I'm gonna win. Okay. Third times, I guess. Now I have coded it in such a way that I should be able to beat him if I put myself here and just spam. Let's see if it actually works. Now this isn't good game design wise, but yeah, you can modify, of course, the code base to make sure that the player cannot game the system like that. Okay, as you have just seen, the ghost has left a key. So I can go here, come back, and then the dialogue will change and the door to the prison will open. Oh, wow, you got the keys. Thanks for saving me. And then I enter here. I talk to him again. Thanks again for saving me. Go talk to my father. He will reward you handsomely. All right, so now that we go back to, so just to make sure that the state is properly kept up, you can see that the ghost does not respawn. All right, so now let's go back to the father, the old man, and tell him that, hey, we saved your son. And here we go. and you'll see, as a reward for saving my son, you can keep the sword I gave you. So this is basically the reward. Now, I made the code base in such a way that you could feel free to expand it in any way you want to make, like, let's say, give to the player a shield, for example. Now, just before we continue on, I just want to tell you where to get the assets. So first of all, the assets I've took for this is this. So it's made by someone called Moomin, and I just wanted to shout him out. It's a free asset pack, but we're not going to use it exactly as it is. I made some modifications, as you may have noticed. I have like used brighter colors and added some tiles. So in the description of the video, you'll see everything, the link to the assets you actually need to download, but you'll also have a link to the original asset pack from which this one I'm currently using is based. So feel free to give him a download just to support his work, I guess. All right, so now let's get right into the code. So right before that, if you haven't done already, I'm just going to go in the development setup. So let's start with the development setup right now. So first, download this tile software. For now, just download it, install it, and then we'll see. The link should be also in the description, and then I'll go over how to use the program later down the road. Now, the other thing we need is to set up our dev environment. So I'm going to open my editor. So here is an empty VS Code window with a empty folder called Zelda game. Feel free to name it however you'd like. I just want to say that if you don't have VS Code installed, I really recommend it because it's really how I develop things. We're going to use a couple of extensions, basically two, that will make development very easy. So I really recommend that you basically just go with what I'm going to use here. So the extensions we need here is Prettier. Now the reason I want you to install this extension is that Prettier is a code formatter. What it will do is each time you save, it's going to reformat your code to look neat. And in the previous tutorial, I wasted a lot of time trying to format my code. And the reason I didn't install a code formatter is because I thought that it would add too much of a burden on the viewer to know, hey, how to install this thing. But I decided to just show it to you right from the get-go, so that, yeah. So install it. So go to the extension marketplace, type in Prettier, and then you should see an install button. Here it's written uninstalled because I have already installed it. Now it's not enough to do just that. You have to add this block here. So if you scroll down, you can see this thing. So this you're going to need to add it. So copy it first. I'm going to tell you in a moment where to add it. So first let's copy it. Now here in our folder. Now I think my code editor is set up to actually work with Prettier even from the get-go. So even if I type in main.js here and just write some console.log and then I simply hello, it reformats it. The reason it does this is because in my user settings, I have set up this as the default formatter. Now, I would like to go a different way. So the first way is where you just use Command P, type in settings.json, and then you can have your user settings where you have this part, editor format on save. This part is exactly the part we copied. So you can do that. You can feel free to do this. However, I prefer to just have a folder within my VS Code, my project called VS Code. And within that folder, you have a settings.json. And within this, here it's where I will paste this configuration. Now, we also need to set up how Prettier is going to format our code. Now, usually the defaults are pretty good, I think. I think the defaults are good, but maybe I have some preferences. If you have some preferences, I'm just going to show you. So to create a config file for Prettier, you simply need to create a .prettierrc.json file. So prettierrc.json. Within here, if you, for example, write semi, here you're specifying that you want semicolons to be removed. So for example, here, it's going to remove it as you save. Now, this is not what we want actually. I don't mind having semicolons, especially if it's done automatically for me. If it's not, then it's tedious. But for the tab width, this is something I would like to configure. Now it's set to 2 spaces. I want it to be 4. So now, for example, if I write a function. Now, by the way, if prettier doesn't work, so yeah, you see when I do a tab, so if I do console.log test, and then right below it, tab is going to take 4 space instead of 2. So this is what I prefer to use, and feel free to follow me or just to remain with 2. It doesn't matter that much, but otherwise, yeah, this is what I wanted to show. Now, it might not work automatically after having done this on a clean install of Prettier. What you need is you probably either need to reset, to reopen VS Code. So try that first. If it still doesn't work, what you can do is you write some code in the JS file, test, for example, and then you hover over, you select it, you right click, and then you do format document with, and then you should see Prettier as the code formatter. Once you click this, it should basically set up your code formatter as being Prettier by default. All right, so hope the first method worked, so that you just have the code Prettier working as soon as you reopen, you close VS Code and then you reopen it. But if it doesn't, feel free to, if it still doesn't work, please feel free to add a comment to the video. I'll try to look into it, or maybe someone else that watches the video could chime in as well. Okay, now let's set up another extension we need. The other extension you need for this project is live server. So basically, it starts a server in a local server within the folder you're currently working on. The reason this is useful is that to make games in JavaScript, you need to have that, a server. Now, there are many options. So if you're not using VS Code, you could start a local server using Python. There is a command for it. Look it up on Google. Otherwise, yeah, just follow me. And you can see at the bottom of the editor, at the bottom right, you can see a Go Live button. When you click on it, it starts the server. Now, for now, it's not useful. We're going to start this in a moment. All right, I can just close this, and let's set up the various assets we need, the various folder structures, etc. Now, main.js here is something that we're going to need, actually, so I'm going to keep it. Now, I'm going to create a folder. Well, actually, never mind. We're going to create first a folder. I'm going to call it source, which will contain basically our source code. Sorry. I'm going to drag and drop main within it, and let's keep it at that for now. The other folder we need is the lib folder. So the lib folder is going to contain a local copy of the Kaboom.js library. So usually now in JavaScript, you usually use a bundler, and you just write npm install the library you want to use. Now, I'm not assuming any level of knowledge in front-end development here. I might in future tutorials when I'm going to try making games in React, hopefully, where it will be necessary for me to use commands like these. But for this project, we can just use a JS file, mjs file, to load the library. Now, you have 2 ways of doing this. Either you use a script tag within your HTML. Now, this is good, but it could theoretically happen where the library is no longer available online, and that means your game will no longer work. So having a local copy and freezing the version, well, actually with a CDN you can freeze the version as well, but just having a local copy is very useful. So yeah, I'm just gonna drag and drop from my other window here the library here. So you can see that it's a bunch of squibbles, and here it's just a text file I put for myself just to keep track of which version I'm using in the tutorial. All right, so for this file, the link will be in the description. Basically, it's a link towards you click on that link, you see the code here in your browser, in the browser tab, you just right click and do save as mjs. Now, the reason we're using a .mjs file here, I think it should be important to explain it, is that in JavaScript, recently you can use modules. So the import from syntax that you're used to in maybe a Node.js environment wasn't available before, but now it is. It's not that new, but to use it, we need to have an MJS file. So I think it's best to just show it to you. So let's do just that. Right before doing that, I'm gonna hopefully not forget to come back to explain this further. So yeah, let's move on a bit. All right, I'm gonna create an index.html, which is basically the entry point of our program. Now, the HTML isn't really fancy. You just need an HTML tag, a body tag, and then put in the script here. So script type module, and then, so the reason we're using type module here is that to allow us to, in our main.js file, to use the import syntax, being able to do import from. The previous way, the older way of importing libraries would be to just have another script tag with the file towards that library. But this gets messy when you have too many imports, and you cannot like structure your own code very easily. So that's why it's best to use a module. So even if you want to import, make another file code available in another file, you would have to use this script notation and put it right above. And I did this in my earlier tutorials. So if you look at the Pokemon game making tutorial that I made earlier on, I used the script tag above like that, and it gets messy. It doesn't get that messy in the tutorial because the game I built was pretty small, but if we want to think, we need to always think a bit further than currently now, so as to avoid a lot of pain later down the line. All right, so now in the source folder, we're going to create a couple of folders here. Actually, before that, we need to create our assets folder at the root. So assets folder. So what the assets here are going to be, we're going to contain another folder which are going to contain our maps. Now the maps we're going to build are going to be built with the tiled editor, and tiled allows you to export your map as a JSON file, and this is where we're going to put the maps here. Now for the actual assets here, I'm going to put it right here. So top-down asset.png. You should find in the description a link toward that. It contains everything we're going to need for this game. So everything is compact into one single sprite sheet like you see here. So that's pretty good. And that's one of the reason I wanted to use this asset pack, because instead of having like multiple folders of images and you could miss one, this makes it very easy for you to follow along. Now we need a font, and as you've seen in the game, I use the Game Boy-like font, and here again, it's gb.ttf. So feel free to, in the description, you should find a link towards that. All right, we have everything we need when it comes to asset. The maps, we're going to create them later and put them here. Okay, so we're ready to continue on. All right, so now what do we need? We need to actually go into our source folder and create a bunch of various folders. Now, one thing I forgot to mention here is the index.html. You have a source/main.js, the path, because we want this to be our entry point to the game. Now, yeah, so that's basically it. Here in the source folder, we're going to create a couple of folders. I'm going to create the content folder. Now, the reason I'm creating a content folder is I'm going to keep all the text content, so the dialogue and what's in the title, etc. By the way, there was a title in the game, a title screen. Sorry, I haven't shown it to you. So the Legend of JS, basically, it allows you to switch languages. I'm going to teach you how to support multiple languages. So here it's in French and here it's in English. Of course, maybe you don't know two languages, so maybe you can skip that part or try to put some Google translated stuff here. Now that's the menu, is bare bones. That's why I didn't want to show it to you in the beginning. But yeah, so that's that. Now, just to showcase again, if I refresh and go to the French version by pressing the F key, the character will talk in French. So that's pretty cool. Now, in French, normally there are accents. So here in the E, there's supposed to be an accent. But however, the Game Boy font does not have any accents available. So, and in French, it is allowed actually to write in capital without accents. So you would see that in France mostly, but if you go to like Canada, the French part of Canada, or French speaking part of Canada, then we usually also use capital, even in capital letters, we would use accents. Now, this is one of the pitfalls, I guess, of trying to do your UI in the canvas, is that you could have some issues with text in various different languages. Well, one thing that comes to mind is that if you want to support Arabic, it's going to be very complicated because in Arabic, the letters are joined sometimes and sometimes not. It depends on their placement. And by default, if you try to just display Arabic text, it's just going to display them unattached and it's going to be basically unreadable. It's going to be displayed in their unattached form, which can look very different than their attached form, which why it becomes harder to read. And this is where I think maybe in the future tutorial, where I'm going to start making games with React, we're going to see how to basically build a UI layer on top of the canvas by using actual text, actually the browser, because the browser are made to support probably all major languages. So we don't have to do that work again. So that's something for the future, hopefully. Now, okay, let's go back to the code base. Yep, so I'm just going to refresh here and reopen my editor. Now, okay, so we have a content folder. We'll keep it empty for now. At the same level, we're going to have an entities folder, which is where we're going to put all of our code that we need for various entities. So the player, the slimes, and the ghost, and the old man, which are the 4 entities we're going to need to code logic for. As for the sun, it's basically not needed. We just need a collider and to collide with it. So yeah. And then another, whoops, not here, within the source folder as well, we need another folder called the scenes folder, which is where we're going to store all of our scenes. And finally, a state folder where we're going to keep global state. So here I'm going to go over this later, but having this pattern is going to make our code very, very, very convenient, very maintainable, I guess, not convenient. All right. And finally, the UI components folder. So this basically is going to contain all the dialogue text box and stuff. There aren't many. There's basically like 2 things, the health bar and the dialogue box, which are the two components we need here. All right, so now let's we have our setup basically done, and now we want to display something on the screen. So let's get right into that. So in the source folder, I'm going to create another file. I'm going to call it Kaboom context. Now this is different. If you have followed my previous tutorial, we would usually just import Kaboom globally and use the functions like that. So they are globally available in any file you import Kaboom in. But this time around, we're going to create a context, basically a constant that you need to do k dot and then the name of the function. So that just by looking at the code, you'll know that this function comes from Kaboom. So that's something that's pretty handy, and it's going to make it easier for me to explain to you like what is from Kaboom and what is just normal JavaScript. All right, so in this Kaboom context file, what we're going to do is we're going to import Kaboom. And to do that, we just do import Kaboom. So now we can use the import syntax from, and then just so you know, like you could always use the import syntax here. It's not because we did anything special yet. It's just because in the index.html, we have the type module, which is basically allows you to use the import syntax within a main.js file, within the main.js file, which is the entry point. But even though we aren't in the main entry point here in Kaboom context.js, we can still use the import statement because afterwards we're going to export it and then use it within here. So basically, the system is smart enough to know where to look for, to know that this is actually a valid import statement, and it can pull from the entry point know all the references to all the things you import using the normal import, the module import syntax style. Hope this was not convoluted. If it was, ignore everything. Just know that since you have used the type module here in the main.js, you can just use the import statement. All right. So we're going to import Kaboom from, and from where? From our library. So this is the path we're going to. So dot dot, basically, if you're not familiar, I want to take the time to explain this because I don't know your level, and I would rather not assume any like major previous knowledge, rather than just you copy this without no understanding. So dot dot, basically from this, so from the file system, the two dots allows you to go back a level. So if you see it as a tree, you have, I think a diagram would be in order here. So I'm just going to go xcalidraw.com, or let's try a new one, tldraw. I think it's tldraw.com. All right, nice. All right, so here, if you're more advanced, this looks like a waste of time, but please bear with me or skip ahead. I just want to explain this just to make sure that everyone is on the same page. So we have so we have a bunch of folders. So that's the root. The root is, where's the text? All right. So we have our root, which is the slash, basically slash. And in this slash, we have various folders. We have the source folder. I'm wondering why it's doing something like that. Okay. This is much better. We have the source folder. Maybe lower this, make it smaller. So we have the slash, and then it's gonna make sense in a moment. We have another arrow, another arrow. Let's just keep it at 3 and imagine that the rest is also defined. So here we had our libs folder. The font looks nice. It's the first time I actually use tldraw to explain stuff. So this is the rest. And now to understand, let's draw the actual path. So slash search slash libs, so you understand why I put a slash here. Now here, within this, we have our Kaboom context.js file. So Kaboom context.js. And this, the path for it, so we don't just, it's slash source slash Kaboom context. So for you to import something from the libs folder, because in the libs folder, you have slash libs. I think it's lib, not libs. The name, yeah, I called it lib because there's only one library. So sorry about that. So lib. So here it's going to be lib slash and then kaboom.mjs. So the MJS extension allows you to import it as a module by using the import kaboom from this. So yeah, this is why it's an MJS and not just a normal JS file. So now if I want in my Kaboom context.js where I'm writing the import statement, I'm writing import Kaboom from, I need to specify the path where this file needs to look for this. And by doing ... you're basically telling your file system, well, actually, I don't know who you're telling, the interpreter, I guess, the JavaScript interpreter, to go back one level. So levels are here. So this is a level. This is another level. And finally, I really like tldraw. I just realized it's it's even better than Excalidraw. It's very easy to use. All right. We have 3 levels in our file system. So by using ... you're telling their JavaScript interpreter, I guess, to go one level below, I guess. So one level behind. and then to go to the libs folder by using /lib. So it's going to go here, 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 and then Kaboom.mjs. Hope the explanation was Hope the explanation was clear and what this two dot means. If you haven't had any like formal computer science education, this might seem like you might not have known this. So hope it clarified things for those who are more beginners. And yeah, let's continue. All right, so let's jump right into, so I'm just going to write the whole thing. So lib/kaboom.mjs. I save it. Now I'm going to create a constant. I'm going to just call it k, just so that it won't become too tedious later on. So in Kaboom, to create the canvas, you need to call this Kaboom function. So you call Kaboom and you pass in an object. It takes a few params. We're going to first pass it a width of 1280 and a height of 720. So this is just a standard 6:9 resolution. Now we're also going to need to set the letterbox property to true. The reason you need this is so that your game canvas is going to scale regardless of the screen sizes of the user, the player, automatically, so you don't have to do any work. And finally, we're going to set global to being false. But by default, by default global is true, that means that once you write this statement, you can use all the functions of Kaboom by just calling them their name. But by using global false, you're going to have to do k dot the name of the function. For example, add, which is one of the functions Kaboom offers. Now we're just going to export default k here. Now, again, if you're not familiar, export default means basically it's the only thing that is going to be exported from this file. If you want to export multiple things, you just remove the default, and the import syntax is going to be different. So the from the other file. So for example, if I just do export k, declaration was I think it's export. If you just do export k here, when you're going to be in main.js where you want to import this, so I'm going to go here, go to main.js. I'm just going to do import and then use brackets because you can have multiple things to import. You can have k, you can decide to export another constant, another function, etc. And use the brackets here. But because we want a default export, we just want to do import k from the Kaboom context. And this is important here, is that you have to add a .js. If you were using a bundler, that would not be necessary, but because we are using JavaScript modules that is native to JavaScript, that is supported, ran in the browser, we need to use the .js extension here, as the browser needs to know that, hey, this is a JavaScript module. So if you were using a tool like Vite, and where your development workflow is basically you do npm install and then npm run dev, you do not need this, because anyway your tool is going to compile all of your code into a single .js file that you can just deploy somewhere. Now there are advantages to this approach, and probably if I make a React tutorial where I make a game, let's say an RPG, stuff like that, it's going to, we're basically required to use a tool, a bundler like that, because you cannot use the syntax called JSX with normal JavaScript. So basically having HTML elements within your JavaScript that aren't strings, that aren't within strings. All right, this is a bit like out of the topic for this tutorial, but I like to add stuff like that just so I believe in just-in-time learning, where you learn everything you need when you need it. So you can go into these branches of, so for example, I want to make a game. I don't know JavaScript. Okay, I learn JavaScript. Okay, I need to import a module. Okay, I need to learn how the path, this file system works, etc. And this might be slow at first, but you get a better understanding. Okay, so now let's go back to Kaboom context.js and remove this, the export. We want to export it default. So one thing that is weird is in JavaScript, you cannot do that. It's considered ambiguous for some reason. Now because you can have multiple const defined in a single line. You could have const b 10 or something like that on a single line. Now I know this isn't on a single line, but it's considered as a single expression, so that's why it's not allowed, I think. But don't quote me on that. Make your own research. I'm pretty sure it's this. This is the reason, but you know, like just I don't want to risk being wrong, I guess. All right, so I'm gonna do export default k. Now you can do this. Now here in main, you can have your k here available. All right, so we have our canvas, we have exported it. Now, I think we need to start our server. I think we just need to start our server. All right, so I have this. Okay, so this, don't forget to hit save frequently on the files. Otherwise, you might look at the output and not realize that you haven't saved. That's why nothing is happening. All right, you see there's this go live button at the bottom corner if you have installed live server correctly. Click on that and it's going to open a tab. And here you can see that just by importing k from Kaboom context, we have this beautiful checkered board canvas. So that means everything is working and we can really start diving in and work on the game. So let's go back into our editor. All right, so now what are we going to do is let's start with creating our various scenes. Now, a way to do that is to simply use the scene function that comes with Kaboom. So so for all the functions that I'm going to mention here, I'm always going to try to mention what comes from Kaboom and what is from normal JavaScript so that you have a better understanding of how you would use Kaboom.js outside of this tutorial. So what I'm going to do now is I'm going to create a constant, an object basically, but defined as a constant. I'm going to call it scenes. And it's basically going to contain the scenes we're going to use. Now this might not make much sense, so let's keep it empty for now. Right below that, I'm going to have a for loop. I'm specifically going to use the for in loop. So for in JavaScript is not the same as for in Python. It will not iterate through an array. It will iterate through a object and give you the key for that object, for each of the entry in that object. So here I'm going to have a const scene name in scenes. Now within that, this is where we're going to call our first Kaboom scene function. I'm going to call the k.scene function. This is a Kaboom function that allows you to define a scene. It takes two params. The first is the name. It's a string. Now, because we have the key that we want to pass here, we're just going to need to have the scene name here. Now, I may have lost you. So in the scene object, let's add a name, a string. I'm going to call it world, and it's going to point towards an empty arrow function. All right, so you see Prettier removes the quotation marks because in JavaScript, you can have objects without being like strings if there are just a single word without spaces. Otherwise, if I wanted to have world dot space like that, then it would remain as a string. Just something I thought would be important to mention. But basically, if you know your stuff already, I might sound redundant, so sorry. Now what we're going to do is that this scene function in Kaboom.js takes the name of the scene you want to create. So this is basically you're telling Kaboom that create this scene where the scene name is what I pass as a first param, so that when I'm going to refer to it later on, it knows that, hey, this is the scene you want to call. And the second param is a function. What this function does, it basically just, it contains the logic of your scene. Now what we're going to do is we're just going to defer to what's in the object, the scene's object. So I'm just going to call my scene object here, and then pass in the scene name, which is the key, and even call the function that is resulting. So we define the function here. By the way, you could even do this. In JavaScript, this is allowed to just have your function defined with an object. Now you're going to see in an instant that we're not going to put all of our scene logic here. We're going to put it in our separate scenes folder. This so it is more maintainable. So we have k.scene scenes. Here we call the scene within that. This might sound pointless for now, but what I want to do is pass the context here. So what I want is to only have one place, one source of truth where I call all Kaboom functions. And well, all because the k object basically controls the rendering. So by passing the k, I don't have to import k from Kaboom context in all of the various files we're going to write later on. So we just do it once, and most of it is passed through params like these. So I can add it here. Now, if we were using TypeScript, it would be much more straightforward what this does, because in TypeScript you have type information, like it will tell you that this is the Kaboom context. You would type it as it, of course. So yes, don't hesitate to try using TypeScript with Kaboom. It is supported. Now the setup for it is going to be very different than what I'm currently having here. The reason I do JavaScript game dev tutorials instead of TypeScript game dev tutorials I thought to myself that if you know TypeScript, you're just going to use it even when you follow my tutorial. So those who don't know TypeScript, it's going to be more accessible to them to just use JavaScript. So even if you're more experienced, you can still follow the tutorial because you're going to be able to adapt the code to your needs anyway. All right, so I have case scene, etc. We call it. Now we do nothing with it, and that's why it's grayed out a bit. And now finally, the last piece of code you need is you need to call k.go, which tells Kaboom which scene to go to, and you need this by default. You need to have a default scene. So that's why you need to call k.go in your main.js file most of the time if you're using scenes, because you could make a game with just the default canvas and no need any scenes, but that would be a pretty simple games. And I'm trying to progressively increase the scope of the tutorials, the games we're making. So yeah. All right, so here you just write as the string. So it takes one param. Actually, it can take two, I think. It can take a param and then values if you want to pass data to other scenes. But I preferred to go with another approach to state that is much more convenient than this. I tried using this in previous tutorials, and I think on a larger scale game, it would get messy. So that's why I prefer using singletons that control the states of the game, and multiple, not a single source of truth, which will become really big. So I usually have a game state singleton. I'm going to explain what a singleton is when we're going to do it, if you don't know. And this is from where we update and basically keep track of the general state of the game. Now we have specific state like player state, old man state, etc. All right, so here we're going to just put the default scene to being the world for now. Later on, we're going to create this simple menu scene to switch between languages. So that's going to be useful. All right, so we have this, we have everything. I think it's time that we just create our first scene from the scene folder, in the scene folder. So I'm going to create a new file within the scenes folder. I'm going to call it world.js. Now here, I prefer to use a default export for those things. I just want to export the scene and nothing else from this file. But you're going to see that later on we're going to use, I think the name for it is named export, or the other variants where you use brackets, when you can export multiple things outside of from a single file. All right, so I'm gonna write export default. Maybe I should increase. It's a bit too late for this, but maybe let's increase the font a bit. I think this is too big. Could be too big. Maybe. Okay, let's write our code with this font size for now. All right, so I'm gonna create an async function Now, the reason this is a sync is there a reason for this? Yeah, because we're gonna load the map from our JSON file within those scenes, and because of that, you need to have a sync await for this to work. All right, so I'm gonna do a sync function world and then pass in the k. So basically the same thing we did in our main.file, but we just keep it at that for now. And here, I'm just going to import, not on import, sorry, import world from world.js. Remember, if your editor did not add .js, you need to do this. Otherwise, the error you're going to have is going to be a MIME type error not supported, or a MIME type, something MIME type, an error that mentions MIME type, basically. So now we don't need this. We can just call world like that. This might seem strange if you're not used to this syntax. This is a shorthand for having a key called world that pass in a function called world. If you save this, it's going to do world, but even more concise. JavaScript allows you to have simply world. All right, so I think we can look at the output. Nothing has particularly changed, and that's normal. Now to really make sure that everything works all right, let's go back to our world.js code, and within, I'm just gonna draw something on the screen just to show you. So I'm just gonna do maybe k dot. So in Kaboom.js, use the add function to add game objects, to create game objects using components, which are functions that you call within that array. And then so it's an array of component that you pass in to the add function, which takes care of creating that game object. And most of the time, a game object is visible. It's something that a sprite, for example. Now we're just going to use the rect component primitive that is available in Kaboom.js. I'm going to want a rectangle of 100 by 100 pixels, and I want to have its position. So use the positional component, pos, and specify the x and y value. Now, if I want my rectangle to be at the center, I'm just going to use k-center component within the positional component. So this takes a vector2. Vector2 are just a pair of two values, x and y, but put in a neat data structure that is offered by Kaboom. So it's the vect2. You can either pass vec2 like that and specify 100 by 100, which is the x coordinate and y coordinate, or you could just have 100 and 100. So you have those two options, or you can use this specific component that gives you the exact coordinates for this center. So this k.center gives you a vector2 that has the x value corresponding to the center of the screen and the y value for it as well. So the coordinates for it. Now this, let's jump. Yeah, let's save this. And let's look at our editor. You can see we have a white square by default. Now, if you hit F1, you can see debug mode, which gives you the FPS, but also will allow you to see the hitboxes. Now here, you can see that the the rectangle is drawn from the top left corner. So this point actually is the coordinate. Now you can actually have it from, have the square drawn from the center, but you need to add the, first you need to add the area component, basically creates a hitbox for your rectangle. And then finally, you need to add the anchor component. And in this anchor component, you simply pass in the string center to tell Kaboom that, hey, you want this rectangle to be drawn from the center. So you can see that now it is centered. And if I hit F1, not only you have the hitbox now that is drawn, because we added the area component, which creates a hitbox automatically for you. And we have the point, the coordinate, which is the exact center of the screen. All right, I think we have everything set up, and we can actually start working on our players. Maybe let's start with the map first. So we're gonna use tiled. So here you can see that I have house, dungeon, world.js. Those are already done maps, but I figured that you wouldn't learn like that if I were to just give you the map. We need to actually create one at least. So my plan is maybe we create one together, like the world map. We recreate it, we display it on the screen so you understand, and then maybe you could use these already made from the GitHub repo, so you don't have to like it's not tedious. And by the way, those JSON files are not only the exported maps, but also the map that you can open within tiled. So it's the same format. All right, so in the next part of this tutorial, I'm going to explain how to use tiled to draw this first world.json map, and then we'll decide if we do this as well together, or I just give you the map already well done. I'm going to decide this later on, which one is better for your learning. I think that if you know how to do this, how I built this map, how I build the collisions, etc., you could easily replicate this and even this on your own. All right, so let's go and set up tiled so you can work with it very easily. So what I'm going to do is I'm simply going to remove the dungeon.json, house.json. I'm going to keep this as a reference for me because it's going to be a bit hard for me to replicate the exact same layout without having the actual finished map in front of my eyes. If you install tiled using the website I've shown you earlier on, you might have some issues. So the issue you're mainly going to have is basically that the font size is really too small. So to fix this issue, I haven't found anywhere how to fix it, but basically you go to the preferences section under the edit tab. So you go here, click on preferences, sorry. Now go to theme, and by default, this is checked out. Use custom interface font. What you want is to check this and then increase the font as much as you need. I'm going to keep it at 18. You even can decide on the font itself, which font you want. I'm just going to keep the default and close it. All right, so now what you're going to do is here at the top, you do a new map. You click on that, and then for the orientation, it's going to be orthogonal. Basically, keep it as is. For the tiled layer format, CSV. And for the write down render order, so it starts from the right, and then it goes down, I think. Well, basically, I didn't touch any of that. One thing you need to keep in mind is that you need to use a fixed map, not an infinite map. Otherwise, it's going to make drawing it in Kaboom.js much more complicated. Now here, I've selected 100 tiles by 100 tiles. And for each tile, it's going to be a width of 16 pixels and a height of 16 pixels. All right, I'm going to hit OK. And now you see the grid here. Now you need to add a new tile set. So basically, I'm just going to do just that. Now, to add this, you click on new tile set, and then you need to specify the source. And this is where you click on the browse button. So basically, this is the path. So this is my path, but your path is going to be different. Basically, it points to the assets folder inside of your project and the PNG. So either you use the browse feature here, and you select it through the file explorer, or you just write the path manually here. So really it's up to you. The tile width and tile height need to be 16 pixels as well. And then you click on OK. Now, by using the control key, you can increase, zoom in, zoom out. Control key plus the mouse wheel. All right, so we have everything we need. You can see here untitled.tmx. This is not the format we want. So what you're going to do is basically going to click on Save As. So here I have in the File Explorer, I have it set so that we have the desktop Zelda game, which is the folder where I put the code, where I'm currently building the game, the assets folder that we created earlier on, and now the maps folder. This is where we're going to put our map. And here, instead of calling it untitled.tmg, it's going to be world.json. Now, having done this, it created a JSON file. Now for the if I look at the previous map I had here, I'm going to take inspiration and just tell you how to draw it. So here you have your layers at the top right corner. Here in the finished version, you can see I have a bunch of layers. So let's start with the first layer, which is the ground. So I'm going to call it ground. Now, what I'm going to do is I'm simply going to do a basic version of the map, really simple, just to show you how to use the program, how to create collision boxes. And then I'm just going to use my own stuff here. All right. Okay, so I created the ground layer. Now let's create a simple map. So if I go here, let's say I put it here, I can just draw it here. So I put a couple of tiles like that. You put here, depending on your assets. So oops, this should be here. So basically here, there isn't any miracles. You just draw it normally without, by just looking what makes sense. It's like the meme about drawing an owl. Just draw some circles and then draw the rest of the owl. So here it's basically the same thing. So you can have something like that, and I think maybe not. No. This should be appropriate. And then the tile here, which is going to be the water. And instead of having to draw the whole background, this is going to be performance intensive for Kaboom. So I just draw the tiles I need and then use a uniform background color within Kaboom to draw the background instead of doing it in the map editor. That's why if you go here, you can see that I only draw the water for those the part with reflection here, rather than the whole thing. If I go back to the the basic mockup map, you have it here. And now I'm going to, after having created the ground layer, you can right click, new layer, and then there are two types basically of layers you want. You want tile layers for basic tiles that you want to draw in. So those tiles don't have any like properties necessarily. You cannot have like individual properties, but the object layer is what you use for determining where the player will spawn, but also for the collisions. So let's create a first object layer, and the layer is going to be a the name what it is. The name for this layer, it's going to be the boundaries. So basically collisions. So I'm gonna call it boundaries. And what's useful here is that I can create, using the box, the rectangle, you select and then you can draw a first collision box. What's cool is that you can give a property to that specific box. Let's for now I don't see a reason to name it any, so let's just save with Control S. If I see here, you have just, if I select it using this is the selection tool. It's not very visible, but it's this when you are on an object layer. You can click on it and then you can see if there's any properties. Now there isn't in this. So let's go back to the basic map we're building. So we have here the collision, the first boundary. I'm going to create another one here and another one here, and finally a one here so that the player doesn't fall off from the cliff here. All right, I'm going to save all of this, and we just need to create another layer now. I'm going to create another object layer. I'm going to call it spawn points. So spawn points is the name. Is it true? Yeah, spawn points. And in this layer, you can use this. I don't know, this pin. I guess it's called a pin. Where, sorry, my mic is a bit below. Okay, all right. So it's called a pin, insert point. It's called an insert point in this program. So here I'm gonna create one, and I'm gonna give it a name. So the name I've given it is player. So this is how we're gonna know in the resulting JSON where is the player, where we're gonna spawn our player. So I'm gonna save this. Let's put one for the slimes as well. So let's put another after having saved, of course. Let's say we want a slime here. So here, just to make sure that everything is understood, the pin is here, but the character is actually going to be drawn from the top left corner. So, I mean, the sprite will actually be in this cell. Same thing for here. The slime is going to be in this section of the screen. All right, so now here, I'm going to call it, wait a minute. So yeah, I'm going to use the selection tool here. Remember, this is the selection tool. It's a bit of a weird icon, I think, but I guess it's the name. So I will select it, and I'm going to expand this. Why is it called spawn points? This is called player. Okay, I click on that. Click on that. All right. Now I click on name, and I'm going to call it slime. This is where the slime is going to spawn. So I think that's basically it. Now, one thing I want to showcase is the tree. So the way I did the tree is pretty interesting. So I think it's worth showing you how to do it. So I'm going to create another layer called vegetation. So here, right above ground, it's going to be a tile layer. It's going to be called vegetation. Now vegetation, we're going to put the bottom of the tree here in this layer, but we need to create another layer. And this layer is going to be called upmost. The reason I'm calling it upmost, and it's going to be also a tile layer, is because we want it to be above everything else, even the player. The reason for this is that the top of the tree, we want the player to go behind. So the player will go behind the tree, and it will give you the illusion that the player is behind the tree, because the top part of the tree is drawn on top of the player. Now, we need to add a collision to this. So in boundaries, we add a new rectangle here, and I click on that. I create my box. Now I can save. Now we have everything we need. We can go back to the code editor. And then later on, I'm just going to drag and drop this and the other maps. So I really want you to have just a basic understanding of how I did things. And then you can just open those maps as well, already made in tiled, and edit them and look at the various layers, objects being put, etc. For example, here you have 2 squares for the wall. You have named boundaries, so player dungeon, so that when the player collides with it, you can run some logic by looking at the name, etc. All right, now that this is done, let's go back to the code editor. And one thing I want to show you is that now in the assets maps, we should have the world.json. And I think it's interesting to just look at it, look at what the file is about. So what does this do? So the data, so we have let's collapse everything, and then let's go over one by one. So first of all, we have the height of the map, the width of the map. This isn't very important for us. We have what's really important for us is basically, I think the tile height is important, tile width is going to be important, but mostly it's this. It's the layers, how many layers we have. If I collapse this, collapse this, collapse this, and collapse this, and collapse this, we can see we have 1, 2, 3, 4, and then, oops, 5. 5 layers, and if we go back, 1, 2, 3, 4, 5, it corresponds. Now for the tile layers, like the upmost, I think this tile layer is going to be the ground. So in the array, the first element is the deepest layer, and then the layer on top, the layer on top, the layer on top, the layer on top. So for tile layers, where you just draw tiles, you get this data key, which contains an array of what? Of tiles, numbers, the frame, the specific frame in your tile set. So this 40, I guess, what does it correspond to is if I go to, I guess this, you click on that, you select, you can see that the ID of the tile is 40. It's basically the numbering. So how this numbering is done is basically it starts here at 0, 1, 2, 3. You can see at the top left corner while I'm selecting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc., etc. And then it switches to the next line, etc. This is how the numbering is done. So by simply knowing which tile is being used, we can basically know what to draw. So if I collapse this, you can see the name of the layer, which is the ground, and basically the width and height, etc. This isn't important. The most important part is this. Now for object layers, so this is another tile layer. So this is the vegetation, same thing, for where the bottom of the tree corresponds to 162. If I go back to tiled, select the bottom tree here, you can see 161. Maybe it's the topmost. Wait, what? It's 160. Oh yeah, because there is an offset, it seems. There is an offset because tiled, it uses 0 as the absence of the tile and not actually the first tile. So you have to add +1 to everything. So even though here it says that the ID is 0, actually for this tile it's going to be 1. So it's offsetted because 0 in the exported JSON corresponds to the absence of the tile, not the first tile. So this is something to keep in mind. It's going to be clear later on when we're going to deal with this issue. Hopefully, I don't forget. Okay, so we have the data here. Okay, so those layers are tile layers, and actually you can see the type here. But for object layers, so the boundaries, it's different. You don't have a data property with an array. You have instead an objects array, which for each contains an object with the height, the name, if there is any, but also the exact coordinates. And this is what we're going to use to draw those objects, which is the boundaries, the hitboxes. And if I scroll down and look at the spawn points, you can see that the name is player, so we can know this specific object corresponds to the data we need to know where to place our players, our player. We only have one. All right, now that we have the world.json and we've looked into the world.json file in depth, I think you have a better understanding of how tiled works with Kaboom.js. Now it's time to actually do the drawing, try drawing the map. Well, actually you have an idea of how it's possible to get all you need to draw the map in Kaboom. All right, so we have this async function called world. We need to import the map data. So we need a way to fetch this, to load this JSON file. Now there are recent features in JavaScript that would allow you to simply not have to use fetch call and really import it in the same way you would import a JS file. But for this tutorial, and I don't think it's supported outside of Chrome, so we can't use it. We want our game to work on all platforms, all browsers. And the two major ones, well, actually there's only one major browser vendor now. It's Chrome. Firefox is losing market share, unfortunately. I'm still using Firefox, but yeah, it's a losing battle, it seems. All right, and I'm not that attached to browsers anyway, but just wanted to discuss this a bit. All right, so we're going to need to load the map, and for that I'm just going to create a file at the root of the source folder in the same level as main.js. I'm going to call it utils.js. This is basically where we're going to put all the functions that don't fit anywhere else, and is basically a utility function. It's a utility to fetch the map, actually, not necessarily like draw it. So it's going to be used by all these different scenes. So I think it's a good thing to make it under the utils folder so it's fully reusable. All right, let's write some code here. And yep. So to load the map, we're just going to need, I'm just looking at, yep. We're going to export. Here, we're just going to export multiple things from this file. So we're not going to use default export. So I'm going to export an async function. So I'm going to export an async function. I'm going to call it fetch map data. Now this function, fetch map data, is going to take in the map path, which is a string that tells us where to look for the map. And we're simply going to return an await, so fetch call. So this might look strange, but bear with me, it's going to make sense in a moment. So we pass in the map path. We then call .json outside of it. So to explain this, sorry, I have to fix my mic, which my mic tripod, I guess, which keeps falling. All right, so what we need to do here, what we're going to do is, okay, so to explain this code, basically we use the fetch call to get, so the map path is basically the URL to the JSON file here, which can be found by just having a relative path, which is assets maps world.json. We use the fetch call here to get this. We need to await, so we need to wait for this fetch to be done before we proceed on with our code. And then once this is awaited, so once the result has come back in, we need to convert this in JSON, which is again is an operation that needs to be awaited again, because if you just return without the await, it's going to return a promise pending or something like that. So by just making sure that the JSON conversion is fully done, or it's made to JSON before returning, we'll make it like sure that when we get it back, it's actually some JSON. Now, the reason I'm using the parentheses is just I was too lazy to have it on 2 lines instead of 1. So this set to a variable in 1 line and then await that variable.json. All right, so we have this. We can just go back to our world. And in our world, it's where we're going to world theme. It's where we're going to just call it as, so I'm going to remove the rectangle. This is no longer needed at all. So I'm just going to do this and then remove it. And then I'm going to do const map data equal await. And then after that, I'm going to simply call fetch map data. Normally VS Code should show you this. It will import it, but it's not smart enough to know that we need a .js here because we're using JavaScript, native JavaScript modules. So we do this, and as for the actual path, it's going to be assets/map/world.json. Now that this is done, I think we're ready to actually draw. But before drawing anything, let's create a utility function that allows us to draw, maybe on top of that, the background to a specific color. So I'm going to call it export function colorize background so that we can draw the rest of the sea without having to use like various styles. So here we're just going to pass the context k instead of having to import it again and again. And finally, we're going to pass RGB values. So this is how we can define a color with red, green, and blue. There's a way to define it using hexadecimal, but for some reason when I'm using with K, like with the context, the non-global version of Kaboom, it doesn't work. So yeah. Okay, once we have this defined, we just simply add a k.add.k.rectangle. We create a rectangle that is going to be k.canvas canvas.width. So this is how, so the k object exposes the canvas, and you can then go search the width. You can do the same thing for the height by using k, which is the Kaboom context, get the canvas, and then get its height. Now you might be wondering why there's no way in Kaboom to just draw a background from a single color. There is, but the issue with that function that is provided by Kaboom is that it will colorize everything. So if I go back here, it will even color this part. We don't want this part to be colored. the same way here. We want it to respect the aspect ratio. I think this is a bug. It wasn't there before. So yeah, if you're a Kaboom maintainer and you're watching this, please fix it. Fix it if you have time, of course. It's not that big of a deal though, because there is this workaround. Anyway, so we create the rectangle, but now we need another thing. We need to pass in the k.color component. So Kaboom offers the color component, which takes in an RGB value. So R is going to be a number from 0 to 2 and 255. Same thing for here, and then same thing for here as well. All right, so now we only need one thing left. We need to use the fixed component, and this is going to come into handy when we're going to implement the camera, because we don't want this rectangle to move alongside the camera, to be affected by the camera viewport. We want it to always remain static regardless of the camera. So that's why you use the fixed component that is also offered by Kaboom. Yeah, anyway. All right, so we have this. We don't need to return anything because calling kadd just creates it, adds it to the canvas. So now what I'm going to do is I'm going to go back to the world.js, maybe right after having imported it. Or maybe you draw it first. It doesn't matter. It shouldn't matter. Colorize background. Now I'm passing the Kaboom context. Now for the specific colors, I don't remember them at the top of my head, so I need to go look it up quickly. Sorry. So it's 76, which those colors, those RGB values I'm mentioning right now corresponds to the bluish, the blue like sea-like color. The how do you say, the light blue color, yeah, used in the asset pack. The way I extracted those is by using Sprite, which is a pixel art editor software, and just looked at the RGB values using the color picker tool. All right, colorize background is called. Now, if I look at the result for that, you can see that we have a bluish, light blue, beautiful background. All right, now it's time to write the logic for the map. I think we're ready. So what I like to do is to create an object, a game object called map. So const map equal k.add. The reason I'm doing this is that in Kaboom.js, objects can have can have children that are assigned and then positioned relative to the parent object. So here I'm going to specify a position for the whole map. And this way, after having drawn the map, it's going to be very easy to move it where we need it. For now, let's do it 0. I think it's going to be fine with this. We don't need to move it elsewhere, but yeah. The other object I like to create is an entities object, which is going to contain references to the various entities we're going to draw in the scene. You're going to see why this is useful. So one player, so I'm going to put it to null intentionally. That's why you use null instead of undefined. Undefined is when it's not intentional. Null is when you want that you use it when you like, I want to make this null. It's intentional. That way, using it that way, you can know if it's an error on your part, you forgot to define something, or the programmer knew what he was doing. Now here for the slimes, we're going to draw many slimes, so we're just going to put that into an array. Now I noticed that if I go back to tiled, there's only one slime, so let's just add one. So spawn points, what's the name of this? The insert point tool. Let's put one here and use the same name, slime. It doesn't have to be unique. Save it with Control S, and let's go back to the editor. Now what we're going to do is we're going to get our layers. So as you probably remembered, in the world.json file, there is a layers property that contains all the layers. So if I go back, so I go back to the world.json, you can see that this is this key. We want this array. So what I'm going to do, I'm going to use the map data. So map data dot and what I'm going to do. So yeah, the reason we're using an await here is because this is asynchronous and we don't want to proceed on until this is fully resolved. So we have access to the layers, the object, the JSON object. All right, so now that this is done, we can just do layers.map.layers just to have a lighter syntax. And then we're going to iterate through those layers and draw them. So let me just fix that. So for const layer off. Now we're using the off loop, which allows you to iterate through an array. It's an easier version of the traditional for loop in JavaScript, where you have to define I and then another I++, etc. here. So you don't have to do that if you just want to simply iterate through an array. Now, here it's where it gets interesting. If the layer.name equal boundaries, we want to draw the boundaries. So I'm going to leave a to do here, and I'm just going to write a continue, because otherwise we want to continue with another if statement. This is how you get rid of else's statement. Most of the time you don't need to write an else. You can get away without doing it, either by returning early or using continue within a for loop, for example. It makes your code much easier to read at first glance. So that's why it's a good idea. I think I messed it up a bit. Never mind. We need another if statement within. Now, if the layer.name is a spawn point, though, so we're going to spawn points. It's called spawn points. We're going to, again, to do, and then continue. And then I think that's it. The tile are just going to be drawn here. The normal tile layer. The tile layers, instead of compared to the objects, the tile layers compared to the object layers does not need to be drawn any differently. Never mind, I said this wrong. So the tile layers can be just drawn by using the frame, etc. But for boundaries and spawn points, we need to have a custom logic to draw them. That while we can reuse the exact same logic for any tile layer. So here we're gonna to do draw tiles to do. All right, so let's first start by drawing the boundaries, the hitboxes basically, and then we'll do the same for the spawn points, and then, or maybe, you know what, let's draw first the tiles, because this is, I think, the most visual part first. Once this is going to be done, it's going to be like very gratifying to see something on the screen, your map. So let's go back to the utils folder. Again, we're going to create a function that is going to be reused by all scenes. So that's why it's in the utils.js. So this function is going to be called draw tiles. And the params it's going to take, it needs to take the context, the Kaboom context, because it's going to use methods from Kaboom. It needs to take the map object that we created earlier on in the world, so that we can add to it child game objects, the layer, each tile basically. We need the layer, the specific layer name. Not name, the layer is actually if I go here, you have layers, and then here, because in our for loop, layer, why do we need the layer? So we have, okay, so we have layer, because we need some data about the width and the height. So let's say each object here is named a layer, it's a layer, and for those, we have the width and the height, which is going to be useful, I think. All right, so in our utils, we need the map, the layer. Is there any other thing we need? We need the tile height and the tile width. Tile height, and then tile width. Be careful. Here I did not use capital letters like camel case, because I think that was due to the fact that in tiled itself, it uses lowercase tile height and tile width. And I thought when I was refactoring it, I just kept the same name convention here, so that you don't get, so I don't get confused. So that's why it's there. I think right now it might be safe to just disregard, but let's keep it that way for now, just to be sure. So here we're going to need within a variable named number of drawn tiles equal initially to 0. Now this will allow us to know when to move on to the next row. So we draw each tile in a row and then we move on to the next and to the next, etc. Now we're going to create a tile pause constant, which is going to be a vector2, and it's going to give us the current position of the tile. We're going to set the position. So this is basically the current tile position. So after having drawn one tile, this will be modified to change its values so that it's going to correspond to where we need to draw the other tile, etc. It might not make a lot of sense. You could have used a simple object with X and Y properties, but this is more convenient. It's shorter to write, and you basically have access to the same thing. So now that this is done, let's start with going through each of those tiles. So const tile of layer. So that's why the layer dot, I think it's going to be layer dot data, which is the property that is needed. If you remember in the world.json, this key. Basically, I think now that you could have just passed the data layer immediately instead of passing the layer object. But then again, we use the layer with the full layer with. Okay, I understand now, because we use this later on. That's why I did not just simply pass the data array to this draw tiles function. All right. Okay, so now within this for loop, if the number of drawn tiles modulo, I'm going to go over the modulo operator, layer.width equal 0. So basically what this line does, it allows us to know when we have finished drawing all the tiles of a given row. So the reason for this, the reason why this works is that we do the division. So number of drawn tiles divided by the width. If there is no remainder, I think, if there is no remainder, that means that the division was even. So we fully divided the number of drawn tiles by the layer width, which means that we have finished drawing the full row, because there is 100. Yeah, so there is 100 tiles in the. There's the width of the tile, the layer is 100. So by having this operation, you're making sure that you will only move on to the next line to draw, once the current line has been fully drawn. And that's why right below, I do tile pause. I set it, the x coordinate back to 0. That means I think a diagram is in order here. So here is, can I reset? Can I clear? Maybe if I do this and I remove that. So basically, if we were to draw a Cartesian diagram like that, and then let's say you have a bunch of tiles, I'm just gonna copy this. Whoops. Sorry for the poor. And then I'm just gonna copy all of those 3. Whoops. Gonna copy this like that. Okay, let's assume we have a full line. And then we just need to move on back here. So here, if I use it, we had 0. This is pretty thick in width, I guess. What? Okay, this is opacity, sorry. Is there a way to draw small, maybe? All right, that's perfect. All right, so here the x coordinate is 0 at the beginning, at this part. And then here, let's say it becomes, I don't know, 100. So once you know that you need to go back here, you will simply set back x to being 0. But your y is going to be increased by the tile size, so 16. So y is going to be plus 16. So I hope this was clear. Tile pos x equals 0. Tile pos y, though, we're going to add to it the tile, not to string, the tile width. The tile height. The tile height. Even though they're supposed to be the exact same thing in this sprite, in this tile set. And then otherwise, if we're not here, and here we cannot continue. So here we need basically to have a else statement. I could have, it's ironic, I was telling you don't need any else. But I think there's a way to write this logic without an else, but it's just that right now, I don't think we can. Maybe, let me think. Okay. I think we can actually. So if in the case, okay, so we want to do this. We want to increase the number of drawn tiles, plus plus. And then if the tile is equals 0, we want to continue. That means that we don't have a tile to draw. Remember, the 0 number in the array here means an absence of tile, not that we need to draw the 0th, the tile number 0. And here we have the map object. We use the add function to add to this existing game object children, and we use the k.sprite. And we're going to use the assets here. Now I need to explain where do you get this from. We haven't imported our assets into Kaboom yet, loaded our assets. But basically, we're going to load our assets, call it assets as the key, so we know which assets to use, and use as the second param to the sprite component that is offered by Kaboom, an object which can specify the frame property, which allows you to give the exact number of the frame you want to display on the sprite sheet. So tile -1, if you remember, we need to do this because of the fact it's strange that it's tile -1 because yeah, it is over incremented. So the way I did it, yeah, the reason for tile -1 is simply because we need to offset the fact that this tile can be 0. But what I find strange is if I go back to the here it's tile considered tiled 0. But if you subtract, it's going to be -1. Here it's going to be 1. It's going to become tiled 0. But that's because Kaboom itself considers the 0 as a proper tile. So Kaboom numbers their tile starting from 0, while tiled thinks that 0 is empty and the tiles start at 1. So that's why you need to subtract even for the 0th tile. So for example, in Kaboom, not in Kaboom, it should be simple to just understand this. If I look at the ground layer, you see 1 corresponds, okay, this corresponds to 41, 1 corresponds to the first tile. So this exactly is considered as 1, even in tiled, despite the fact that in the ID here is considered 0, which makes no sense. But because of this, you need to subtract 1 minus 1. It's going to be 0 because in Kaboom, when you load the sprite sheet, it starts numbering by 0. It starts with a 0 instead of 1. So that's why you need to do a tile minus 1. So just to recap, Kaboom.js, the way it loads assets, if you load a sprite sheet using the load sprite sheet load sprite function, I'm going to show in a moment, it will divide your tile set, if you do the proper things, into tiles, and those tiles start being numbered with the 0 index. So the topmost tile on your image, on your sprite sheet image, is 0, is numbered as 0 in Kaboom land. In tiled land, it's numbered as 1 in the exported JSON. So that's why you need to do a -1, because in tile, they consider the 0 as the absence of the tile, not the tile, the first tile. Hope this was clear, and let's move on. All right, so we have the sprite asset here. What we need as well is a positional component, k.pos, and we just pass in our vector too, which we created here and modified accordingly here. There's one statement that we need here, but I'm going to put it at the end in order to avoid having an else statement. And then k.offscreen. The off-screen component is from Kaboom, and basically it helps with performance. So when your tile is not visible in the camera, then it's going to be less computationally expensive, because Kaboom is going to do less calculations. For example, not taking into account the collisions, not rendering, not doing any calculations. So those are the 3 components you need. Now, like I said, in case this is wrong, we were basically forced to use an LC, because if we haven't drawn the full line, so it's not the time to move on to a new line, we still need to increment the x-axis to go to the next tile. So that's why we need an else, because otherwise, it would be repetitive to write another if statement, but with the contrary, it would be less good looking code. Now, yeah, it would be less good looking code. Yeah. So I think this is a rare case where I think you need to have the else here. If you in the comment have had time to think about it, maybe you could come up with a way to not have this else, but still keep the logic intact. So feel free to share that with me in the comments. That would be great. By the way, if you are enjoying the content I'm building, the tutorial, please feel free to subscribe for more. It helps out the channel, and even give a like, which would supposedly help the algorithm. So let's continue, and also comment, because commenting also supposedly helps with engagement. But yeah, let's just move on now. All right, let's go back to the world.js file, and here let's call our function that we just created, draw tiles. Now I call it, pass in k, pass in the map object we created here. Now the rest is the layer, so we have it here. And finally the tile width and tile height. Now what it might be repetitive here, so let me just look if we could improve this and not have to do that. Okay, so the tile width and the tile height and the tile width is for the overall map, not just the current layer. That's why we pass them separately. Map data, tile width. Here we go. Now let's look at the result and see if it draws anything. It didn't. JSON unexpected character at line 1 of column 1. Oh, come on. This error is horrible. Okay, I'm just gonna look into it. Oh, it's understood. This doesn't work because we haven't loaded the map yet, with the asset for it. So let's do just that. And I think this is going to make the error fix itself, but I'm not sure because if you've noticed, it was a JSON error, but maybe it will fix it. But let's first fix that. So basically for the assets, you could create a separate function for it, but I don't think it's that necessary for now. Let's just create a kload. Let's use the kload sprite. Use the asset's name. The first param is just a name you want to refer to this sprite, and this is going to be the sprite sheet. So in Kaboom.js, you use load sprite for everything. So for singular sprite, but also sprite sheets. Now you need to put path. So it's going to be slash dot slash. So a relative path is usually preferred. Here's because when you're going to try to host it, if you don't specify a dot, it might cause issues, but you can try it out. Either way, it should technically work, but you never know. Sometimes you have issues like that. I had some issues like that in the past. All right, so here, so the first param is the string, the name you want to use for that asset. The second param is the path towards that asset so that Kaboom can find it. Finally, the third one is the properties. And basically we want to use the slice x property, which is going to be 39, and slice y, which is going to be 31. Okay, this looks like magic numbers, but slice x tells us that there is 39 rows. I think it's rows. If I look it up real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's go at the end. It's, yeah, because we start at 0. If you look at the ID, 0, and then 38. There's 39 because 0 counts as 1. So we have 39 tiles that are, so we have 39 columns. So slice x tells you how many columns there is, even though it's called slice x. It's how many slices you want on the x-axis, basically. So on a given row, how many chops you want. And it's 39. And for slice y, it's 31. This basically allows Kaboom to know what each tile is. So basically, to do a drawing, so that things are understandable, but before doing a drawing, let's first test that this works actually. So refresh, we still have the JSON error. That's very strange. Everything seems to be correct. We have the correct asset path. So I'm gonna console.log the map data and see what I get. So if I go back to the browser tab, refresh, this doesn't even work. Why is that? I think, okay, let's go to main. We pass in the K. We have the world. If I go to world, you have K here. That's very strange. It should work, technically. Maybe I did it wrong. Assets, maps. Oh, I wrote map instead of maps. That's why. So that was a stupid mistake, but hey, it does happen. And you can see our map is actually fully drawn here. So that's a good place to start to stop here. Right before we do that, I'm going to remove the console.log and then draw the diagram just to explain to you how it works. So here again, I need to select all, no, not that. Here, select everything, remove them. Now let's have a grid. So slice X basically tells we have a line, yep. Tells Kaboom how to slice things. How to slicing. Ah, come on, this is tedious. You do this like that. Okay, so basically, here slice X would be 3 because you're making 3 slices. And That's why it's slice X. You're making 3 slices on this row. So you have this row, you have this single, like this row, you make 3 slice in that row. So that's why it's slice X equal 3. And slice Y would be 1. And then the more you add, slice Y, slice Y would be here 3. So now you have slice X 3, slice Y 3. You make 3 slices on the Y axis. That's why it's slice Y. And you make 3 slices on the X axis. That's why it's called slice X. Hope this was clear. Alright, so hopefully I'm going to see you in the next part of this tutorial to continue where we left off and draw start writing the logic for the player and the slime. Once we have everything, the drawing logic for the maps done, then I'm going to swap in the actual final maps I have made, and you can download them in the description. So yeah, thanks for watching. Okay, so like I said, we're going to write the code for the player, to display the slimes. But before just that, let's first try to fix one thing. As you have seen, the map is really small, and we would like to increase the font size. So to do not the font size, the size of the map. And to do something like that, it's as simple as at the end of all this logic that we wrote in world.js, we can simply go here, write k dot, and Kaboom offers the cam scale function that allows you to determine how scaled in or how zoomed in the camera is going to be. So by default, there's already a camera. It's just now you have to control it and apply modifications. So if I just look at the result, you can see that it's blue. There is nothing. If I press F1, that probably means that the map is outside of our viewport. Just to make sure that it's indeed working well, I'm gonna reduce the scale factor by 2. And now if I go back, whoops, still disappearing. Well, that's strange. If I do it 1, I scale it here. All right, yeah, that's exactly that. So if I do 1.5, you'll see that it should technically grow, but it's going to, here we go. It's going to go outside of the viewport. But this is not going to be an issue in the end because we're going to make sure that the camera follows the player. So let's work on the player's code and let's display the player. So first of all, I'm going to go to my entities. I'm going to create a player.js file, and this is where we're going to write all of our player related logic. Now, what does this file is going to contain? Now, you may have noticed that there's a lot of components, the concept of components, and Kaboom.js is really not object-oriented. Now, if you're interested in still using OOP, so object-oriented programming, my previous tutorial where I built a platformer showed you how you could still kind of use object-oriented programming with Kaboom. But Kaboom is really not thought like that. So instead of creating a class that is going to be a player class, and then we're going to do all of our player-related logic like that, what I'm going to do is I'm going to create a function, and I'm going to call it generate player components. So this is a design decision I took, which hopefully we're going to have the best of both worlds. So the best of OOP with the best of just using functions, the simplicity of it. So what does this do is it returns an array of Kaboom components. If you have noticed earlier on, we create game objects by using the add function and passing to it an array of components, of Kaboom components. What we're going to do is the same thing here, but only make a function that generates, so constructs this array of components. So let's first write, so we can reuse those same components if we want to create a new player. So this allows us to have multiple instances because we can just pass in the array of components to the add function and it will create a game object of it out of it. So I'm going to call the sprite function from Kaboom like previously. I'm going to use the asset sprite that we have loaded in main here, if you remember. So for now it's going to load everything, but we're not interested in everything. We just want a specific animation. So in Kaboom.js, you can specify animations within the sprite sheet that you take by using the anim property. Once you have this, you need to, within select a name, you choose a random arbitrary name you want to use for referring to your animation. So here, I'm going to select player idle down. So I want the player that looks down. Okay, so far so good. However, our animation is basically just one frame. We want to, actually we don't need this. We could specify a specific frame that we want to use, but the reason I'm using still the anim object is because it's going to be more maintainable to switch between the various states, the various sprites we want. So the reason I'm doing this, I'm using the assets, the whole sprite sheet, but just selecting the components, the player animation from within is because, as I said earlier on, this asset contains everything. So the character that we are going to use is just down below. So it's just like a tiles. It's still tiles of this same sprite sheet. Now the number that corresponds to idle down is, I think it was 936. Now, this is not arbitrary. The way I got this number is, you know, if you look at the character here, looking down, the ID of it is 936. So this is how. So yeah, one thing that is confusing as well is that, like I said earlier on, when you want to draw the tiles, this is considered 0. And in Kaboom.js, yeah, in the exported version of tiled, so the JSON, this is considered as 1, while here the ID is 0 in the graphical editor. So this is confusing. But Kaboom also uses the 0-based index. So it corresponds to what you see in the graphical editor, but it's not what is exported in the tile.json, in the JSON file, the world.json file. That's why we had to subtract 1 when wanting to draw the tiles in our draw tile function, if you remember. Now here we don't have this issue because we can just tell Kaboom to take this specific frame, and that's why the number will correspond to 936. Does that make sense? Hope it does. And if it doesn't, feel free to ask in the comment section. So we have the player idle down. Okay, that's good. Now we're going to use it. So back to the player code. I'm then going to use the second param of the sprite element. So what it allows you to do here is you could have frame here, but you can also have the anim property and set the animation player idle down. All right, now it's going to display this downward look at facing character that you can see here, which is the player. I hope you can see it, this one. All right, so now that this is done, what we're going to do is we're going to use another component right afterwards called the area components, because we need a hitbox for our player. But this time around, we're going to use the shape property. So the area component in Kaboom.js takes an object with many properties. One of them is the shape property. It allows you to specify the shape of a hitbox. And to do so, you need to call the new keyword, k.rectangle. So we're going to create a rectangular hitbox with first param needs to be its position relative to the player by just passing in vect2, and then we're going to offset this from the player image, player origin, 3 by 3 units to the left and 4 units on the y-axis. So here it is, 3, 4. Now the param that comes afterwards is 10, and I'm going to explain this in an instant, and then 12. So what is this basically? First, it's the position, the relative position. So this position is relative to the player sprite, that is the player game object that is going to be drawn. So this is an offset from that position. 10 is the width of the box, of the rectangle, the hitbox. 10, yeah, and 12 is the height. Now, in game development, I should have done this earlier. tldraw.com. So in game development, in most frameworks and libraries, let's say this is your canvas. This is something I explain in every tutorial. I don't take it for granted because I'm assuming some people don't know this. You have your y-axis and you have your whoops, why is it doing this like that? You have your x-axis. And the way they're positioned this way is because the higher you go down in your canvas, the higher the value of y is, rather than decreasing. So you increase the value of y to go down, while you decrease the value of y to go up. This is counterintuitive if you're used to having your Cartesian product like this, where the y-axis is this one, and the more y is high, the higher the point. So this is just a convention, I think, in game development where it's mostly this. I don't know actually if it's that ubiquitous, but it's something I have noticed in many game making libraries. So hope this made sense. All right, so now we have the area component here. We need something else. We need, let me just look it up. We need the body component. Now the body component basically tells Kaboom to make the game object affected by physics. So collisions, so that your player game object is going to be able to push things around and to be pushed. So that's why you have the body component here. This is what it does basically. Now, if we want later on, we're going to draw some tiles, some tiles, and we're going to add to those objects. I think we're going to add to some hitboxes the body component with an object, and within it the isStatic property. The isStatic property allows you to make sure that this game object will not be affected by any gravity or any collision, so the player cannot push it. So yeah, let me just put it back to body because now we're working on the player. So we don't need this isStatic, but I thought it would be a good idea to explain it right now. The next thing we need is the position. So by simply calling xpos, and here, this is where we're going to just pass the position as a vector2 component. If we were using TypeScript, this would be of the type vector2, like that. But since we're not using TypeScript, this is just written pos, and you see here it's a prime example of why TypeScript is useful. I'm not the one who wrote this code. I don't know what pos is. I could rename it pos vec2, but then again, I'm just putting the type within the variable name. So you can see that having to do this isn't optimal than just having types. So that's a prime example of why types are useful and TypeScript is kind of good. All right, so now I use the opacity component. This is going to be useful. It allows you to control the opacity, which varies between 0 and 1. So by passing in a number here, you'll have an opacity of 0.5, which is going to be midway between 1 and 0, of course. So it's going to be, the player will look a bit faded, but not completely. The reason you need this right now is because later on we're going to write some logic to make sure that the player blinks when he's hit, so that it gives the impression of a hit. Same thing with the slimes and the ghost as well. Now, one thing Kaboom offers is the ability to pass in inside your array of components in object, which is useful for storing data about your instance or your game object. So for example, here, I would like to store the speed of movement. I would like to store the attack power, which determines how strong the player will be when he hits. I would like to have the direction property here. I'm going to set it to down. This is going to be helpful later on to know by which direction the old man should look at you. If you approach him from the left, he should turn towards your side, etc. So that's why it's used here. And is attacking a boolean that basically specifies if the player is attacking. Finally, is frozen. This is useful because I think I might have not used this in the end. Let me just look it up if I used is frozen anywhere in the code base. I think I didn't. Yeah, I didn't. So this is not necessary. The reason I created this is because I want to freeze the player during a cutscene, during a dialogue, or during a certain instance, for example, when transitioning in the dungeon room from the prison cell to where the ghost is. We don't want the player to be able to move during that transition because they can find themselves out of bounds. But to do this, I'm going to store this value inside of our state folder, because it's more of a global thing that it's better to control it from there instead. All right, so now that we have this, one last thing is Kaboom allows you to pass in strings, which are tags. So usually one of them. It allows you to basically mark your game object. So you can get a specific game object by using the k.get and passing in the tag. And then it's going to give you an array of all the objects that have this specific tag. So this is why it's useful. I think I have used, and it's also useful for collision event listeners. So you say on slime collide with this, any object with this tag. So that's why it's useful. So now that we have our generate player component, player components, what we need is, I think for now it's just that. We're going to add a bunch of other methods here later down the line. I think one thing we missed here is to always pass the context, the Kaboom context, so we can have access to all these Kaboom functions. All right. Now, if I go back to our world scene and inside of spawn points, what we're going to do is, let me just go here. Okay, so what we need to do is, since the layer is a spawn point, we're going to simply do an if const object and of layer dot objects. So here we go. Const object what why is it oh yeah sorry, it's a for loop. All right, so our for loop, the reason I can do this now is because since we have made sure that this is a spawn point layer, that means that this is an object layer, and therefore that layers.objects is defined. So that's why we can use this. Now, it makes sense to make this for loop. And then within that, we can just do if. So that's a bit too many ifs. I think it's fine for now, but sure, if it gets deeper, it won't get deeper than that. So if the object dot name is equal to player, then we're going to write the logic to generate the player. And we're going to, at the end of it, continue, because we're going to draw other things that are part of the spawn points layer, which, for example, are the slimes. So this is where our entities.player is going to come into play here. The reason I'm storing this here is because we're going to use the reference to that game object later to do some other things like handle collisions, etc. So that's why it's good to store it here when we create it. So here I'm going to call k.add, and I'm going to call my generate player components, pass in the k here, and pass, let me just remove that. Here for the position, what we can do is we create a vector2, and for the x value, it is provided by the layer, by the, not the layer, the specific object in tile, in the tile export. So object x, object y. Now we have it. So now if I look at world.json, I collapse this as well, and we have the spawn points, and here is the player object, and you can see specific coordinates. All right, now let's look at the result. So I'm gonna go back here, and it's not displaying. Anim not found, player idle down. Okay, that's an issue that we definitely need to fix. I'm gonna go here. Player idle down is defined though, so that's strange. Maybe assets player idle down. Wait a minute. So in main, I have player idle down. So why is it not recognizing it? All right, anim not found. Player idle down. Player idle down. Oh, here. Sorry, another error. It's anims, the anims key, because there are multiple animations that you can put here. So that's why in main.js, when you are first importing your assets in the third param where you specifying slice x, slice y, in the anims, this is multiple anims. Now if I go back, it should work. You see the player is exactly where we wanted them to be. And just to show you the power of tile is if I move it, let's say I move it here, and I save with Control S, and I go back to the browser tab, the player has changed. So this is pretty handy. Now let's fix one thing. Later on I talked about like scaling the camera, and this was tedious because when we did it, we couldn't see the map anymore. What we're going to do now is I'm going to write the logic for the camera in world.js here, not dungeon, sorry. And then here in world.js, I'm going to first set the camera position after scaling it. So this is how you do it. Let's put back the scaling to being 4. And then here, you can use the campause function, again, offered by Kaboom. This is where the reference to the player is going to be useful here. You use entities.player, which gives us the reference to the game object. And here we're just going to do a world position. Now, the reason where you can't do position immediately like that, so by default, when you create a game object, you can usually access the position by just having this. And you can for the player, but remember that the player here is a child of, wait a minute. It needs to be a child of the map, right? Let me just cross-check for a second. Yeah, we need to put this within the map. So the game object, the player game object, instead of being created as a general game object on the canvas, it's going to be created as the child of the map. Let me just look and make sure to, I'm going to comment that out, make sure that it produces the correct output. Yes, the player is in the right position. So in that case, I'm going to do camScale 4. And this is why you cannot use simply.pos, because this position will give you the relative position of the player, a game object, relative to the map, and not the actual position regarding the actual space, the canvas. That's why you need, in this case, to use the world pos function, which is going to translate and give you the actual position of the player, not relative to the map, which is its parent, because we added the map we added the player as a child of the map. So that's why we need this to have the actual general position. Now, if I do this, you can see it looks pretty neat. And yeah, that looks nice. Okay, now that we have there this, why not actually draw the slimes as well? So if object.name equal slime, then entities dot slimes, and because there are many of them, we're gonna push to the slimes array here the various game objects. So like we did with the player, we're just going to, in the entities folder here, I'm going to create a slime.js file. And really, it's going to be the same thing. I'm going to copy this over, but we're going to have to change a couple of components. So instead of calling this generate player components, generate slime components. And here we're going to have to create a new animation. So let me just check that quickly. Slime here. Okay, let's first fill in the slime, generate slime components, and then work on the next thing. All right, work on adding the animation. Okay, so what we do need though is, instead of this time around having an animation here, we could add the frame. Well, actually, I think it's best to start with adding the animation that we need for the slime, and then once we do that, we can continue on. Anyway, we're going to have to add everything else anyway. So let's start with slime down, or slime idle down. So slime idle down, which is going to be a single frame, which was derived in the same way as the player. So slime idle down, it's frame 858. Again, just to show you, it's this one. And if you look at the ID property on the left side where my mouse is, it's here. Okay, now that we have the slime, we can go back to the slime.js and then replace this. Instead of having player idle down, we're going to have slime idle down. Once this is achieved, we can add we need to modify the area component. So instead of having, oh yeah, one thing I forgot to show you is if I go here, you can see the hitbox, right? That's the hitbox we got by using the area component and then offsetting from the point here, which is the origin of the player. So it's going to, it offsetted it by, I think, 3 units to the left and then 4 units to the bottom. So that's just to make it even more clear. I'm going to go back here. I'm going to try to play with the values. What happens if I add 10? If I add 10, you can see it moved 10 on the x-axis from the origin. What happens if I go back to 0, 0? By the way, in Kaboom.js, you can specify the same value for x and y by just passing in one param. And now if you do this, you can see it's now stuck to the origin. I think you get the point now. I'm just going to restore it to how it was, 3, 4. Let's go back to slime. So instead of 3, 4 here, we need 0 and then 6. Same reasoning. And here's 16. The hitbox is going to be 16 by 10. So 16 of width and 10 by height, because the slimes are take more space horizontally and less space vertically, I guess. All right, now once this is done, what we're going to do is we need the body component. It's already there. We need the positional component. We need the opacity as well. And actually, we don't need, one thing we don't need is we don't need the actually we need something else in addition. So we need the off-screen components. So this will allow us to have a more performant game, because Kaboom will stop doing more computation when the slime is not visible in the screen, which will happen when the player moves on to go elsewhere. Not necessarily in a little example, little map, but yeah. And one thing we need as well is, as I said, the opacity, but we also need a, well, actually for now, let's keep it at that. We don't need much more than that. We need, though, to specify the speed as 30. The attack of power is going to be 0.5. So every time it hits the player, it takes 0.5. And one last thing is the slime tag that we need here. All right, so we have everything we need for now, but later on we're going to add some more components here. I'm going to go back to the world. I'm going to go here and type in map, add, and then generate slime components, pass in k, pass in create a vector2, and then pass in object x, and then object dot y. Now, I'm sorry to annoy you with this, but just in case, the reason we need a continue here is that on a specific object, while we're iterating, if the object was a player, there's no point in continuing here. Otherwise, it's going to generate an error. Actually, it might not, because anyway, the name is not going to correspond to the name we were looking for, and therefore it's not going to go in there, but it's useless computation, basically. Instead of having our computer, our browser, the JavaScript executed, it's good to be efficient as efficient as possible, without, of course, impacting the clarity of our code. Well, it depends. Sometimes you have to you have to really go with performance, and sometimes it's better to have clearer code because it's going to be easier to maintain in the future. It's really a trade-off that you have to consider. All right, we have this, I think if I look at, yep, we have our slimes. And now just to showcase that it is indeed updating correctly, I'm going to take the slime spawn point. And by the way, I'm dragging it here like that because I have the select tool. I have selected the correct layer. So I have dragged it here. I save. And then we have the hitbox, and the slime has indeed moved into a different direction. So we're making a lot of progress. So what should we do next? We have multiple options. We could either start drawing the hitboxes. I think that would be good. And then we would swap in the actual real map. And then we would tackle player movement and the rest of the thing. Yeah. So let's go with boundaries. So here, I prefer to create a utility function for this because it's going to be used in basically every map. So here I'm going to, first of all, the name for this is going to be draw boundaries. It makes sense to call it this way. So it's a function, export function, draw boundaries. We need, of course, to pass the context so that we can have access to all the Kaboom related functions. We pass in the map object and the current layer. That's the only three things we need for that. And you're going to see in an instant why. I hope so. I hope so. I wrote my code well. Okay, so you have a for loop, which we're going to iterate over the layer dot objects. So for every object, basically hitbox in the boundaries layer, we're going to add it to our map. And here is where we need to write a function called generate collider box component. And let's do it. Where should we do it? Let me check. We should okay. Let's do it in the utils file, in the same file near it. Generate, instead of player components, it's going to be collider box components. That could be a good name. Collider box components. it takes in k, the context. We're going to also take in the width, the height, the position, and the tag, because sometimes we want certain hitboxes that define the boundaries of our level to have certain specific tags to trigger some things. For example, if we draw a hitbox for the door, we want to give a tag of door so that when the player collides with it, we can write some logic to make the player switch to another scene, let's say the house. So I'm going to do this. So context, width, height of the collider box, the position you want it to have, and the tag. Now here we return. What we're going to return is a k.rect. So you can create a rectangle as I shown earlier. Pass in the width, pass in the height. Realizing this, you could technically there's no need for that. Technically, you could do everything in the area component. So for example, you would, instead of that, let's try it out. I'm going to have an area component. Within, I'm going to have a shape. I'm going to call k.new k.rectangle. Here, we don't want any like relative position. We want to be exactly where the actual box would be created, the game object would be created. We pass in the width, we pass in the height from here. As for the position, we're going to have to do something different here because there is an offset between, for now, let's pass it normally, and then when you'll see that everything is slightly off, we'll come back. Okay? So now I'm going to also use the body, and this is important, and especially the is static property to true, because we want this to be solid and the player to not go past through it, cannot push it, etc. And finally, we needed an off-screen component so that it's going to be performant, and if the collider is not within the screen, the camera, it's not going to have much heavy computation. I'm still not sure how the off-screen works. It's just that I have tried with and without, and there seems to be a good performance improvement. And finally, we pass in the tag, which is the string here that we can just pass into our array of components. All right, now that this is done, let's go back to draw boundaries. Let's call generate collider box components, pass in k, object.x, object.y. As I said, the object contains the x and y coordinates. Oh, whoops, this is not what we want. Sorry, that's absolutely not what we want. It's object.width. So even object.width, object.height. And then here, k.vector2, and then object.x, object.y, and then the tag. Once this is all passed, I'm going to go over each of them. So object width, object height, where does this come from? If I go to, instead of the spawn point layer, I go to the, where is it? It's the last one. Now this is a tile layer. This is a spawn point. The boundaries layer. You can see that each object within has the width and the height of that box. Now, it's not the same with spawn points, because with the spawn points, you don't have this, because we use just a marker, a pin. So the width is 0, the height is 0. All right, now that this is done, now we have this in our utils. I think we're ready to actually use it. Let me just make sure that we haven't forgotten anything. Oh, one thing we want to do is for the tag. So by default, as long as because this is not defined here, as you can see. So there's no params that allows us to have a tag. So what we want to do is just basically pass the object.name as the tag. So if I go to world.json, as you can see, name, not in spawn points, sorry. In boundaries, you can see that there is no name. There is no name, there is no name, there is no name, etc. Except for, yeah, in our current case with our toy map, there is no need for that, but this is how we're going to differentiate between a wall and a door, for example. So later on, we'll have to write some logic within the utils here, object name, to select the name, either pass the name as it is passed, made in tiled, or have a default wall name. But for now, it's not that necessary. Okay, so now that we have this, and we're ready to just simply go back to our world.json, and in there, we're basically just going to call the function. So let's do just that. I'm gonna call the draw boundaries, draw boundaries function. I pass in the k value, the map, the context, the map object that was defined here, if you remember. I'm going to pass as well the layer, which is this. And I think that's it. We don't need anything else. And that's why I put it as a reusable function, because this logic is going to come back over and over again. All right, so now that we have this, something went wrong. Vector2 is not defined. Okay, I know what it is. Let's go back to our utils. k.vector2. I guess it's here. In the generate collider box components, I forgot to add a k here. So this is one of the drawbacks. While using the context like that allows you to have neater code and not name conflicts between, because there are some functions that conflicts with what is in JavaScript somehow. So yeah, that's an advantage, but disadvantage, you can easily forget to add the k before. But as you get used to it, it's pretty easy. And usually you can recognize the error by just looking at, oh, k is undefined. You basically know that there's something missing. Now, to know that we have our hitbox properly, you see, we have them drawn by using the F1 key. You can enter debug mode and see them. But there is one thing. The issue is that they're not, there seems to be an offset. And that's why we need to go back here. We need to especially go back to here and add plus 16. Now, if I go, here we go. Now it's perfectly aligned. I don't know why. I do not know why it is offsetted. I find this very strange. But it seems that there is an offset of one tile, and because our tiles are 16 by 16, it makes no sense. It makes no sense. Or maybe it does. The reason it does is because if you go back to tile, remember that this pin, the player is drawn here, but the origin is here. So by having the hitbox drawn here, it's probably going to draw it. Yeah, it makes no sense. I don't know. I don't know why it is offsetting like that. Let me just check again. If I remove it like this, go back, refresh, for some reason, instead of being here, it's here. So this is definitely something that I don't know why. And I'll just admit it here. I just don't know why it does this. Why the coordinates given by tiled for the object layer where you draw rectangles and hitboxes basically is not one-to-one, as opposed to the spawn points layer where you just used the pins. So this tool, so the insert point instead of the rectangle. All right, if you have any like insight, you found why, feel free to share in the comments as well. All right, now let's go back to our code base, and I think we have everything we need now to actually start working on player movement. Actually, let's swap out the map. Let's swap out the map with the actual map in that I've made originally, and let's see if everything is rendering properly. Just before doing that, making sure everything is correct. That's one thing. Yep, everything is rendering properly. F1, the hitboxes are here as we have defined them. The reason it's you have a rectangle here and it doesn't go all over here is because, remember, we actually draw it this way. Because you shouldn't draw anything not useful, useless. Because if you draw hitboxes that are not needed, you cannot, it will not be useful. It will impact performance. Sorry to ramble here. It will impact performance. So try to draw as the least amount of things possible, and also try to avoid having collisions unnecessary collision as much as possible. So for example, I wouldn't go here and create a box here and then a box here between the two. That would be useless. Okay, now let's swap out with our actual map. So what I'm gonna do is I'm going to call, yeah. So here in the world.json, I'm going to replace it with what I currently have. For you, it should be in the description. So I'm going to replace it. The action is irreversible. Let's do it. Now, if I go here, and here we go. We have our map properly drawn and everything. So in the description, you should find the link to the world map. Copy the JSON. And if I go here, it's this map. It's this map. One thing with Kaboom.js is that you should be very careful when drawing a lot of stuff with it. It does not like performance can be heavily impacted if your scene is too big. So what I would recommend, however, the alternative, I guess, the way to go around that is that you can have a limitless amount of different scenes. It seems you don't have to. You can cut your big scene into chunks and then have them as separate scenes, and then no worries for performance in that case. So that's that. All right. So in the next part of the tutorial, we'll be implementing player movement. And after that player movement, we will implement Slime AI so they move. Finally, we're going to do the dungeon, not the house, and then the old man logic. Once this is done, then we're going to create the dungeons and etc. So there's still some work to be done here. So hope you don't get discouraged, and I hope I was very clear up to this point. So yeah, by the way, I'm hoping that after you finish this tutorial, that you'll have a good base if you want to ever make these types of games for your future project. So I would always recommend that you do your own thing afterwards, modify the project, play with it, modify the code, etc. All right, so in this part of the tutorial, we're going to now work on the player movement so that we can also implement the camera movement stuff and see the rest of the map that we actually displayed here, but we cannot see it completely. So let's work on that. All right, so for this, I'm going to create a function. I'm going to call it, I think I'm going to call it set player movement. So here, I'm going to export function. We don't need the left side for now. But what I'm trying to do here is we have set player movement. And what this is going to take as params is, of course, the context. We need this. And what we need as well is the player object, game object that we're going to pass in here. Now, it's not necessary. Like, you could remove this and use the k.get, but why do this when we can just pass the player object immediately? So in Kaboom.js, you have a lot of event handlers you can use. You have the on key down, on key press. So let's use the on key down. Now in previous tutorials, um, I would just simply create multiple ones for all keys. So in the first param, you would put the key, for example, left, that you want to use. And the second param would be the function that would be called when you're putting this key down. But a more efficient way to do this is to just, there's another form of this on key down function where you just pass in one param, which is the function you want to run. And within it, Kaboom can pass the key, the actual key that is being pressed. To test that everything works all right, let's console.log it. So we have console.log the key. Now, we haven't exported it, we haven't used the setPlayerMovement function yet, so we need to do that. So I'm going to go here, and not here, I think in the world scene that we created, and at the bottom, I'm just gonna do k.set, not k, sorry. I'm gonna import set player movement. This can be imported from where? Yeah, from the player.js. So make sure to import this if it isn't done automatically by VS Code. Here you pass as the first param, like I said, the Kaboom context, and as the second params, the entities.player, so just the player. Once this is done, we can go to the browser tab, open up a dev tool, the console tab. I'm going to refresh this to have the proper aspect ratio. Now, if you press any key, you're going to see that it's going to print it out. And yep, so here. So it works. Now let's go back to the player code. And within the set player movement, we're going to do something else. Now, we just want to implement basic movement for now. And then we'll think about all the edge cases where when the player presses space, for example, to hit with the sword, we want to prevent any other movement so that the player cannot spam attacks while moving and destroy everything in his path. So we're going to need an if statement first. Let's first implement basic movement. So here, I would normally tell you to just do key equal then the key you want. But if you want this to be more adaptable to, for example, various keys. For example, I know that the European keyboard is different. It has a different layout. Instead of the QWERTY layout, I think it has the AZERTY layout. I'm not sure if it's for all of Europe this, but I know for France it is. So WASD is not the same. The W isn't where the W is on the North American keyboard. So that's why I recommend that maybe you do this. So you create an array, you pass in all the keys you want. So here, I'm just going to put left or A, which is going to be like either WASD or the left arrow. And then you use the includes function in JavaScript. And then you do this. So what this thing does, this line does, it checks within this array if the key that is currently being pressed and passed in to the function that we pass in to the on key down event listener is included in this. Now the reason, so Kaboom does this thing, so the on key, Kaboom is the one who passes this param, the key. This is an arbitrary name. You could have decided to name it whatever, like sandwich, and it would still contain the key that is being pressed. Just note that this is just arbitrary. I called it key. All right. So just to make sure, on key down is the event listener. It has two forms. The first form that I shown you that you can use is where you specify the key as the first param, and then you pass a function that is going to be called when this event happens. Now, on the specific keys you have decided. And you can only pass one key. So you could have only done left here. The other option, which I'm currently using, is that we can pass just one param, which is a function that is going to be called whenever this event is occurring. And when you use this form, Kaboom will pass a param to your function. So now we just need to specify that this function that we pass in accepts one param so that you can actually receive the data, which is the key. Like I said, this could have been named anything you'd like. Could have named sandwich, whatever, you decide on the name. Key is the most intuitive. Now, what we're going to do is when this, either the A key or the left key on the layout, for example, is pressed, we're going to flip the player. First, we flip the players by using player.flipx and then setting it to true. Now, why is this necessary? Well, it's necessary because in the sprite sheets, if you go to the top-down asset, you can see here that we're simply going to use one animation, this one. And we just want to flip it when the player goes to the left instead of using this one. Now, this will avoid you a lot of hassle when building the assets, but since these assets are already made, you could have decided to just use this one as well. But just I wanted to show you how to do this in a more efficient manner. So yeah, that's why we flip. So in Kaboom.js, when you have a game object with a sprite that uses the sprite component, I think you need to use the sprite component for this property to be accessible, but I'm not sure. But anyway, the game object that results allows you to have a couple of properties. One of them, those already available properties, is flip X, which flips the player sprite like a mirror. If you say it true, it's going to flip it along the X-axis. If you do set it to false, it's just going to be like the default. The reason you would want to set it to false is that sometimes you want to go back to the original orientation of the image. One other thing is that you can also flip towards the y-axis by using flip y. But this isn't necessary for now. It's not necessary at all for this project. Now we're just going to do the player movement. Later on, I'm going to add a line here just to change the animation. When I say later on, hopefully soon in the tutorial. So here in player move, you see that what the move function is something from Kaboom that is available for game objects that I think have the area component available or the body. I think those two are a requirement. That allows you to move the object. It takes two params. The speed, the X speed, and the Y speed. So if you want to move to the left, you want to specify as the first value a negative. So let's say 100. And as for the y-axis, you do 0. So this code is going to make the player move to the left. Now, we don't want to hard code values here. And since we have used this object in our generate player components and specified the speed property, we can just call it. And any property you pass here is going to be available by doing player dot the name of that property. Now be careful here, because sometimes you might create a property here that will conflict with an already existing Kaboom.js property. And usually you'll get an error in the console for this. So you'll know pretty soon. So here I'm just going to do minus player.speed. That way, if I want to modify the player speed later down the line, I just need to modify it in one place. So that's the best practice here. All right, now that this is done, I will also want to add one thing, is player.direction, and specify that the direction we want to go to is left. The reason I'm keeping track of which direction the player is currently going in is that if you've noticed in the final game, you would be able to approach the old man from any direction, and he will look back at you in the appropriate direction. So, for example, if you approach the old man in the house from behind, he's going to turn around. And to implement something like that, we need to know which direction the player is currently going in when they're going to collide with the old man to start the dialogue. So that's why this is necessary. Now let's look at it. Let's look at it and see if we can actually move leftward. You see we can. Now the camera isn't following us and we're going to have to implement this as well. But for now it moves. So what I'm going to do now is just do the animations. So play the appropriate animations. But to do this, I need to go to main.js, and here in our load sprite, we're gonna need to have the proper animations we want, and we need to add them. And I'm just gonna search for the correct numbers here. So for the idle, for the downward animation, there's 4 frames. If you look at here, you have the numbers for each: 936, 37, 38, 39. If I go back to my code base, I'm going to create a player dot dash, and then the name, I think. What name did I choose for this? So the name I chose for this is, I think, player down, simply player down. And in there, when you want an animation with more than just 1 frame, you have to pass in an object. You have to attach to this key an object. And you have to specify 3 properties. Well, actually 2 are required when you have multiple frames, but the third one is useful. I'm gonna mention it in an instant. So what you need is at 936, this is the starting frame, and if we look at tiled, you can see that here, when I select the first frame, it corresponds to ID of 936. Now the second property you need is the to property, and this property is the final frame, and for our case it's 939. Here again, if I look at it, the last frame is this. I selected it in tile, and it's 939 the ID. So it makes it very easy for you to know which numbers to use compared to if you didn't use tiled. Sorry. The third property is if the animation is going to loop. And we want generally this to happen. We want the animation to loop as long as we're pressing the key down, the key for it. So by default, we play the animation once, we call the animation once, and we let it play until the player decides to either release the key or press another one. So for by default, we're going to put true. Now I'm going to go a bit faster. I'm just going to copy and paste the other animations I have for the movement, the player movement. And then feel free to pause and let me just reformat them. So player idle side. The reason I'm calling it side is because I'm only going to use this one, the left side. And because I'm only going to use the left side, I didn't want to call it left. I want to use both. I mean the right side, the right facing side. So because of that, I'm just gonna call it side instead of using both these and importing these and these separately. So that's why I called it side. And for this is the idle. So the idle is basically just the first frame of the side animation. And here you have the rest. So feel free to copy those animations. Now what we're going to do before playing those animations is I'm going to create a utility function for this that is going to come back, that is going to be used a lot. The reason for this is that we only want to play the animation if it's not already currently playing. And usually it will involve making a check, an if check all the time, and this logic is kind of very repetitive. So by creating just a function we need for it, it's going to make our lives much easier. Now instead of creating it at the end, let's create it at the top. So here, I'm going to call it export. Of course, we need to export it. Play anim if not playing. That would be the name of the function. It's pretty descriptive. I like that, even though it's a bit long. But I rather have very descriptive names than shorter names. And we need to pass in the game object as the first param and the animation name we want to use. as the second. So those are arbitrary names. I thought game object is more general than just player, because this is intended to be used by more than the player, by all entities, and entities in Kaboom.js are usually game objects. So the slime is going to be a game object, the player is a game object, and the ghost later on is going to also be a game object, and the old man that talks to you is also a game object. So having all of this, let's write the actual body of the code. So I'm gonna have an if statement, and what you do is you can call the game object, and every game object that has a sprite attached to it, so that uses the sprite component, can also use, it makes available for you the cur_anim function. Now, if you're the maintainer of Kaboom, the creator of Kaboom, watching this, I'm not sure if having the sprite component is a requirement for this to be available at all, but it makes sense to be. So that, sorry if I made any assumptions that shouldn't be made. All right. Now I'm going to, in this if statement, we're just going to check if it's not equal to the current to the animation we want to play, because why play the same animation twice? And it's going to interfere, because if you're playing an animation already and it's at frame, for example, 4 of 6, you don't want to restart it. It's going to make your game look very weird. So now inside this if statement, I don't think you even need the brackets, because there's only, we can write this logic in one line. We're gonna have game object dot play, which is the function used to play animations in Kaboom, and you just pass in the anim name, which is a string. So this is how it looks like. Looks pretty simple to me. You just check if the current animation is not the actual animation you want to actually play right now, and if it isn't, then you actually play the animation. So that's very simple. Now let's go back to our player.js code and add this function. So play anim if not playing, and then in there we just pass in the player, and here for the left key, for the left movement, we're just gonna use the name that we've defined in our main. If you remembered, we had player side as the animation, and this is what we're going to use. So I want to play the player side animation, and since player side animation is by default facing rightwards, by having called the flip x true, it's going to flip it to look to the left, and that's why we don't need to use both the right side and the left side here. Hope this makes sense. Now that this is done, player.flipx equal true, player if anim not playing true, it is going to play the animation if it's not already playing. Let's check it out. There's a mistake. Okay, that's because this is a MIME type error that I've mentioned previously that you get if you forget to have, or VS Code doesn't add the .js extension to the import statement you're trying to use. So that's only applicable if you're using a basic HTML JavaScript setup without any bundlers. All right, so now that this is done, let's go to the left. And yes, it works. Now you can see that the animation is not stopping, but we're going to deal with this later on. So now let's work on the other animations, the other movement. So we want that after having done all this logic, we just return early, because we're going to simply check for the other keys. So why bother continuing if a key is already pressed? And this is useful to avoid when the player is pressing 2 keys at the same time, to actually try to conflict and play both animations or one animation right after, and it's going to look weird. So by making sure that, hey, I only check for the first key that is pressed here, and I do just the logic for it. All right, now the next step here is basically the same thing. I'm going to do it with you here, and then later on, I think if it gets too repetitive, I'm gonna just copy and paste, or I don't think it's going to get too repetitive because I usually try to make reusable blocks in that case. So let's continue on. So here we're gonna use the exact same pattern. of using an array and then an include. And here we're just going to pass in the right string, and the key also is D for WASD, and then we check if the key is included. If it's the case, here it's important to make sure to put flip x back to false. Because if, for example, the player has pressed the left key, is holding it down, not pressed, but holding it down, this is going to be set to true, and that means the next time you're going to press another key, this is still true, so the player sprite is still flipped, so you have to flip it back when you press the actual key, the right key, even though by default the sprite, the animation for player side movement is facing rightward. Even though it's the case, it's not going to, the flip value is not going to go back to the original if you set it using the flip x property. Alright, so now I'm just going to call it play anim if not playing. Same thing, we'll pass the player, and then here player side as well. So this is repetitive, but it's not too repetitive to warrant an abstraction. There's often times where I saw some repetition, like let's say 2 or 3 times, and tried to create a reusable function, but this locked me into an abstraction that afterwards I realized wasn't fit, because in the situation that looked repetitive, it actually wasn't. It was repetitive, but there are some particularities and made it that it needed to be treated as its own special case. But now that it was locked into this abstraction, it was painful to make the changes I need. So that's something to be very careful when you code, is that truly determine carefully when to make an abstraction to avoid repetitive code. All right, so let's move on. I'm gonna use player movement here instead, just player speed, and then 0, and finally the player direction. So player dot direction, and then put it the right direction. You could transform this into a function, a single function here that you would use for both right and left, but since this situation doesn't come again that much, it will come, but for up and down, but it's different because now you need to edit this instead. So it might be just not worth it to have a reusable function here. All right, so now let's test it out. I can move left, I can move right, but as you see, the animation is not stopping. We're gonna fix that later. All right, so now is the time to work on the up and down animations. And for this, I'm just gonna copy the code for it to go faster, and feel free to pause and copy it. So I'm gonna go over it. So we have this same pattern, we have this, so I'm just gonna add a second key just to show you. Up and W, and down and S for WASD. ASD. All right, so we call this, we move, and so we put the player up animation that we imported in main here, and player down, we already had it here. So we played the player up. There's no need to flip anything because we have both animations separate. Separate animations for each. So player up, player down. Now we have player move, where this time around the y-axis. So then again, if you remember previously in the canvas, the more you reduce the value of y, the more you go up, while it's the contrary. If you want to go down, you increase the value of y, which is strange because it's not what you're probably used to in math. But I've already explained this earlier on, so hopefully it's understood by then that this seems to be a convention in game dev. Yeah, it's using if this is the Cartesian plane, it seems that in game dev we use this one, or not even. It's just strange. It's strange to me. It's not that intuitive why it was decided that this was appropriate. Maybe there's some technical explanation for it. If you're familiar, with the reason why in graphics programming, oftentimes the coordinate system is like that, feel free to chime in a comment. I would really appreciate it, and it would expand my knowledge as well. Like I said in those tutorial, I'm not an expert on everything, but yeah, so I'm willing to learn from any sources. Like I don't think I'm above learning. All right, so now we have up, down, right, left, everything is there. Let's look at the output. Here, 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 and here. But as I said, it doesn't stop the animation when you actually stop pressing any keys. One thing I need to, maybe you didn't have time to copy the code, so here again, some time, press pause here. All right. Let's try now to actually for stopping the animation. So now outside of this function, so outside of this on key down event listener and the function, the anonymous arrow function that we've passed in, we can use key on key release, which is another event. And here we don't really need to pass in the key. We don't care, basically. You could have that. You pass in the key and it's going to give you the exact key that is being released. What we just want to do is call the player object and use the stop function. So stop function is provided by Kaboom on a game object that uses the sprite component, I think. And it basically stops any ongoing animations. So now if we go here, you can see that you can move down, you can move left, and when you stop holding, but for now there is this this thing that we're going to need to modify. Wee looks fun. It looks kind of fun. Not gonna lie. All right, so here, and as you can see, we can pass behind the tree. If you remember, we put this part at the topmost layer, so that's why this is possible. And the tree here is at the, because of the collider, you cannot go past it, so it gives you the impression, the illusion that this is like a 3D scene, I guess, and you can pass behind the scene, like an illusion of the Z-axis, basically. All right, so now that this is done, what you're going to do now is basically let's implement the camera in world.js. As you have seen already, we have the cam scale, you have the initial cam position that is set, but we want it to follow the player. Now for this to happen, we need to write some logic in an update loop. So Kaboom.js offers you a bunch of abstraction, event listeners, function, etc., but you can still use the main event loop, the loop that is run on every frame. And this is useful in certain situations. And if you come from various other libraries, it's usually they give you an update function and a draw function, and then you need to put your logic there to draw at everything, at every frame what you want. In Kaboom, it's not necessary to do this all the time. You can just, when you need it, call the onUpdate function. And this onUpdate just adds the function you pass in to the update loop. So you can call it multiple times in multiple different places, and it doesn't hurt, basically. It doesn't cause any issues. All right, so now here we want to use an async function. The reason we're going to use an async function is because we want the camera to tween. That means to follow the player, but not exactly. So it's lagging behind a small bit, but then catching up. And this gives a smooth movement to the player. In this update loop that is run every frame, I'm going to check if my entities.player.position is position.distance. So there is this distance function that is provided by Kaboom if you use the positional component. So already, if you use the pause component when creating your game object, you have access to the pause property that gives you access to the position of the property of the player of the game object, which you can do pause.x, pause.y to have the specific x and y coordinates. Now you can also use the dist function, which will calculate the distance between this and what we want is the current cam position. And to have this, you just call k.campause. We set initially the cam pause to the world position of the player, I already explained why we did this. Just to reiterate is because the player is a child object, a child game object added to the map and not to the general canvas. That means its position is relative to that parent. By calling the world pos function, we want to get the actual position on the canvas regardless of the parent. That's why we call the world pos function here. And this, yeah, so this is it. And now here, as I've understood it, it seems to be that, and it makes sense. So here, await, we're gonna use the await keyword. That's why we call the async function, because to tween, what we want, the reason we want an await keyword is going to be apparent in a moment. I'm gonna explain it. Is basically we don't want, we don't want to. Actually, I think it could work without. Let's first write the tween. I'll explain why I put the await here, or maybe we'll try without. If it works without any issues, then that means that this was useless. There's no need to explain it. All right. So the tween function takes 1, 2, 3, 4, 5 params. It takes five params. 5 params. The initial position of the thing you want, the camera here. The second param is the target position of the camera. So here are actually, don't think in terms of position of who. This is the initial point you want to start with. It can be positions, but it could be any value. You want the original value, the starting value, and this is the end value you want to reach. So that's what these two params are about. So first param is the initial value. The second param is the target value. And then the third param is going to be in how much time you want it to reach the final value from the starting value. And then the fourth param is going to be the function that is going to update the position of the camera to fit with this progression, this up until the target value. It makes no sense here, maybe, but let's continue on, and it's going to be more apparent. So here, the initial position of our camera, we can get it with cam pos. So it's going to give us a vector2, and it's going to be the starting value. Entities.player.worldPos is going to also give us a vector2, which corresponds to the current position of the player on the canvas, the actual world. So, and finally, we want to reach the target value in 0.15 seconds. And here is the most important part, is the function that is going to be called at every, I don't know the rate of how this is called, but basically it gives you all the intermediate values. So this is an intermediate value between the initial position and the final position. And you use this value to set it up, to set it to the cam position here, in this case. Cam pos new, not new, value. I think well, you can call, just to make it more descriptive, new position. I'm going to call it this way. And we're going to set this new position to the cam pos. And then finally, you want the function, the 1, 2, 3, 4. The fifth param is actually the type of easing function we want to use. And this, we're just going to use a linear function. So the rate of change between the starting position and the final position is the same. Not the same, is constant, is linear. So it follows a linear function. That means here, let's make a diagram for you to understand properly. Let's say we have this is our x-axis. This is our y-axis. And I'm just going to use a drawing tool. Yeah. So linear is this. Actually, this would be best with okay, so this would be best with just a line. Maybe, can I select a different? All right, this line. So that's what? That's not what I want. I want this. I want the line to be continuous. Well, it doesn't want to let me. So imagine just this is just a linear curve. So as the value of time passes, the actual value or the new position value that we pass in the function is going to be a different value each time until it reaches the target value. This is the target pause. This progression is different if you use a different easing function, like I don't know, you could have this, you could have various different functions, but for now we're just going to use, for this project, we're just going to use linear. So to recap, this is a default position. For now, it doesn't have, we don't, in those two params, we don't update the camera position at all. We just get the current camera position, we get a target position, could have been anything, but we want to follow the player, so we want to get the actual current position of the player. We want this value to go to this value in 0.15 seconds. This is the function that is called every frame or not, that gives you a new position, and it's an intermediate position between this, and it changes along by following a linear function. So when this is called first, let's say this starts at the same value as camPause. The next time that this function is called is going to be this plus a certain value, and then plus a certain value next time around, and this is going to change gradually until it reaches the target value. Hope this was clear. Now that this is done, I think we have everything. And now if I move, you see how smooth this is? The camera follows you just a bit. And now we can walk around the whole map. Looks pretty nice. And now, okay, that's it. That's just a trick. One thing as well that we did is you can pass behind. This is achievable because if I go to the tiled file, take some time to look at the various layers, and you have in upmost, I've put the behind of the castle to be in that layer so that the player can be drawn below it and pass it. Yeah. So the order of the layers here is important. It's going to determine when a layer is going to be drawn, so be careful about that. Here I added a couple of like tags. So here player dungeon is a spawn point that we're going to use to spawn the player outside of the dungeon. For example, when the player enters in and then wants to go back, we don't want to spawn him back here, which is the initial player spawning point, but right outside. Hope that makes sense. All right, I think that's basically it for this part of the tutorial. And oh yeah, one thing I need to explain is why we need the weight here. So let's remove it and see if there's any difference. Because let's first try and then. All right, it seems that it's unnecessary at all. We don't need it at all. So this was probably something I initially put because with async await, what's cool is that if you want to make sure that the tween happens first before the rest of the logic you write here proceeds on, it's good to use await. So it basically stops this from, because if you just call it like that, this is going to be called and starts changing the value, but the code will not wait for this to finish, the tweening to finish, before continuing on with the logic that comes here. So in the case where you really want to have things sequentially, where you want this to finish first before moving on, then it's useful to use the await keyword. That's why it's called await. You're waiting for this to finish. This asynchronous code to finish. So asynchronous code means this code could proceed on while, well, asynchronous doesn't mean that, but in this, like practically in this example, K-tween is asynchronous in the sense that it's going to be run while you continue on with your logic here. So by using await keyword, it stops from moving on until this is finished. Hope this was clear. And then I'm going to remove the async keyword as well because it's not needed. And I think that's it. I don't think we're going to add any logic after it, so that's why here in this particular case, a wait and a sync is not necessary. All right, so I'm hoping in the next part of the tutorial to, I think maybe we're gonna start working on the attack animations on the player, or maybe you could start with working with a slime AI. So there's a bunch of things that are still left to do. So let's continue on with the player movement. So what I want to do in this part of the tutorial is that in the previous we basically wrote the logic for moving the character in 4 directions. Now what we need to do is actually make sure that the player cannot move in diagonals. Otherwise, I'm not sure if it's here. Yeah. So we want to prevent the player, to be from moving like that. I know it's very fun to look at, but it's a bug, so we need to fix it. And to fix that, we're going to create a utility function in our utils folder file, sorry, utils.js. Now here in the utils.js, I'm going to create a function. I'm going to call it are any of those keys. So yeah, let's put it right below here. Export function, and then are any of these keys pressed, or down. I think down would be appropriate. Yeah, more appropriate because we're using. Oh, yeah. So the reason this would be more appropriate is because here we're using in the player code, we're using the on key down event listener. And what we want to do is have a check when we enter the if statement, whatever not the any of the other keys are pressed, so that we can prevent some movement, some diagonal movement. So basically we need 2 params here. As always, we need to pass the context because we're going to use some Kaboom related functions. And then the second param is going to be an array that contains the keys. Here again, this is where, again, something like TypeScript is very useful, because here you don't know what the type of this is. You don't know if it's an array by just looking at it. So if we were using TypeScript, that would be made pretty obvious. Yeah, so I'm not gonna write TypeScript here, but you know, you get the point. Or maybe this, like that. So if you're interested that I make tutorials in TypeScript, feel free to comment that, and I'm gonna consider making my next projects maybe in TypeScript. It's not that hard to learn if you know JavaScript, but yeah, so. And then within this function, what we're going to do is go iterate through all of those keys by using const key of keys, the off loop in JavaScript. Just in case you're not familiar with this, loop is basically the off keywords allows you to iterate over all elements of an array. So this is actually the element. Now, if you were to use in, this will not work because this gives you the keys of an object if this was an object. So it's not like in Python where the in keyword is used for the for loop. So I like using the off loop because it's easier to write than the traditional for loop with the const I equals 0, a semicolon I plus plus, and then semicolon I, it's I inferior to something, and then semicolon I plus plus, etc. Now here, what we're going to do is we're simply going to use the is key down function from Kaboom and then pass in the key. As soon as we find one key that is down, we will return true, because the goal of this function is to check if any of the keys passed into the array is true. And then finally, if after iterating through all of the array, no keys were found to be down, then we just return false. All right, so now let's use this in our player code, and where we're going to put it is in I think two places. Yep, here. So maybe either we added this as a second condition, or okay, yeah, we could add this as a second condition. So this should be and then here we're gonna use the bang sign to make sure that are any of these keys down. We make sure this is imported up above. And then we want to pass the context, and the keys we want to exclude that we don't want to be pressed, to be down while the left or A key is pressed are the following. We don't want up, we don't want down. And I think that's it. Otherwise, if we allow up and down, yeah, but since we're also using other keys, so we're using, not only are we using up and down, but we're using W, and what else? And S. So we want to make sure that when the key left or A is being pressed, the keys up, down, W, and S are not pressed. This will prevent diagonal movement when pressing the left key and either up or down. Now this, we need to replicate this logic and put it also for the right. So something like that. And then I think that's basically it. We don't need anything else. Yeah, I think this should do the trick. Now if I look at the output, you can see that even though I'm pressing both left and up and right and down, it's not moving in diagonals anymore. So yeah, that's pretty cool. So it gives a grid-like movement to the player. All right, now that this is done, now that this is done, what we're going to do now is I have two options basically. Either we could work on the logic for the sword, but maybe later on. We should work on that when the player is talking to the old man. So what I can do is, let's start with the slime AI. I think this would be easier. So let's go to slime.js. Right below, we're going to create another exported function. I'm going to call it set slime AI. Once this is done, I'm going to, in the slime AI logic, we need first of all to think of two things, the params. So which param we need? Of course, we need the context, and we need the actual slime to apply this to. Once we have this done, I'm going to create a state machine. So a state machine is really the way AI is done, basically. If I'm going to do just a quick schematic on tldraw.com, I don't need this. Sorry, that's a little drawing I made. If I clear this, all right, clear this. Okay, so how is AI programmed? So mostly it's done using finite state machines. And finite state machines, the way they work is, let me try to pick a circle. Do we have a circle? So you have a bunch of states. So let's say this is a state. I'm going to copy it over. This is another state. And let's copy this over. And this is another state. So we have three states. Let's call this state the idle state. Let's call this state the alert state. And then let's call this state the move state. Now these states are probably not the ones we're going to use for the slime AI, but just to illustrate the point. The way a state machine works is that we have a condition. So initially we always start by entering the state machine by the default state. So here we set the default state. I don't know why it's not letting me draw it further. Let's keep it that way. So we enter the default state. By default, we are in idle. Now you write some logic in that state. So while we are in this state, if, for example, the player is close enough to us, so you make a calculation and you determine that, hey, the slime is close enough to the player, then you move on to the alert state that you've defined. So you call a function that will change the state of your AI, or your slime AI, to move on to the alert state. Now the alert state, when it enters the alert state, you define some logic that is going to be run on each of those states. So on idle, you have some logic that is run when you are in idle. On alert, the same thing, and then on move, the same thing. Let's assume, for example, that on alert, you start moving towards the player. So you write the logic for this, and during alert, it basically tries to follow, the AI will try to follow the player. Now, if the player is too far, so let's say you recalculate every time you move the distance between you and the player, and for some value, you consider that the player is too far, then you move on. You call the function to a function to move to the next state. And here, well, actually, it doesn't make sense. Alert, move. Okay, let's say we have only two states for this to make sense. Ignore this one. So here, once you have calculated that the player is far enough, you go back to the idle state. And this is how a basic AI works. Now let's implement it. And let me also return. Okay, now let's implement it. So here, we're going to create a bunch of state. Let's create our idle state. So the way you create a state in Kaboom is you take your game object, and first of all, one thing is, in our generate slime components, you need to pass in the state component. And here, the state component takes two params. The first one is the default state you want to use, and the second one is an array containing all of your states. Did I do? Oh, okay. Let's remove this so that there's proper formatting. This is going to contain all of your states. Now, for this particular project, I think I don't need to put it outside. Give me a second. Okay, yeah. So I will create a constant outside. So one drawback of this, of the property, is that you cannot reference them within the array of components. So for example, you cannot create a property here. So let's assume I added this component after having my properties, and I wanted to have all my states listed here. So slime states, and have the array here that I reference. In fact, I think maybe you could have access to the general state object from within. So never mind. What? Sorry if I'm rambling. I'm gonna make this things clearer in an instant. So let's go here. Let's first enter the state we need. So we need the idle state, of course. The reason I'm mentioning it twice is that this just tells you which state to call initially, while this is all the possible states you need to specify. So you have the idle state. We also have the left state. So when we want the player to move left, the slime to move left. When we want the slime to move right. When we want the slime to move up, and when we want the slime to move down. Those are the name of the various states we're going to use. So the slime AI is just going to be very dumb. It just moves randomly. So, and when it collides, it just selects a new random direction and moves to that direction. As for the following the player, etc., we're going to keep that for the ghost boss. I think, yeah. So just to not overcomplicate things. And yeah, and of course those slimes, they don't look like enemies, so it makes less sense to have them like follow you and try to destroy you. But anyway, so in the set slime AI function, now that I have my state defined here, what I'm going to do is, for now, I'm just going to console.log the slime And that's the states use. Maybe I can have access to all states here. You're gonna understand in an instant why I'm doing this. Now let's import this in the the world.js file, where we have, okay, so right below here at line 75. So does it make sense? Okay, yeah. So a little bit further down the line. So what I'm planning to do is to call all the related logic to the player here, and then below to the slime. I'm going to iterate through the slimes of entities dot slimes. If you remember, this comes from the entities object we have created that had the slime property that is an empty array initially. So once this is done, so now in this for loop that I'm creating, I'm just gonna call set slime AI, import it from the slime from the slime.js file. Here it is. Don't forget to import it if VS Code hasn't done this automatically for you. And then I do k, pass the context, and then the slime. Now let's look at the output. Okay, this is undefined, unfortunately. So I'm trying to figure out live if there is give me a sec. Okay. Okay, let's go back to slime.js. I'm just gonna print the whole object itself. So now let's look at the first one. And we have, what do we have? Do we have a static on? That's not what I'm looking for. Opacity, parent, screen, state. We have the current state, which is idle. But do we have a way of having all of the states? I don't think we have get. Maybe get states. Do we have this? Set state, get state. We have a getter, but we don't have something to get all of these states, it seems. That's why we have to take this, take these four states, and outside, unfortunately, create a constant. I'm going to call it directional states, and I'm going to create an array and call it there. And I'm also going to go here, remove that, use the spread operator and reference. So the reason I'm using the spread operator is it's going to spread over, so take every elements of the array here and append them to this current array. So now that we will only have one array that has idle, left, right, up, down here at the same level, just in case you weren't familiar with the spread operator. Now, I didn't want to do this because the reason I'm doing this is that we're going to need later on to select a random state, a random direction to move. And as you have seen, it seems that Kaboom.js doesn't offer you the ability to just check what are all the states available. You can only check what the current state is with the state property. I would have preferred to specify those directional states within the object here, but unfortunately you cannot call it. You cannot call it. You cannot call. You cannot reference a property here inside of what comes later. That's why if I were to do this here, if let's say I declared the k state after the properties and would have a directional state and then pass in the various up, down, left, and then right, and just put here, I cannot do slime this because it's not defined. It's not defined, and you cannot use this as well. So that's why it becomes pointless to do such a thing. Unfortunately, it would be nice. In object-oriented programming, if you were using a class, it would be possible to declare your properties and then reference them inside the same constructor. but unfortunately cannot do that here. All right, it's not that big of a deal, but yeah, it's definitely something I would have hoped to be able to do. Now I'm gonna just put this directional states. All right, now that we have this, we can start defining our various states, and it's gonna be a bit long. So what I'm going to do is let's first start with defining an idle state. So to declare an event listener on a given state, you do slime on state enter. You specify the state and then the function you want to call. Now what I'm doing here is I'm keeping a reference to the resulting event listener, so I can cancel it afterwards. The reason you want to cancel it is we want to cancel all state events listener once the player quits the scene and goes to another scene. Because what I've realized in the previous tutorial where I was making a platformer is that those states keep on going even though you are on a different scene. So this sounds like a bug, and I think it's a bug. And where this becomes an issue is when you have sound playing within a state. So you call the play function to play some sound. It's going to do it even though you are on a different scene. And that's why I prefer not from now on to put a reference to the event listener and then cancel it on scene leave, so that I'm pretty much sure that no leftover state event listener are there. And of course, I think it makes things more performant as well, since we are removing any unneeded calculations and yep, and code running. So just to do it, to not forget to do it later on, I'm just gonna call the onScene leave function. This onScene leave function is going to take a function that is going to be called when the scene leaves. It's an error function, as you have seen here. And then you can just call the reference idle, and it should have the cancel function method that you can call, and it will cancel this, destroy it basically. All right, so let's create all of our various states we need, and then we will fill each one of them. So the second state we need is the write state. Slime on state enter right here, and then the function. And then here I'm going to, yeah, later down the line write the code, but below we're just gonna cancel it on scene leave. I'm just gonna copy this over for down, up, and I think that's it. I think that's it. Yep, that's it. And we can just do a, oh, we have left, of course. So right, left, up, and then down. So let's modify the string, left, up, down. Now let's call the cancel on each of those. So up, cancel, down, cancel as well. So right, left, up, down, we cancel all of these. All right, so now that we have this, let's start with the logic we're going to need for the idle state. So when we enter the idle state, what we want is that we want to stop any animation of the slime. So we can do this with the stop call that you have seen in the player code, if you remember, that we did here, to stop the animation of the player once any of the keys, the movement keys are released. Or any key, when any key is released, actually. Not just movement keys. Even when later on we're going to hopefully implement the sword striking animation, it's also going to stop when you release the button for that. Okay, so we stop, and then what we want to do is we want to await using the wait function in Kaboom.js for 3 seconds. Here we're going to need async. The reason I need a wait here is because I don't want my code to proceed on to what comes next with it, which is we want to enter state. So the enter state method, we can call it to go on, to move on to another state. And here is where it comes in handy to have the array with all the directional states, because we want to select a random state. We could do math floor, then math.random, and then we multiply that. I'm going to explain everything in a second, so don't worry. Directional states.length. All right, so what does this code do? Basically, math.random is a function available in JavaScript. So this is JavaScript knowledge that randomly gives you a number between 0 and 1. You multiply it by the length of the directional states array, so your 4 states. And this is going to generate a value that is going to be superior to 1 because of this, but it's still a decimal. And that's why we floor it to have an integer. And this integer will always correspond to an element of the array direction, the index of a directional array, a directional state element. So this allows us to have a random index amongst the 4 0, 1, 2, 3, 0, 1, 2, 3 possible indexes, because we multiplied by the directional states.length, the math.random function. So 0 0.1, 0 from 0 to 1 multiplied by the integer here. In this case, it's 4 states. So 4 multiplied, let's say, by 0 0.5, it's going to give us 4. It's going to give us 2. In this case, we don't need to floor it, but let's say you had 0 0.25 multiplied by 4. It's going to be 1. Let's say you had 27 multiplied by 4. It's going to be 1.08. So imagine, because this is random, a random number between 0 and 1, it could be 0 0.27. And if you multiply by this, which we have 4 elements, so this is equal to 4. So 4 times 0 0.27 is 1.08. Well, this cannot work as an index. We need an integer, and that's why you use the math floor, which will floor the number to the closest integer that is inferior to the value that we currently have. Hope this explanation was clear. So this is going to run after waiting for 3 seconds. Now, if we were to remove the await keyword, it would run this, but we could still move on to this because this is asynchronous. Because by the wait function in Kaboom.js normally takes 2 params, one which is a function that is going to be called after 3 seconds has elapsed. So yeah, but because we aren't using this form of the function, we're just using it as a way to make things stop for a while. It's important to use await, otherwise the code execution of the function will continue to this. So it's going to enter the next state before having waited 3 seconds, even though this function is still running and will resume, like still running for waiting for 3 seconds. Hope this was clear. Await basically allows us to take asynchronous code, so code that is supposed to be executed while you're doing other things, and making it sequential, so one after the other in a given async function. So that's why it's a powerful keyword, and this is why it's called await. You await. You want to wait for this to finish before you move on to the next thing. Hope that was clear. Okay, now that we have done this, we can move on to the next state. So the next state is going to be the right state. And here we want to first make sure that the flip value of the slime is going to be false. Here again, we're going to use the same trick to move the slime, to change the animation of the slime, to move it from the left to the side, to the left and the right. If I go back to the tile editor, you can see that we only have, for this time around, well, actually we have both direction, but we're only going to use the right direction and then just flip it instead of having to call this second direction the right one, the left one, sorry. So one thing before we continue, I just realized that we need to go back to main.js and import the necessary and define the necessary animation, not import them. So let's do that real quick. Okay, so what we're going to do is I'm going to, again, because this is repetitive and I think by now you have gotten the point, I'm just going to copy and paste the code here. Here's nothing new, just the numbers. And as I said, to figure those out, you go to tile, you select a given tile, and the ID gives you the frame number. Hope that was clear. So slime idle down is the first frame of this, and then from to we loop, as I said, etc. Okay, now that we have all of our slimes animation, we go back to slime.js, and then in the right state, what we're going to do is what are we going to do? We're going to play anim if not playing. And this the animation we want to play, of course, is first we pass in the slime game object, and here it's slime side, I think. Let me just slime side. What? Yes, this is exactly what we want. Okay, now that we have this, we are again using the same trick. We're gonna await k.wait 3 seconds before moving on to the next state. So that means that this should be asynchronous. And then we're going to move on to the next. Now, here I'm purposefully not writing the logic to account for collisions, so that if the slime collides with something, with the boundaries, they move to another direction. So they don't keep moving in place. Now, the next state we want to go here, we're going to decide. So here we always go back to idle after having done some movement in those states. So idle is really the centerpiece. We idle selects the next state. It goes to that state, does what it needs to do, and then goes back to idle, and then this will choose another state, and probably it can even probably choose the same again twice, so that the slime will move right twice. Sometimes it will move right and then left. Sometimes it's going to move left, and then etc. Now here you may have noticed that we wrote none of the logic to move the actual player slime, because it's more efficient. It's not more efficient, but we want to be able to use the move function, and you cannot really use it on state enter on this, because the move function really runs as long as the update as the action is called. Here we only call on state enter once when we enter that state. That means that if you try to use slime.move, it's just going to move for maybe a frame and then stop. So to fix this, you have two options. Either you're going to use tweens, where you can decide the timing of a given value. So from a initial point to the target value, and this could be the initial position of the slime to the target the position you want it to have. But the issue with tweens here for this movement is that it will ignore collisions. So for example, if you want your slime to move from point A to point B, and you use a tween for that, if there is a bush between the two or a tree, it's going to move past it. It won't care, regardless of collisions. So to fix this, we're going to call the onUpdate function, which takes a function, and then we're going to use a switch case statement, and the onUpdate is called as long as it's called on every frame. So basically the idea behind what I'm going to do here is that as long as we are in a given state, for example, as long as we are on the right state, we will call slime.move with the corresponding value, so that the slime starts moving to the right and continues moving to the right as long as the state is right. All right. So to do this, I said right a lot. All right. To do this, I'm going to use a switch case statement because it's going to make our code more concise. And we're going to pass in the slime.state. So Kaboom.js allows you to, on the resulting game object, to have access to the state property, which gives you the string that corresponds to the current state. Now here, we're gonna just have a case, the case when the state slime.state is equal to right. And here, we're gonna call slime.move, slime.speed, exactly the same pattern we used previously. We have defined the speed here, and so that we can modify its value without having to modify it in multiple places. And here for the x-axis, it's going to be the y-axis is going to be 0. We only move on the x-axis with this speed. And then, of course, with switch case statements, it's important to put the break here because by default, case will continue evaluating the rest. So, for example, if you don't put this, it's going to go here, and then it's going to evaluate the next, and evaluate the next, etc., until there is a break or it arrives to the default. That's something you need to keep aware of. And for now, it's not a big deal because anyway, slime state will never change during a given call to this function. On the same call, it's going to change on the next call, so it doesn't matter, but you're executing a bunch of code that does not need to be executed. Hope that was clear. Now we're going to do the same for the left, etc. So here I'm just going to copy paste to go fast. And wait, here we go. So that's the rest. So minus to move to the left. Here we put this on the second param because this is going to move on the y-axis. This is also going to move on the y-axis. Remember, in game development, to go up, you need to subtract to the y-axis, not increase. That's why this is minus, and you go down by increasing, which is something that is counterintuitive. Okay, and then for the default state, we don't really need that, so you just call it empty. You need an empty default state, like that, default case. Now that this is done, we can continue on the logic for all of these, and it's going to look very similar to this. In fact, it's going to be almost exactly the same. So except for the flip value, which is going to become true for left. So if I put it here and then put that to true, and then here it's the same. So this logic is repeated twice. Don't forget to transform this to an async function. And I think that's yeah, now we can, for the up and down, exactly the same thing as again. So I'm noticing that things are getting pretty familiar, pretty similar. So we can create a reusable function. Give me a second. Okay, so we wait and then we enter the next state. Now, this may be too early to modify, to abstract away. This is the case where I think it's fair to wait. Even though we're repeating this 3 times, you don't know. Maybe in the future, the down and the up states are going to be very different. And if I start to already abstract this into a function, it's going to make it more difficult to modify later on. I'll have to probably de-abstract, and that means the abstraction was useless in the first place. And then finally, for down, same thing. Wait 3 seconds and then move to the next. And then let's see if it actually works. Okay, let's see if it actually works. And it doesn't. Why? Okay, that's because the import statement was wrong. Play anim if not playing needs to have the .js. Be careful with this. This error wouldn't happen if you were using a bundler. So maybe look into using something like Vite, and you'll avoid this completely. But as I said, the reason I'm just using plain JavaScript is to make this very beginner friendly and also future proof in a sense, because even in the future, let's say Vite falls out of fashion, or yeah, so my tutorial will be like using an outdated tool, and that might be my video will be less, my tutorial will be less evergreen. Okay, let's see. Does it work? Yes, it works. You can see that however, the flaw here is that when it collides with something, it continues moving. What we want is that it immediately selects a new state to proceed on, so that this happens less often. Okay, let's do that. It's a single, it's not that much code. It's just one if statement, actually. I'm going to copy it, and I'm going to paste it, and I'm going to go over it to explain everything. So we don't do that in the idle state. We only do that between the waiting and the changement of state. So that's what this does is Slime, you use the get collisions function in Kaboom, the method associated to the game object. What this does is, first of all, to use this, you probably need the area component so that the slime can actually deals with collisions because it has a hitbox now. And what it does is it's going to give you an array of all the current collisions that are going on with the slime. And I want to just get the length. So I just want this, what this if statement is basically saying is that if the we are seeing collisions, just move on immediately to the next state. The reason I'm using return here, because somehow it occurred to me in the previous tutorial, in the platformer, you will sometimes have situations where you go to the next state, but this code will still run. The rest of the code will still run. So this doesn't cancel what comes after it if you don't return early. So now what we do is just by, hey, there are collisions with the slime. So immediately go to the idle state without waiting anymore. In fact, I think this is unnecessary because we wait for 3 seconds, and this it doesn't seem to be that much. Yeah, that's something I think it's not that useful. Wait a minute. Let me test. Let me test. Okay, does it actually do anything? Okay, let's implement it and then let's see if it actually does something. Because I'm starting to have doubts that it might be even useful in the first place. So I'm going to copy paste this everywhere. Here. Here. And then here. Save everything and let's see. How are the slimes behaving? Doesn't seem to be any different. Yeah, it doesn't seem to be any different. Yeah. Yeah, doesn't seem to change. Okay, well in that case, it's useless. It's useless because it doesn't matter because the waiting is already done. Now, let's say it was not async. What would happen in that case? Would it move? Would it adapt? Here we need to wait. Let's. Okay, what happens in this case? It waits 3 seconds and then it doesn't move because it changes too fast. Yep. All right. I think this is something I just discovered right now, and I don't have a solution for it quickly. So, because the enemy slimes are basically dumb AI, it doesn't hurt to let them wander, even collided, to stay walking for a while and then move to the next state. So let's just simplify our code. Now for the we won't have this issue for the ghost because it will follow the player. It will be more dynamic. This was just a small introduction, I guess, to AI, to Slime AI. I think this API, there's something wrong with it. It's not that user friendly. I think maybe we should have more states. Instead of just having on state enter, we should have a while state instead of having to rely on some things like that. That would be better. If you're the Kaboom maintainer watching this, I doubt that he will watch this full multi-hour tutorial, but yeah, that would be something to improve, I think. All right. I think I'm going to stop here for this part of the tutorial. I hope this was useful to you, and I'm hoping to see you in the next part as well. So there's still a lot of stuff left. We, for example, need to work on the. Actually, let's list what we need to work on. We need to be able to enter the house and exit from it. We need to draw the inside of the house scene. We need to work on the old man AI. We need to work on the dialogue system. After the dialogue system, we need to work on the sword attack system. So giving the player the ability to attack with the sword, and to unlock this, so we need to start having our state management solution here implemented. Once this is done, we need to work on the dungeon, display it, then on the dialogues that are needed here with the kid in prison, the son in prison. We need to modify the state of the door, the prison door, to respond to when you to open itself when you have the keys. We need to work on the ghost AI. So as you have seen, we have a lot of stuff to get done, but hopefully this will be like an eye-opening experience, and coming out of this tutorial, be able to make any kind of a game you want on your own. And also, I'm hoping to also start making other types of tutorials after this one is done. So using other technologies, so maybe using React, trying to make an RPG with React and seeing how to lay elements on top of Canvas. That would be something very useful because, as I have explained earlier in the tutorial, it's really useful to have to benefit from the DOM in especially in terms of languages. The browser supports so many languages correctly and display them the characters correctly. It makes it trivial to implement, for example, Arabic's language translations, or any language really that is supported on the internet. So and also, yeah, so that's why it might be a good idea to make UIs in either React or just plain HTML and CSS and JavaScript. So I'm gonna think, if you have any ideas of future tutorials or things you want to see on the channel, feel free to propose them as well. Hi everyone, welcome to this third part of the tutorial where we are going to build a Zelda-like game. In the previous tutorial, we were able to get player movement done, and I think that's and the slime AI. So maybe I should just run the output first. So here, give me a second. Here we go. So that was the state of the app, the game, not an app. So now what we're going to work on is basically entering the house. And I just want to put your attention to some things that here we have an area that has a tag called door entrance. And this is how we're going to make sure that when the player collides with the door entrance area, it's going to switch to a next scene. So let's implement that right away. Just so you're not surprised why this is here, is that if you remember in the previous tutorial, we just used the tiled files that I already made. So I have shown you how to basically make your own maps. And then just to go faster, I just told you to just download the actual maps we're going to use and start using them. So here in this map, you can see that the door entrance is in the boundary layer, and it's named. It is named. Wait, where did I put the name? So if I click on the specific tile, you can see door entrance. That's the name I've put here to basically detect it in the Kaboom.js code. So now what we're going to do is let's go back to the world.json. So we're going to work on the transition between these two scenes, and then we're going to fill the whole house scene with the actual house. So just so you can see, the house.json looks like this. So this is how the house map looks like. It's a simple house, and everything here is going to be colored black well, a color near black. And yep, so here are the collision boundaries, the spawn points for both the old man that we're going to place here and the player. So I hope that was clear, and we can just jump right into it. All right, so here basically on under world.js, not JSON, sorry, under the world function at the bottom, we are going to simply add a collision detection function. So what I'm going to do is simply maybe wait a minute. Yeah, we're going to have entities. So if you remember, entities is where we stored our various game objects, and you have the player game object stored under the player property here. So what we're going to do here is entities.player, and then since it's a game object and it has the area component, we can use the onCollide function. Now the onCollide function, what it allows you to do is you pass in a tag of an object you want to check collisions with. There is two forms of this. Now this is the method form, where you're calling it as a method of the game object. So what you only need is one argument here for the other type of game object you want to check collisions with. So here, basically door entrance is the tag of the area we want to check collisions with. Now, like a lot of things in Kaboom, the second param is basically just a function, and this function is what will run when the onCollide event occurs, when there is a collision between the player and the door entrance. So just so you understand again, door entrance is a tag that we added to our, let me just look it up, to our area here. It was done by pulling the info from tiled. So if I go back to how we have drawn the boundaries, so in the utils.js, and if I go to draw boundaries, I think, yep. So we add to the map object as a child the generate collider box component, and here object.name is what is passed as the tag in generate collider box component. All right, so hope that was clear where it came from if you weren't paying attention earlier on. So now let's go back to world.js. I need to save, right before hitting save, let's write the logic. So basically, we simply want to do k.go. If you remember, it's how you go from one scene to next. And then if we go back to main.js, you can see that we only created one scene, so we'll have to create another one. And okay, you know what? Let's just go back to world.json, put house here as the name of the scene. It does not exist yet. Just save it. Now it shouldn't work. Your code, well, if you hit it, scene not found house when you collide with the area called house entrance. So what we need to do is we need to go to main.js. Well, actually, we need to look at our folder structure again. And then here in the scenes folder, we need to create another file. I'm going to call it house.js. Now, what house.js will contain is basically the same structure as this, as world.js. We're just going to copy the function signature and replace this with house and close the function, of course. So let's close it. So for now, whoops, I wrote who's instead of house. So this is our function. Everything's fine. We can go back to main.js. We will fill it in later on. So here in in main.js, we import it using import house from dot/scenes/house.js. Once this is done, we can just add it to our scenes object. And remember, we can do this, the shorthand for, yeah. So the shorthand, if you remember, I want this scene to be called house. So normally I would do this and then would just pass in the function. Now it's called also house, but since in JavaScript, if you have a key that is the same name of the variable you want to add to the object, you can just do as a shorthand, you can just pass in directly the name of that function name or variable name you want to import. Hope that was clear. Let's save. And now if I go back to the game and try to enter, we successfully transitioned to a new scene. So now let's draw it. So for drawing, it's going to basically be the same thing again as the world.js. So there's a lot of common stuff we're going to reuse. One of them is, of course, the colorized background, but with a different color. So let's do that. I'm going to take this function, go back to house.js, and then in it, I'm going to do this. Now this needs to be imported. It's not. Maybe VS Code can do it for me. Do I benefit from any IntelliSense? I guess not. That's one of the disadvantage, I guess, of just using JavaScript modules, or I simply don't have VS Code set up properly. Yeah, so even I just don't know everything about VS Code. So if you know how you could get IntelliSense like that for a just normal vanilla JavaScript project, feel free to share in the comments. And also, if you ever see that I write some code in a wrong way, or there is a better way you've come up with, feel free to also share it in the comments. So I can also learn. So I'm just like, it's not just a one-way teaching. It can be like two ways, and we both benefit. All right. So okay. So now for the house, we're going to need separate values, different values of RGB, because the color is supposed to be black, but not fully black, because in RGB you can specify black color. So just to reiterate, RGB is a way of defining colors by passing 3 values. Each values can vary from 0 to 255. The first param is R, which stands for red, and it can take a value of 0 to 255, which is basically describes the intensity. Same thing for green and blue. So now if I go to house, okay. So the color we're going to need to pass in here is the number 27. Now, how did I figure this out? I simply opened up a pixel art editor in which I I used the selector tool and just saw what was the RGB values. You can do that in any photo manipulation software. It doesn't have to be in pixel art editor, just so you know. This is how I came up with those values. Now let's save and go back to our project and see if anything has changed. Wait, we didn't import. That's why it didn't work. So we need to actually import. So back in the house, we need to import colorized background. So colorized background, import colorized background from utils. And then here again, be careful. It did not add automatically the .js extensions, which is needed for vanilla JavaScript projects that use the JavaScript modules like that, import statements. All right, so now if I go back and I go here, you can see it's not black, it's a dark bluish. And this is what we want, because it's going to fit with the rest of the assets. And this is how it was in the asset pack, by the way. Okay, so now it's time to actually draw. And the drawing structure, how we're going to draw the map, is basically going to be the same exact thing with just a couple of variations. So here again, we import. So here is the code for world.js that we just wrote. So let's copy part of it. So I'm going to copy this part, and maybe give me a second. All right, so I'm just going to copy. Yeah, we're going to have to change some values, but otherwise it's mostly the same. So I paste this here. Now here, instead of maps.world.json, by the way, if you haven't done it already, we need to actually have the maps. I haven't done it myself, sorry. So in the description of this video or the previous parts, I'm hoping to just put it back in this part's description as well. You have all the assets you need. So I'm just gonna copy and paste the house. I'm gonna as well go ahead and do the same thing for the dungeon. So I have all of my files already here. And now it's, yep, I think we can just go close this, and then close this again. And then just, instead of maps slash world.json, it's going to be house.json that we want to import. Now, if we save this, and it's time to actually draw it. Now here, we're going to change the origin. So by default, the map is not going to be viewable, because if you look at the editor, you can see that it's not drawn from the top corner here. So this is something I did not expect, but I was like too lazy to change it because it's not that straightforward. I don't I for some reason I just cannot select it. So if you're an expert in tiled, please feel free to tell me how can I just move a same map all over to the origin or somewhere else in the canvas here. All right. So the values that are going to be needed here are going to be 500. But before we put the value, let's just draw the map. So like in world.js, we created an object that contains our entities, and we're going to basically have the same pattern here. And we're going to put old man, which is the old man that we're going to draw, and the player as well. We need a reference to both of these objects. Now finally, same thing again. So I'm just going to copy what's in the world. So this is the same thing. So just copy this part from the for loop that draws. So the drawing part, copy it. And then for the rest, we're not going to use the exact same thing. We're not going to move the camera, for example. So we won't need this logic. As for the player movement, we're going to need to call that. And for this, to determine when the player is going to move out. When the player moves out, wants to exit the house, we need to have a collider as well, a colliding logic. So I paste this. That's it. It's formatted already. So just so I don't need the slime logic. So I'm gonna remove it. I think that's basically it. We're going to need to add the import statements for all of these, but otherwise it's fine. By the way, that's the reason I put a spawn point for the player here, so that it's going to be drawn here. And if the player collides with this, so if I select it, if I go to the correct layer boundaries and select it, you can see the name door exit. So this is how the player will exit the room. All right, so let's go back to our code. We have the draw boundaries that we need to import. So import draw. It's from utils as well, so no need for tool. We can just import it here. Draw boundaries. We're also going to need to import draw tiles. Okay, draw tiles. So 3 of them are imported. What do we need else? Generate player components. This is going to be imported from the player logic. So import player. We need both actually, generate player components and set player movement. And of course, it did not add a .js here. So be careful. I think that's all we need. We have draw tiles. Yep. We have everything. Yep. So now that we have this logic, I think we can just try it out and see what it is displayed. And then you're going to see that we need to change the values here for the map to be centered or at the correct position in the screen. So let's do that. So I'm going to enter, and you see there is nothing visible. That's because the map is outside of the canvas, so outside of the camera's viewpoint, the default camera viewpoint. So we need to change that. So here, the values we're going to need to put, let's go at it gradually, just to show you that if, for example, I put this at 300, let's look at the output. It's still not visible. If I put at 400, and it's probably not going to be visible as well. So that means that the map is probably too much down as well. So that's how you figured it out. So let's add 200. And let's see. Is I'm starting to think that maybe there is a bug. Yeah, I forgot to import this. So sorry. Let's import it as well. So fetch data. Oh, it's also from utils. So we don't need to have a separate import statement for that. All right, so we have all of our imports that we need. This is going to be something that we're going to need later. So let's keep it right here for now. And then let's look at the result. And let's close this. Let's refresh. And then here we go. We have our little player. The camera is too small, of course, but at least the map is visible. And you can see that the boundaries are also visible. So one optimization I think this is a waste to have an area here. It could have been removed, probably, or maybe it could have been removed to save on performance. But it's a small scene, and because it's a small scene, you don't have to worry about that. So now let's write the code for. Let's put the correct coordinates. So here we want it to be at 520. This is because it's going to look more centered. It's going to put the map, properly centered. Now let's write the logic for the map, the camera. So here in world.js, I told you earlier on that we wouldn't need to move the camera, but we need to scale it. We need to actually scale it. So let's do that. So in house.js, right after the for loop at line 43. So if I collapse this so you can see, we can call the k.camScale because remember we're having the k here that is passed. So I save this. Now, if I try to enter the scene, you can see that we're in it. Now you see that the player is facing downward. That's by default. When you just put the player, we specify that the default animation is downward. We won't need to modify it because when we're going to set the player movement, so allow the player to move, by them pressing to go to the next scene, it's already going to change the direction of the player to look towards the front, so the top, instead of looking down. So let's try it out. So here, let's say here, set player movement. Remember we already imported it. Pass in the entities dot player. I made a mistake. Now let's try it out. If I enter, you can see. You see this phenomenon? But now I don't have the logic to go out. So what I'm going to do is write this logic and then you'll see. So here, simply entities dot player dot on collide. And then here instead is when you collide with door exit, because that's the name of the area. We just want to go back to the k.go to the world. And by and then you're going to notice something. So, but yeah, because by default in the world we're placed here, so it's going to look like you're just moving out. But if you were to put the spawn point elsewhere, you would have to have two separate spawn points. You would have a specific spawn point when the player is exiting from the house scene, so that they appear in front of the door. And this is something we're going to actually do in the dungeon. So let me just so in the dungeon, what we want is when the player enters the dungeon and goes back and goes out, we want them to spawn here, not all the way to the original spawn point. And I have already added this second spawn point in the tiled editor. If I show this to you quickly, I go back to world.js. You can see this is a player spawn point, and there is another player-dungeon spawn point. Hope that was clear. All right, so let's go back to the scene. We can move, and as you can see, you can hit. So I was talking earlier on about this not being needed. If you, well, actually, it's needed. This is not needed because there's two. How we say this? There is a bed and the drawer here. That both of them are solid objects. So anyway, the player couldn't pass between. So if you wanted to save on performance, you would remove this area, this extra area. And as you can see here, as soon as I collide, I'm out. And as soon as I collide, I am in. And you can see that the player is facing down because I'm being careful here. I'm just pressing gently, even then. Yeah. So you really have to press gently for the player to still look down when you enter the next scene. But because the usual player behavior is basically they move and then they enter, and by default they're gonna continue pressing the up key even though they entered a new scene. So that's why I didn't want to add the complexity of trying to change the direction of the player where they're looking at. Yeah. So to have this, you could write logic for this, but it is not necessary. All right. So I think we need to draw the old man now. So to draw the old man, it's basically going to be the same thing we did with the slimes, but just only one. So I'm just going to copy the code for it. Wait a minute. Never mind. We need to actually write the code in the entities folder for the old man, and then we're going to copy and paste how to draw it here, or just to redo it. So now let's create a new file here. I'm going to call it oldman.js. So oldman.js is basically going to follow the same structure that we're used to for both the slimes, etc., by using this pattern that I have invented called you have the generate the old man component, and then you have their AI or other functions that are below. So it looks like methods from the class-based object-oriented approach. Now, thinking about it, there's still a lot of advantage, I think, from just wrapping your game objects inside of a class and then being able to edit and modify it from its methods. I think this is it's a greater experience in the end. So after having done this project, I think maybe I should go back to object-oriented programming. There are definitely things that were easier here with using functional, not functional, just normal imperative programming with just using functions. It's not the same thing as the functional paradigm. So that's a separate thing. So yeah. Okay, so let's create export function generate old man oops, components, and then this is going to take k, of course, and I think it's going to take a position, and old man is going to be written with a capital M. This is how I did it. Just do it the same way as me, just so that you're not confused later on why it doesn't work, but either would be good. Just be consistent with the one you choose to go with. So basically, we add here, so we have our generate old man components. We have the k, which is the context. We have the position. Everything looks fine. And then we need to return an array of components that we're going to use. And here, there's nothing special. I'm just going to copy over what we need and then just go with you one by one instead of having to redo it manually. I think it's going to go faster. We don't need this. So here are the components we actually need. We need to get the old man animation from the assets. So I'm not sure if we have actually loaded. I'm not sure if we have actually loaded the old man animations added to the object. Let's just look it up. We haven't. So let's do that immediately so we don't forget. So basically I'm just going to go and copy paste it, and then you will just copy paste it yourself. There's nothing new. Like I've explained with everything, you just take the frame number if it's a one frame animation, otherwise you use the object form. So here it is: old man down, old man side, and old man up. All right, so now that this is done, I'm going to go to the oldman.js, and then here, now that this is defined, this should work. Here is the hitbox, as I said, and this is we want this to be static true so that the player cannot move the old man. So it's going to remain fixed, solid, like the obstacles. and then the position. So nothing new here. So I will spare you spare you any explanation. Not spare you. We're not in a boxing match. Sorry. All right. So yeah. So now that we have this for the old man, we need the actual. Yeah, I think that's it. That's enough to draw it, and then later on we'll have to come back here for the actual logic. So the text dialogues, all of this. So here you see, I'm going to create another if statement that comes right below. And here instead, I'm just going to call it old man. That's the name of the pin. If I go back to house.js, old man, that's the spawn point in the spawn points layer. Now here, instead of entities player, we add a map. We're just going to entities old man. And then map add. And then here, instead of generate player components, it's going to be generate old man components. And be careful here, capital M, if you have followed exactly how I did it. And then the same thing, basically. And then here, don't forget to import it from the old man file. So old man, generate old man components. Here, for some reason, when I write a relative, not a, I forgot the name of this, not the default import. It adds to .js, but sometimes it doesn't. So yeah, be careful with .js here. Keep it or add it if it's not done already. Sorry to reiterate this, but I think it's going to be a source of a lot of errors and you won't understand why. But as soon as you see in the console tab the MIME type, you're going to know what to do like immediately. Oh, MIME type error, so probably I forgot to add the .js in the import statement. All right, so now I think we have everything we need to actually draw it. So let's look at the result. So if I enter the scene, the old man is here. Now we want the old man to be able to change directions regardless of the way he's looking at us. So if we are looking at him. So if I go from this side, I want him to turn to my side, etc., etc., and etc. So to do something like that, I'm going to simply write the code for it and explain it like we're used to. All right, so we are going to go back to oldman.js, and then in oldman.js, we're going to need to add another function that we're going to export. Export async function, and this function is going to yeah. So there is this function that I'm going to call start interaction, where usually the old man will look at you from the direction you're coming from and then start talking to you. But for now, let's just focus on getting the the old man to turn around to your direction when he's talking, when he is going to start talking. But not the actual talking. This is going to be when we're going to create our dialogue system. And in our dialogue system, there is a bit of complexity, but yeah, it's fine. And then after that, I think we're going to just handle the state things, so the game state, etc. And lastly, we just do the dungeon. I think that would be the better order of things. So let's jump right into it. So K, all right. So like with a lot of functions here, we always need the K, the context. Now, yeah, one thing I liked about this project this time around is using Kaboom as a non-global object. And I think this could be really helpful combined with object-oriented programming to make your code more organized. So that's something I would definitely reuse. Now I'm still considering for my next project if I want to do that. But I might take a pause from Kaboom for a while just to explore other things, try to make games maybe in React and stuff like that. Maybe Pixie.js, just so I don't become a Kaboom only YouTuber. All right, so yeah, hope you'll be interested as well in. I'm thinking of making gamified apps. I think that could be an interesting project as well, or a math RPG, so an educational game where you try to you beat monsters, etc., by solving math equations. So if the player attacks you, if the monster attacks you, you have a limited time to solve an equation. And depending on how close you are to the actual answer, you reduce the damage you take. So that could be a nice gameplay. It would be fun. But yeah, that's definitely something that I need to work on and think about. So here in the start interaction function, it's not that complex. You just do a if statement, if the player dot direction, and you remember earlier on we added the direction property to the player code in player.js exactly for this purpose, and we were changing it, updating it in the set player movement. So that's why we were creating this. So if the player direction equal what? Equal, for example, left, then we are going to do two things. We need to flip the old man, because this is, again, like with all the animations, we only use one side and then we just flip it like a mirror to generate the other side. So we don't have to draw two separate directions. And this works well. So play anim. But this one, I don't think this would work with high resolution art. So something like Ori and the Blind Forest, I think you still need to have unique two-side animations. But for pixel art, it still works. So here again, import if playing, if anim, play anim if not playing. And here again, it did not add the .js, so do it. And here call the function actually. And here pass the old man, pass the anim name. So the anim name is just going to be side. I think old man side is the name. Yep, old man side. Old man side. Now that this is done, we can simply, I think, yep, that's it. We need a second if statement for the up and two separate if statement for up and down. Oh, actually, we need, no, never mind, never mind. We need three if statements. So I'm just going to copy and paste them. So we need this. So we need either the old man. So the way it works is if the player approaches the old man by the left, we need to make the old man face right. If the player is facing the old man from the right, we need to have the player face left. If it's down, if the player comes from down, it needs to look above. And because there is a table, we don't need a table that blocks it. And we don't need to change. We don't need to flip the player to look downward because for two reasons. There is a table that blocks the way, so the player can never approach and talk to the old man from this. Well, actually, in real life, you can't just talk to someone, even if they're seated at a table and you're in front of them. But it's the default anim to look down for the old man, so we just go back to it. So now I think we have what we need to to have the player facing the correct direction, but we still need to call this in house.js. So in house.js at the bottom, we need to add another collider. So entities, another colliding logic. So entities.player on collide with who? On collide with old man, which is the tag we used. And then here, oops. So here, what happens is simply we can start the interaction. So I'm gonna call start interaction, imported from oldman.js. So this should have been done automatically. Start interaction, and then here I'm just gonna do k dot not dot comma, pass in the entities. Actually, you can just, in this case, I don't think you need the. Yeah, okay, let's just pass it. So just one thing in Kaboom.js, you can have access to the object, the second object, by just having access to it from this function. It's going to give it to you, so you can have as the first param this object. But I think the reason I went with directly using the original reference that I've made is either I forgot about it, that you could do that, or there are some limitations and I don't remember them at the top of my head right now. So yeah, sorry. So we start the interaction, we need the old man, and then we need, of course, the player. So entities.player. All right, let's look at it and let's see the output. So here it is. If I approach him from the left, you see. But now the issue is that he doesn't go back to looking down. So to have this, we need to have another function. This time around, it's going to be called, what's the name of the function? It's going to be called end interaction. So in old man, here again. Now, there might be something that I forgot to explain is why this is async. And for now, it's not important, but for later, we're going to add some code to this function, and we're going to need to actually have this async because we're going to need to use await for the text scrolling. So as the text gradually appears, we're going to need to use async await here to achieve that. So here export function. I think the second one doesn't need to be async. So export function and interaction, pass in k. I don't think we need k for this one. I think we just need the old man. Yep. Here we just need the old man. I think it's a waste actually to have this function. We don't need it. Never mind. Let's just write this logic directly within the house.js. So maybe in the future, if you wanted for maintainability, yeah, but it turned out I didn't need it. So I created originally this function, or maybe I had the intention to add some other stuff to it, but in the end it didn't happen. So we're just gonna write its logic, which is one line within this function. So entities.player on collide end. This is another Kaboom event listener can add, is to check when a collision ends with another game object. So it's basically the same thing like that, but just when the collision ends. So here again, instead of writing the logic, I was going to write it in another function, but here we just need to play anim if not playing. We pass in the old man, entities.oldman. And then here, we're just gonna have the old man down animation, which is the default one, if I remember correctly. Yep, the default one that we decided to put. Let's look at the output of this. So I go here, and then when I leave, he turns back. And that looks pretty great. All right, so see you in the next section of the tutorial. All right, so now what we're going to do is basically work on the dialogue system. So it's a perfect occasion to work on this because we're going to need to talk to the old man like so to give us the sword, and that will be the opportunity to also work on the state. So let's do that. If we go back to oldman.js, you'll see that we had this function called start interaction, and it was async. That's because we're going to write the logic to display text here. Well, actually, we're also going to create a function in the utils.js file, but that's some for another time. So let's let's start by writing the logic to I think we're probably going to have to write the logic for the text box and then add it here. So let me just check. Yeah, we also need to store the dialogues of the old man under an array. So that's something to keep it organized, and also it's going to teach you how to have multiple languages. So here in this tutorial, we're going to have only two, English and French. Feel free to replace French with whatever other language you speak. Well, actually, it's not possible for all languages. It has to be languages that uses Latin characters. And I think there's only English, French, maybe Spanish, but even Spanish, yeah, in Spanish, maybe Italian as well. Anyway, it's not that important. So let's first start by creating in our contents folder. So I think this is going to be best. Is in the content folder, we're going to create a new file. This file is going to be called Old Man Dialog, and this is where .js. Sorry, I forgot to put the point here, so that's unfortunate. All right, now it works. So in oldmandialog.js, here is the structure we're going to adopt. So what we're going to do is basically have two arrays. Two arrays. One, I'm going to call it English. English. The second one, I'm going to call it French. And then we're going to export this time around. Actually, we need a third constant, but this time it's an object. So old man lines. And this is going to take in the English array and the French array. So like I explained multiple times, the reason I can do this is it's a shorthand for wanting to have the same property name as the variable name that is passed. So that's why I can do this. Now we're just going to export default. It's the only thing we want to export from this, the old man lines. So here in the English, here's the dialog we're going to put in. So the way I structured it is that this array is going to contain other arrays that each represent a given dialog. A dialog is not just like a text box worth of text, but also like a dialog is when you interact with the player. So there's three occurrence, four, I think. Let me just copy and paste it because I don't think there is much value in just typing it out. You can do the same thing as well. So you can just go to your what's the name to the GitHub repo and then just copy and paste this part of the code. So here is the first dialogue. It occurs when you talk to the old man for the first time. He tells you it's dangerous to go alone. This is how we say a reference to the first Zelda game where the old man in the cave in Zelda 1 tells you it's dangerous to go alone. So that's why I wanted to put it here. Line 2 is take this sword, press space to use it. Third line is please save my son. He's captured in the dungeon towards the west, basically giving the quest to the player, and I will reward you handsomely. Now, this is the first dialogue that occurs when you talk to the old man for the first time. Now, if you stop talking to him and then come back to him, he should start from here. He will tell you forgot how to use your sword. Press the space key to attack because in this first dialogue he gives the sword to you and tells you how to use it. And then this is if you forgot. So that's a reminder. If you stop the interaction and then come back again while you're in the same scene, this dialogue is going to play it, and this dialogue is also going to play right after if you come back again. Hope that was clear. I'm gonna also put the French version here. Feel free to translate to your language of choice. So here it is. Now here the way I've written the French is without accents. French usually have accents because the font I'm using, the GB font, does not have accents. So that's why it looks like that if you're French or come from a French speaking country. So yeah. All right, so now that we have everything we need here, we can proceed on, and I think we're going to have to write the logic to display the text box. So let's do just that. So in the utils.js, so this is utils.js, we're going to have to add a maybe it's here. Let me check where I don't remember if I wrote it in actually utils.js. I think I didn't. Wait a minute. Where did I write the text dialog in Oldman? Oh, I know. So here at the beginning of the tutorial, I told you to create the UI components folder, and this is exactly where we're going to write the logic for our dialog. So I'm going to create a new file. I'm going to call it dialog.js. Once I've created this file, what we're going to do is simply create two functions. The first one is going to be the dialog, simply a function called dialog that is the default that we export. Async function, let me close this, dialog. And what this will do is basically draw a box on the screen, so the dialog box, and we'll start displaying the content. So it needs three params, k for the context, because we're going to need to draw stuff in Kaboom to display it. The second one is the position, and finally the actual content, which we're going to pass from our old man dialog back in the content folder. Hope that was clear. Now, what we're going to do is simply, before that, we need to write the logic to create the dialog box. And then once this is done, we're going to create another function on top, which is its role is to display the current line. And it's going to display it gradually with text, with each character appearing at a given interval of time. So let's first work on the dialog box, making it appear on the screen. Once we have this done, we can write the logic for displaying the lines. All right, so the first thing we need is a constant called dialog box. And here again, it's just going to be an empty game object because we want this to be the parent. It's not going to be empty. It's probably going to take the positional components. So it's going to determine the general position of the, never mind, actually, we're going to actually draw the box here, and then we're going to add to it as a child a text, another game object, which only takes care of the text. Hope that was not confusing. So let's do that. So I need k.rect, not react, with a width of 800 pixels by 200 pixels. So that would give us a good looking box, a long enough box. Then of course we need three other game components. We need the positional component, which is passed here. We need also to use the k.fixed. Now this is, if you remember, the fixed component is to make sure that the dialog box is not affected by the camera, so it will always remain visible on the screen, regardless of the camera movements. And then below it, we're going to create another game object called text container, but this time this game object is a child of the dialog box, and so this constant only serves as a reference to it. We're going to need that because we're going to pass this to the function that is tasked with displaying each lines. So it's going to need to have a reference to that game object so it can update the text. So here, instead of doing k.add, we do dialog box.add because we want this game object, the text container, to be a child of the dialog box. So here again, an array of components. I use a text component, initially empty, an empty string that we're going to fill in, and then the text component takes in two params. The first one is the actual text. Here it's empty, an empty string, and then the options object where you can specify a bunch of options like the font you want to use, and we want to use the Game Boy font. Now, I don't think I have imported anything in main. Did I import the font? I don't think so. So we're going to have to do this. Whoops. So to import a font in Kaboom.js, you just do load font. You specify the name you want to call this font and then the path to it. So here it's in assets / I don't remember by heart, but it's asset gb.ttf. You're going to find this font in the description if you haven't already put it here. So if we go back to the dialog, we can have our font here that is specified. Now the width of the font, no, actually the width property here is not the width of the font, is basically the width of the line you want to display. So Kaboom.js comes with automated or automatic text wrapping. So you don't have to write your own text wrapping logic. You just specify to the text component what is the max width it can take. So here 700 pixels is what looked right. You can experiment with this value. So really feel free to change the value here and see what looks good. Finally, not finally, we need, there's two more. We need the line spacing. Yeah, line spacing property, which basically determines the space between lines. So the vertical space. So it's like a margin in CSS. So here margin top. So you want your two lines to be spread out a bit, not too near each other. Otherwise the text will look squished from line to line. Your paragraph, basically. All right, finally we need to specify the size. For now, we're going to default to 32, but with other languages, for example, with French, it takes more words to say the same thing. So we're going to have to reduce it a bit. Otherwise, it's not going to fit in our text box. All right, now for the text color, by default, text is white. And because we have a white dialog box, because by default, if you don't specify the color of your rectangle is going to be white, so we need to change the color of the text. And now I'm just gonna go with black. You can take the value we had earlier on in house.js. I think it's is it here? So in house.js we had this color specify. You can take it. I'm gonna actually take it. Go back here instead of pitch black. It's usually a good design practice to not go with pure black, as it's harder on the eyes. I think that's the reason for it. Not sure actually. All right, now that the color has been decided, we need a positional component. So here again, because the text container is a child of the dialog box, the position here specified is going to be relative to the origin of the dialog, of where the dialog box is. So basically the origin of the position of the dialog box. So here it's 20 pixels plus the position, the X position of the dialog box, and then 40 pixels plus the Y position of the dialog box. Now, finally, of course, we need to add fixed. Now, I think this might not be necessary because the parent is already fixed, but maybe I added this because it didn't work. So I'm going to keep it for now. I'm probably going to remove it once we try displaying it for real. So now we have our text. We have a function that just displays a text box and some text, which is empty for now. So what we're going to do is try it out. Let's see what it looks like. So in oldman.js, within the start interaction, let me just look at it. I think we need to add more we need to add more code, of course, but for now, let's just display it and see what happens. So for now, I'm just gonna call dialog, import it from the UI components, pass in the first param, which is k. As for the position, we are going to need here for it to fit within our screen and looks good. Like it needs to be like bottom centered. The value I've come up with is 250 by 500. Those are arbitrary values. I have figured them out by testing and looking at various positions. So start with 0, 0, and then 100, etc. to see where the box lands on your screen. And this is how you're going to come up with the value you need. And then here for the content, this is where we need to import the content that we've added into our old man dialog. So to do something like that, I'm going to create right above a constant that we're going to use later on. But for now, I'm going to call it responses. Old man. Wait a minute. We need to import the old man dialog. So old man dialog. I guess it's not automate. Oh, it's old man lines. Sorry, old man lines. For some reason, it's not detecting. So we need to import this manually. Import all it's the default import, all main lines from what? From content slash old main dialog.js. Now here in old main lines, not lies, here we're gonna select the language. For now, let's put by hard code it to English. And then here as the third param, we're just gonna take the first dialog, so response index 0, because if you remember, if I go back to the old man dialog here, you can see that we have an array. So index 0 of the English array is this array. So that's why we use index 0. So just to hard code it, so later on, it is not going to matter in the end. And for now, it's not going to display anything anyway, because we haven't wrote the logic to display the content. And later on, we're going to add some state management code here so that we can switch between languages, but also this is going to set the stage for actually other state related stuff we need to keep track of. All right, so I'm going to try it out. Let's go to here. All right, so I'm going to try it out. Let's talk to the old man. And you can see the box appears. Now it doesn't disappear and we need to go out, but you can see that it is indeed here and roughly centered. All right, so now we're ready to continue working on displaying the lines. So right above in our dialogs.js file that is located within the UI components folder, I want you to create a new function and I'm going to call it display lines, or display line. Maybe it's only a single line that we display. To this function, we need to pass two params. The first param we need to pass is actually the text container that we created here. So let's add a first param that is going to take this, and because we need this text container so that we can modify the content of the text container, so we can add characters to it. And finally, as the second param, we need the line, the actual content, the actual line, the string we want to display. And the logic for this is very simple. To display characters gradually, like you see in many games, what we need is simply to have a for loop and use the const char of line. So you can iterate over a string in JavaScript, and I think in many other programming languages, like an array, basically. And we're just simply using the for loop for that and the off variation. So you could have written the logic in a different where you could have decided to write the logic like this. For example, instead of having this for loop, you could have had this one where let I equal 0. I is inferior to line.length because a string also has the .length property, and then I++. And then from within, you would simply, to get a specific character, let's say we console log it, you would get it by just having line.I. So this is how you would access it. But we don't need to do that because we just want to simply iterate through the line and we don't need to do anything fancy. So the off loop is a very handy syntax, an easier syntax to write in this case. All right, so now we need an await and we need to create a promise. Now the reason we need to create a promise is because we want to display the characters one by one, and therefore we use the await to await that the character is displayed. Now the reason I create a promise for this is that if we were going to use the set timeout function, and I think it would be better for me to just write it out and then show it to you. So basically the promise takes in, so in JavaScript, a promise can be created, instantiated by calling the promise constructor with a new keyword. This will allow us to create a new promise. In this constructor, we need to pass in a function that is going to run. This function can take, so as a first param, the resolve and reject functions that are passed within. So the promise constructor will pass to the function we write here those two params. Now you could have decided on a different name. The name here is not really important. What's important is what they do. And here I'm going to keep the reject, but we don't really need it. So let's continue on. I'm going to use the set timeout function. Now set timeout is, if you're not familiar, it's a function provided by JavaScript. And this function provided by JavaScript is basically a native function. It takes in two params, a function that is going to run once a timeout is done. And this timeout, the second param, is basically the time elapsed before we consider the timeout to be done, and then this is going to be called. So here 10 milliseconds, so I think it's since 1000 milliseconds is 1 second, so 10 milliseconds is basically 1/10 of a second, maybe. My math might not be correct here, but it's not that important. So here, during the set timeout, this is where we're going to use the text container. And what we're going to do is, because we used the text component in Kaboom.js, we can basically access it by using the text property and basically change, like modify the content, reassign the content of the text, which will replace it. Now we don't want to rewrite everything, so we're just going to use the plus equal operator, where we are going to concatenate the already existing content of the text property of the text container. So just to summarize, because when we created our text container, we used the text component in Kaboom.js, it gives us in the resulting game object, because the text container is a game object, because that is a child game object of the dialog box. And the reason we have the game object here is because we use the add function to create that game object by passing a list, an array of components. So now here in the text container, we have access to the text property, and then here we're just going to append to it the char, the current character that is in the iteration. So basically, every time we have this timeout, 10 milliseconds elapse, then we add the character to the text container. This is how a character will be displayed. Will be added every 10 milliseconds to the text box, basically. Now this, like this, won't work, because the promise, the way it works, is basically a notification system. You need to notify it when it's supposed to be done, to be resolved. And that's why the await here is important, because the await will wait for this promise to have resolved. That means to have done, being done. And that's why the promise constructor, constructor allows you to have these two functions to basically determine when the code within the function that is being called here is going to be done. So you have to call it. You have to say, okay, after having displayed the character here, so we wait 10 milliseconds, we call this function. Once this is done, then we can consider the promise to be resolved. That means as soon as you call this, it will signal to the promise that it is over, and the await keyword is going to look at, because the await keyword is waiting for the promise to resolve, and now that it is resolved, it's going to move on to the next, because you know the await keyword allows you basically to have your asynchronous code, so code that could be executed not necessarily in parallel, but while doing something else. It basically forces the function that is asynchronous to wait. So the code that happens here will not run until this is done. And because this is a for loop, the next iteration of the loop will not happen until the promise is resolved. And because we decide when it's resolving, because we used the new promise constructor to create a promise, we need to call it when we think, okay, this, after having displayed the character, we can consider that this is resolved. Then that means we call the resolve function. Now the reject function is useful as well. If you have a promise where you have a scenario where things aren't successful, then you would tell the promise that it failed, basically, by using the reject function. But since we don't need it, we don't need it. So we only need to resolve. So we don't really need to have this case to consider this case. So just one last time to summarize. Usually a promise is a mechanism, a way for you to wrap your asynchronous code, so code that can be executed while some other code is executed. And this mechanism, this notification system, provides you with two tools, the resolve and reject function, that you can use in your asynchronous code to notify the promise when it is done. And because we use the await keyword will make sure that the code within this function will wait for the promise to resolve before proceeding on. That's why it's going to give you the characters that are going to be gradually displayed. If you were to not use the promise, in the case where you wanted to just use the set timeout, so let's imagine this case, basically this would all be run at the same time, basically. So it's not that accurate. It's not what I just said is not necessarily true. What happens here is that it goes here. This line is executed by the. So let's start from scratch. When you just use the set timeout without wrapping it under a promise and awaiting it, what happens is that we enter this for loop. We have this first character of the line. It runs this, and then it immediately moves on to the next and runs this and the next and runs this. And what happens is that you could have four, like let's say our line is 4 characters. You'll have those 4 set timeout ran at basically the same time, and basically they're all going to run this after the same 10 milliseconds has elapsed. And because they were initiated at the same time, that means they're all going to be updated mostly like at the same time. That's why you won't have the scrolling effect. We can test it out basically just to drive the point home. So here, if I talk to maybe we need to call it first. So yeah, let's assume this is done. We need to actually call it within our function, our dialog function. So let's do that. So basically, let's just call it await display line. Pass in the text container. And then let's hard code it basically content 0. So the first line of our content here. So now if I go and look it up, try it out, you see how it almost immediately appeared at mostly the same time. Not exactly, because even though those set timeouts, so the set timeouts here are ran one after the other, but because code execution is pretty fast, it's basically it's as if they were mostly ran at the same time, and that means the 10 milliseconds offset is not enough. So to maybe explain this in a better way, in case you haven't understood it, I really want to drive the point home. In the case where we don't use the await keyword here, the promise, it's as if every time. So let's imagine this diagram where you have your code, and yeah, it's a bit hard to visualize. I'm not sure if this is actually going to work. So let's say we have our set timeout function. So this arrow means that set timeout is being executed. And here we have multiple of those arrows. They are really executed one after the other. So, okay, so here is, so what happens in the case of our for loop? So let's say this is our sentence. I need to display the sentence. A, B, C, D. 4 characters. Let's make it simple. So this is our sentence that we want to display, our content. We are in our for loop. So we immediately, when car or char, when char, not car, when char is equal to a, immediately we run the set timeout function and it moves on to the next. And that means that here we're gonna have the second one, char equal b, and they all call the set timeout function for each of those cases are called near each other because it's really run. So let me so we have char a b c. All right, let's say this is okay, and then finally d. So just to make this clear, so a b c d, and then maybe I should have just copied it, so I'm gonna copy it. Here we go. Okay, so let's say we have, so this is our for loop. It passes it through a b c d. The arrow represents every not just the set timeout being called, but the actual it represents also the time elapsed. So what I want to drive home is that because the set timeout are called near each other, they are basically the function within the set timeout that is supposed to be called once 10 milliseconds has elapsed will be called near each other. That's why you have the basic, it basically looks like all the characters are displaying at the same time. So basically here, so this is the time elapsed. So let's compare this diagram to when we use the await. I think this is where it's going to get clearer. So by using the await, what happens is this. So I'm gonna just remove that. So we have char equal a. Set timeout is called. Once the set timeout is called, it's going to call the resolve function. So let's just draw that. Resolve is called. Can I flip this around? Can I? Yep, I can tilt it. That's good. So we have this resolve function that is called, and only then, that means the promise was fulfilled, and only then will will move on to the next char equal b. Here we go, char equal b. And then, so we have char equal b, and then that means we are going to, just going to copy this again, and I'm going to paste it again. And this at this point is when we're going to call the next set timeout for displaying char b, sorry, and etc. You see there is this delay, this time between iterating between char a to char b. So I hope this was clear on how the await will make sure that the text, the characters gradually appear, as opposed to when not using the await keyword and the promise. I hope that makes sense, and let's just go back to the game. So just to make sure, you see it's near instantaneous. If I now put back the code, not the code, I mean what we had here, the promise, then I save, you can see here, and then I go back, and now it should display gradually. It's dangerous to go alone. Now we don't have the other features like moving on to the next line. This is something we're going to implement later. So I hope that was clear. Now there's one thing I want to fix, is basically some viewer, sorry if I don't remember your username, I'm very sorry, pointed out that in the player logic for this is that when you press basically both left and A, or what happens is that your character will move at twice the speed, because we aren't guarding this. We aren't making sure that only one of those keys is pressed, either left or A. And we need to fix that, basically. So the reason I made this mistake is that in the original code base, if you look on GitHub, I didn't use this. I basically decided that one key would be used for movement, which is the arrow, directional arrow. Okay, the way I see it to fix it is basically we remove this. We basically specify that if the key is equal to left, and then we simply add to our array here of any of these keys down, and we add the other key for left movement. By doing this, it should fix the fact that now if I try both, I will not simply not move. So that's the fix. But as you see, it's not that elegant. And we need to basically either we write a reusable function. So here I could have a function. I'm going to call it left movement logic. And we have the key. And we prevent excluded keys. Here we go. Excluded keys would work. And then here in this function, we would copy the if statement. Here, we would need, it's not a pure function because we need access to the player, etc. So maybe I need to also pass in. So I'm going to call it left player movement logic, pass in the player as well, and then the key for it, and then the excluded keys. So the key is basically going to be if the key is equal to the left key. No, that doesn't make sense. What we want is, because there's the key here, so on we need to pass in the key as the second param, but this is the key that is currently being pressed. So current key, expected key, and finally excluded keys. So here for current key, so actually we have current key equal expected key, and then here we would have excluded keys. I think that's the logic. So now here for the first one, I would simply call left player movement logic. I would pass in the player. The current key would be the key here. The expected key is left, and the excluded keys excluded keys would be an array that contains up down ws. Up down ws. Now this should work, but I think the return statement is going to be useless now. So let's try it out. If I press left, okay, k is not defined. We need to pass k in our left player movement logic as the first param then. And then here, why do we need k? Okay, because it's passed here, so let's pass k as well. Let's see if it works. If it works, it will fix our situation. Okay, I can go left. If I press both at the same time, nothing happens. All right, nice. Now, if I remove the return statement, because it's basically the only thing in the function. So, all right. It seems to work. Now let's try calling the same function again, but using a key here and as the excluded key. So now we need to add the excluded key a here, and the excluded key in our array here is going to be left. Now let's try this out, and then let's do both. All right, it works. Nice. Glad I found a solution. Now I think we could come up with a better one, and that's just not. I think we could come up with a much more general solution. But let's, for now, let's write another function that is similar but for the right movement. Even though I think we could abstract this out further, but for now let's go one step at a time. So we have the right player movement logic. Is there truly no way to... never mind. I think let's abstract it out. I think it's possible, and it's going to save us a lot of time. So here, we have 1, 2, 3, 4, 5 params. We could have a directional param, and then a directional param. Yeah, it depends, because this statement here is movement vector, basically. Move vector would be enough. So here we would replace this with the movement vector. It's going to be a vector 2. Move vec2. Or a movement vector 2, but move vec2 is better, I think. For the direction, we are going to specify it within, and I think this should be abstracted out. So, and then instead of left player, we can just call it player movement logic. Let's try it out. So I'm gonna call this player movement logic. I'm going to add here the direction as being left. The movement vector is going to be a k.vector2 and minus player dot speed 0, so that the player moves to the left. Let's copy this again, this time around here, outside, and then let's remove that as well. And I think it should work. Let's try it out. Let's try it out. All right. It does work. So it does work, and it's abstracting out a lot, so we can use it for the right here. So let's implement this as well for the right key. Player, movement logic. Okay. Player, the current key is key. Expected key is right. And then, of course, we have our array of up, down, WS, which are the excluded keys. And then finally, we have the direction, which is right, going to the right. And finally, we have our movement vector, which is going to be a k vector 2. And because we're going to the right, we can just do player dot speed 0. Now, how does this look? Looks fine. Let's copy and paste this again, but this time around with instead of right, it's going to be D. And then let's comment that out. So in the end, the viewer who told me that the return statement wasn't doing anything, well, it's basically preventing us from computing what comes after. So that was useful in a certain sense, but it did not help us at all. So in the end, it wasn't that necessary. So yeah, you'll have an unneeded computation, because when you run this code, you'll have to run this and this as well. So maybe we should have an if statement, but yeah, maybe this should return something. It should return a value, and then we put that within an if statement, and then if the player movement logic returns true, then we return early. Yeah, we could have worked on that, but first let's make sure that it actually works. So I can go, wait, what? Oh, the animation. We need to fix the animation. That's one thing we didn't abstract out. Player anim if the flip x value. That's something. Oh, come on. because now we're having too many params, I think. Because we have like the player, the current key, the expected key, the excluded keys, the direction, the movement, and now we're going to add whether to flip or not. Maybe we could just figure this out via the direction. So you would say if direction equal if it's equal to left, you would put true. Otherwise, you would put false. But then again, there's another issue that comes right after is the animation to play. So basically, we would say if it doesn't matter. We can use the direction, I think. Direction. So if direction is equal to either left or direction is equal to right. I forgot the other part of the statement. So if direction equal left or direction equal right, we want to play the player side animation. Otherwise, it's going to be the player player what? Player, if I look down, player up, player down. Oh, come on, it's gonna be complex. It's gonna be really complex. I don't want to add a switch statement with it. Okay, so we have a switch statement. We have the direction. And then here, the case. So if direction, we don't need that. If left, case, if right. Actually, it's a good thing. It's a good use case for that. And then we're just going to have play anim if not playing, pass in the player, and then the player side animation if you are either left or right. Now for the flip value, it doesn't matter on the if it's up or down. It only matters if it's left or right. So this can be kept, but yeah, you know what? We're just gonna do it here. It's going to be much more organized to just have like if it's right, then we set it to false. And we break. Now, because I have this, I have to also have the case player flip X. I could have not. You know what? We could. Yeah, because I want to play the animation either if it's left or right anyway. I'm trying to figure out if it's a better decision to have this, and so that we can reuse. We can basically have, because the way switch case statements work in JavaScript is that you have the case, and as long as you don't break, it will go to the next case. So if you have the direction being left, it's going to immediately go to case right and then play. But if right is false, yeah, wait a minute. If left is false, okay, you know what? For now, let's remove that. Let's try it out this way, and then we'll figure this out later on. If the case is up, then we want not up to, just up. If the case is up, then the play anim is going to be basically player up and player down. So player up, and then we break. You have to break, otherwise it goes to the next case. And then case down. But you might already... the thing I'm asking myself is that if you have case left, it's going to go to the case right, but if it's not right, then it's not going to do this anyway. So I'm just going to think, just looking at what the behavior will actually be. I don't remember. I don't use the switch case statement that often. It's very rare when I use it, but it seems to be a good fit in this particular situation. So here we break, and then in the case of default, we do nothing basically. You can just keep it. Wait, it's not case default, it's just default. All right, we have our switch case statement. Let's look at the output. So we have our, okay, so it seems to run for, like if I press left, it's going to go left. It's going to play the animation even when I press left. So that means that I can do player.flip flip x to being true here. I can do that, and let's see. So, and then yep. That means if I want to not have to repeat the logic here, I would have just basically a I would have to have a case that comes right after. This case is, can we have an empty case? Can we have a case called null that will just have this here, and then we just use player. So you might find it very weird why I have a null case. My logic, my idea behind is that we check the direction. If it's left, it starts here, and then it will move down. Ah, we can't do that. So I think there is no way but to. Well, let's try it. Let's try it. I don't think it will work, but yeah, it won't work. That's because it goes to the left, flip X true, then it puts it back here, and then it plays the animation. So we need to just, I'm basically forced to have a break here and to just duplicate that code. I think it's better to just duplicate it and not have this ternary operation that makes the code less clear. All right, so here we go. I think that looks good. And what? What happens? So I press right, left, and it's still. That's strange. Why is it doing this? Oh, because of that. Oh, that means the reason it didn't work was probably due to that. What? Okay, that's strange. We have the flip X. We have this. Oh, I forgot to break. That's why. Here we go. Now it should work. Hopefully. Here we go. We have movement. If I use WASD. Oh. Yeah, we have to fix now. We can use this function. Now it's a bit weird to call it player movement logic. Let's keep that name for now. We need to add actually the keys here. D. So when the player presses the right key, we want to exclude D as well. And then when the player presses the D key, we want to exclude the right key. Now, if I try it out, if I try pressing both, we freeze in place, but now this moves twice as fast. So let's fix that again. All right, so I'm going to remove the code here, and we're basically going to do the same thing. So I'm going to call player movement logic. So player movement logic is here. Now instead, we're going to have the up key. We're going to exclude the W key in that case, so it's already there in the list. So yeah. So that's because I copy pasted, that's why. All right, up key, when the up key is pressed, we want to exclude, we want to exclude, actually want to exclude a bunch of other keys. We want to exclude, Mm, Actually, we don't need to exclude anything but the S key for now. So let's use this like that. As for we're going up, that means we need to subtract the speed of the player vertically. And this is something I explained countless times why the coordinate system works that way, where when you increase the value of y, when you decrease the value of y, you're actually going up. Now here we're going to do the same thing. Oh, actually S, it's not what we want to exclude. We want to exclude W because up. And now here it's the reverse. W and then the up key. And then we keep this here. And that direction, of course, we need to modify that to being up. All right, up, up. And I think we can remove this logic. Let's see if it works. We're moving down, moving up. If I try both key, it freezes me in place, so that works. If I try to both press A and down, but some other directional key, I just want to make sure that the character doesn't move diagonally. It doesn't seem so, so that's great. All right, but now the only thing left is that if I press both S and down, I'm gonna go twice as fast. So let's fix this. Let's fix that as well. So I'm gonna take this. I'm going to again paste it. I think player movement logic is a weird name, but let's keep it for now again. I don't have a better name in mind for now. By the way, since I'm recording this tutorial in parts, if you're watching this, feel free to add any comments for improvements. It's most likely will be that I will be able to incorporate any feedback in the next part of the tutorial. As with this, for example, this was pointed out by a viewer, so I was able to notice that it was an issue and basically fixed it live on the spot here. Okay, so we have a player movement logic now here for down. So let's start with the down key. What we want to exclude here is the S key, and the direction is down. And I remove the negative. I copy this, paste it again, and then I would have here instead S, here down, but the direction is still down. And I think that would be it. All right, let's work it out. Yep. If I press all of the keys, I'm not moving twice as fast in any way, shape, or form. And voila. So I think that's basically it. Now, we could have further optimizations, but I don't think it's needed. So let's keep it here. As for the name, player movement logic, set player movement, maybe move player towards move player is actually, I think, a better name. So I'm gonna right click, rename symbol, player. Oh, we probably player, move player. Move player is a better name. Save. I think move player. Yeah, it's a better name because we have set player movement. Okay. All right, yeah. I think we have a better name with move player. I think it's more descriptive. It explains the situation better. I think we can improve it further, but let's work on something else. All right. Let's continue on with the dialogue and everything that is required here. And then once this is done, we're going to basically, if you have any improvement suggestion to improve the player movement logic, feel free to share in the comments. Okay, so now let's work on the logic for the dialogue again. Now, we displayed a single line, but we need to display more than that. So all the line of a current interaction should be displayed when the player presses on either the space key or something like that. Then we will work on how to freeze the player so that he doesn't move during a cutscene, for example. So let's do something like that. So inside of the dialog function, I'm going to create a variable. So just so you're not lost, the dialog.js file is what contains the file that contains the dialog function. It's within the UI components folder. So yeah. Now here in the previous part, we created this display line function. It's all fine, but we need to display more than just a single line. That's why I'm trying to write the logic for that here. So we have, initially we set the index to 0, and we're gonna use this to move over, to iterate over the various content, the various lines that are to be displayed. So let's replace the 0 with index here. Now the next thing we need to do is basically create a variable. I'm gonna call is finished. This is the variable. I'm gonna call it line finished displayed, and it's going to be initially true. The reason it's true is because it's going to be declared right after we have displayed the line. If you remember the await keyword within an async function, because we have this, we're pretty much sure that once it reaches here, we are 100% sure that once it reaches the line 29, the execution of the code, this would have the line would have been fully displayed. Now, if I'm going to create another const, this time around I'm going to call it dialog key, and this is basically, we're going to use the onKeyDown function to listen, not listen to basically, actually not onKeyDown, the onKeyPress event listener to listen on the space key, so that once the users press the space key, we display the next line. So nothing new here. The onKeyPress event listener is the same as the onKeyDown, just for pressing. It takes in the first param, the key you want, and then the second param is the function. Like I said, those onKey event listeners have two forms. They have this form where you have two param, but they also have the singular form, not the singular form, the form with a single param, which is the function, and then you can pass in the key here to get the specific key, the key parameter. So here at line 31, I'm going to maybe scroll above a bit so that people on YouTube will not have the code hidden by the player, the YouTube player. So here we're going to simply have an if statement. If the line has not finished displayed, then we return early, so that we don't start displaying another line when the current line has not finished being displayed. So once we're pretty much sure, because of this statement, that the line is fully displayed, then we increment the index, and then if content dot index. So basically we try to get the specific line from the contents array by passing in the current index, and if this doesn't exist, because either the index is superior, well, the only reason why this would be false, the content.index would be false, and because of the bang here, this condition is going to be true, is when the index goes beyond the maximum index the content array has. So this is a convenient way to not have to basically do a content, to basically check that the index is inferior to the content.length minus 1. This is a simpler way to have the exact same thing. So basically this if statement tells us that if the content, there's no content to display basically anymore, then we know that we have to destroy the dialog box. We can do that by simply using the destroy Kaboom function and passing in the game object we want to destroy, and we want to destroy the whole dialog box. So by passing in the reference to dialog box, we're going to destroy everything, the dialog box and all of its children. And here in this instance, in this case, we only have one child. So k destroy dialog box, but we also need to cancel the dialog key event listener that we're in. So that way, when the player will press the space key again, it's not going to try to increment this or display anything. So by canceling the event itself, we are pretty safe from that. And then finally, we're just going to return. Now I'm just going to leave a note for myself here to do freeze player, unfreeze player basically. Unfreeze player. This is just for me, for when we are going to write the logic to freeze the player. So by returning early, the reason I want to return early is because I want to write some logic that comes after, which is actually the logic where we're going to clear everything that was in the... So by displaying the line, it filled the text from the text container with characters, and we want to basically clear that so that the next line is going to be displayed. So I clear everything by reassigning the text property to being an empty string. Then I put the line finished displayed variable to being false, and I call the display line with the text container. And then one thing I forgot, of course, is to make this an async function so that we can use the wait here. And then we have the text container and the content index, the content of the specific line we want to display. And then because this is not a wait, that means the code after it will not execute as long as the line is being displayed. But the reason we check for line finish display is because the on key press event listener that listens on space, the player can decide to press space at any given time. It's not going to wait for this to... The code will not cancel any pressing of the space button as long as the display line has not finished display. This is not how await and sync work. So that's why we still need this, the line finish display variable that we declared here. Hope that was clear. So once this is finished, once the line has actually finished displayed, we can set it back to true. So let's look at the result. I enter the house, I talk to the man, I press space, take this sword, please save my son. He's captured, dungeon towards the west. Now, the last text here is not ideal. As you can see, it wraps here, and we want it to fit in all of the available space. Now here there aren't like a lot of options basically. Here I've selected the size of 32. Maybe we should reduce that size to being 24. If I look at my original code base, I think I set the width to being maybe, let me just look it up. I think the original font size is 30, not 32. So let's go with 30 so that it fits within the text. So yeah, Kaboom.js, it's very hard to work with Canvas with HTML DOM elements on top of it, because we don't have a lot of control over the canvas itself on how to position it. So that's why maybe I will be moving to another library or some specific project that requires using the DOM to have like more text and UI, etc. So something like P5 would be good. I'm also thinking of making tutorials on that, so I don't become a Kaboom specific YouTuber. All right. So as you can see, the text is displayed, and then I can move around. So I think that's a good segue to start working on state management. The first state we're going to control is basically to freeze the player. So we need to know when to freeze the player, and the best way to do that is to keep it within a state. All right, so let's go to our state folder. And in the state folder, we're going to create two files to start with. The first file I want you to start creating is the state manager, statemanagers.js. This file is just going to be used as a way to have a centralized way to import all of our state managers. And another file I'm going to call global state.js. Now, for the state manager, let's work on that later on. Let's first start with the global state. So the pattern I'm going to use is the singleton pattern. So for those who don't know, a singleton is basically a single instance of a function. You want to make of a class, but we're not going to use the class keyword, but it's going to be similar. So basically, the idea behind a singleton is you would have one. So in the context of object-oriented programming, is when you prevent the creation of more than one instance of a class. So basically, a class that can only have a single instance. And we want that for our global state, where we would like a single source of truth for that global state. But as you can see, not right now, but I'm going to create many state managers, and each one of them is going to have a couple of things that they take care of. The global state is really for things that are really global, like what was the previous scene, which language did the player select, the font size, whatever some major events in the game happened. So if the ghost was defeated, or if the sun was saved, if you see that, and whether or not to freeze the player. Now we have specific player specific state. For example, let me just show it to you. So if I look, we have the old man global state, the player global state. So for the player global state, you would have, for example, whenever or not the sword is equipped, or what's the max health if the player has the key, of if what's the actual health of the player, current health of the player, etc. So those would be player specific state. The reason I'm doing this like that is so that we don't have a singular object that contains the state over everything, and it's going to be like pretty big and everything. While the centralization is good, I think we benefit more than having like multiple state managers that take care of a class, of a certain class of state, rather than a singular big object that would do everything. All right. So, but for this game, I think because it's a smaller scope project, I think it wouldn't have hurt if you would have decided to just go with a single state. Okay, now enough talking. Let's start coding. So I'm gonna create a function, export default function. It's the only thing we're gonna export from that file, so that's why I'm gonna call it this way. I'm gonna call it global state manager. I think I'm gonna call it, instead of just global state. Yep, global state manager. And it's a function, and it's not a class. And you're gonna see how we're gonna basically have OOP, but we're using functions. So first we create a variable called instance, and we're gonna set it to null. We're gonna see why instant. Within this function, we're gonna create another function. So in JavaScript, you can do that. You can create function within functions. And basically, that's how you get the object-oriented programming without using the class keyword. You would just basically create a higher function, have your state variables as simply normal local variables within that function, and then within that function, the bigger function would create smaller function that have access to the scope of the global state manager. So those are not pure functions. They can reference what's outside, and that's how you get OOP without using the class keyword in JavaScript. Now, is there any advantage to using this instead of using the class? I don't know. I just like
I'm basically exploring this way of doing things. I think we could have just decided to use the class keyword, but maybe there are advantages to this way. Uh, but really, I think in JavaScript the class keyword is just syntactic sugar, right? If I read that right, it's just like basically the same thing as what we're doing here. So I guess it's what you like, basically. So in our instance function, it's actually here that we're gonna have our properties. So I'm gonna create the two property, freeze player, initially set to false, and the font size initially set to 30. And the reason we're keeping track of the font size is that depending on the language, so for French, we're going to need to reduce the font size a bit because French takes much more words to say the same thing as in English, basically. All right, so basically, if languages were programming languages, English would be JavaScript, Java would be French. So Java is known for its verboseness, and French is pretty verbose, if you ask me. All right. Um, Here we're gonna return an object, and this is where we're going to have all of our setters and getters. So here I'm just going to call the set. I'm going to create the set player, the set freeze player, set freeze player. Now here, because it's an object, you could have decided to write an arrow function and do it this way. But in JavaScript, you can basically do this as as syntactic sugar. This is accepted. So you can just define your function like that within an object instead of using the name and then two dot, like the name of the property, two dot arrow function. So this is a cool thing that I just discovered recently. And yeah, so I I just thought I would use it. So here the set freeze player, we're gonna pass in the value as a param and gonna set it here. So the value is gonna be set here. Now we need a way to get the state. So that's why we need the getter as well. This getter is just gonna return the freeze player basically, and that's basically it. Now here I think it's actually shorter to use an arrow function here because you know the arrow function, if you don't specify, if you just do it this way, it basically implies that it's going to return this. It returns this without having to write return. So for getters, it's actually simpler to do that. Now for the font size, let's do it as well for the font size. So set font size value, and then font size equal the value, and then it's poor formatting, and then get font size, and same thing, we just return the font size. All right, we have everything we need, and now we just need here, when we call the global state manager, we're going to return the get instance function. So get instance here is a function I create. In the same way, this is a function I've defined within an object. So this is equivalent to this, just to drive the point home. So I'm just going to revert to the syntactic version, sugar version. Now here in this function, basically if there is no instance, so if instance is null, then instance equal create instance. And that's the actual singleton pattern. We cannot create more than one. So if you call the guest instance more than once, the first time you call it, it's going to initiate the instance and create it. But the second time you call it, this already exists, and you would simply just return the instance as is. So basically, two cases. The first time you call get instance, it creates the instance and then returns it. The second one, it just skips this and returns the same instance. So you cannot have more than one instance. Now, if we go back to state manager, we're going to import global state manager from global state. Here again, be careful to add the .js at the end. And here, this is where things are going to get interesting. Well, not that much, but we're just going to export const. Wait a minute. Do we need to do that? Yep. Here I'm just gonna call this is just to have shorter names. So I'm gonna create a constant called game state, and I'm gonna call the global state manager function, and then get the instance. That's the only place where we're gonna get the instance, and then use the same instance in all of the places we're gonna use game state. So now let's use it. If I go to where we're gonna start, I think it's in old man. No, where do we freeze the player? In dialogue. So if I look up, where did I write this logic to freeze the player during a cutscene? So let's do that. I'm just gonna go here. All right. So basically, at the top, so right before even displaying the box, I'm going to call the game state from the state managers. .js, remember, that's important. Then in game state here, I'm going to use the set freeze layer method we created, and I'm going to set it to true. Now, this is all good, and then let's write here the logic to unfreeze the player. So game state dot set freeze player to being false. But now we need to actually go back to our player logic and to the set player movement. And basically, I think here, is it here actually? Let me verify if it's actually here. We need to write the logic. We need to use the game state to check whether or not the player is frozen, and if he is, or if they are, we're going to basically just prevent any movement from happening. So, yep, I think it's the first statement. We need an if statement here. If game state, remember this is going to import it from state managers.js. Here I don't understand. Sometimes it adds the .js and sometimes it doesn't. And I just realized that maybe I made a mistake. If I go back to the dialog, no, it's not a mistake. This is a named import, not a default export. So I don't understand why sometimes you have a .js and sometimes VS Code decides to omit it. So really, it's a mystery. If you have any answers to that mystery, please feel free to comment and share your knowledge. That would be great. All right, so in this if statement, we're gonna get freeze player, and if it's true, we're gonna simply return, and because this is a boolean, it's going to return a boolean. That means it's going to be either true or false value, and we're gonna return here. And this is another like good thing about TypeScript is that you see here in the global state, I have this setter for the freeze player, but it's just a value. It could be anything. If we simply had specified that this could only be a boolean, then this would also already guard us from this kind of mistake, or where someone would, in the code base, let's say you work on a team, would use set freeze player and I don't know, pass a string instead of a boolean. That means here expecting the string, expecting a boolean in the player.js. If it turns out to not be a boolean, then this is it's going to cause issues. And that's why you would here in normal JavaScript, you would have to write extra code to make sure that the type of this is actually a Boolean before checking the value, etc. And TypeScript saves you from doing all that. Now, TypeScript can be slow to start with, but you get productive because of those little things like that it saves you from. So that's something to consider if you ever want to, dive into TypeScript. So that would be, I think in this tutorial we've seen 2 or 3 cases where TypeScript would have been pretty handy. All right. I think we have everything we need for the freezing, so let's check it out. I'm gonna talk to the man, and as you can see, I'm trying to press the directional keys and to escape from the the man, but I cannot move. I can only press the space button, and it displays the next line. If I talk to him again, it's the same thing. All right. One thing before I finish this part of the tutorial, I would like to basically change the font size. Basically, what we want to do for now is go to where the dialog is displayed. So here again, dialog.js. And in there, for the size, we want to pull this from the game state instead of hard coding it here. So game_state.get font size. And later on, when we're going to create a menu where we can set that font size, this is going to update automatically without having us modify the code here. So if I go here, make sure that everything still works, same font size, and that works. So let's continue working on the dialog. What we want now is, now that we have basically wrote the logic to display a single line and multiple lines, we want also to be able to move on to various different dialogues. So to do something like that, we're going to have to go to the old man logic. If I just go back to the content folder, if you remember, before that, we had a set of content, so a set of dialogues. So we have the first set of dialogues, which are a bunch of lines that are displayed. We want basically the old man to move on to the next when talking to the player. So let's go to oldman.js and write the logic for that inside of the start interaction function. So basically, after having written the logic here that you see for the direction, we're going to have the response and select the language. Now, this is something that would better go in the state manager, in the global state, where the language is set from there. So that's a tangent from what I wanted to do, but let's do it now so that we don't forget. So in global state.js, we're going to go there, and after having gone there, we're going to create another state variable. It's going to be called locale for the language. You could have, I think locale is a bit of a weird name, but let's use locale. You could have decided to go with simply language, but yeah, let's just go with locale because I don't have a reason. It's shorter, I guess. And we need, of course, to create the setters and getters for that. So let's do just that. Here we need the set locale, a value, and then actually I want to use the syntactic sugar version. So here, whoops, sorry, I need to manage my cables. They're interfering with my keyboards. That's why I'm struggling. Okay, so we have the set locale value, and then locale equal the value. Okay, this is basically simple logic, and then get locale, nothing new here. No need for value, just the arrow, and return the locale. Now here in the old man, we're just basically going to, instead of having a dot English, we're just going to go here and call the game state, and then here get locale, so that it will automatically change the lines depending on the language. So game state is imported properly here with the .js. Make sure that this is added. It's really important, otherwise you're gonna get a bunch of errors and you're gonna be confused and lost and why it's happening, etc. So yeah. All right, so now in oldman.js, we're going to basically need to keep track of how many times the player has talked to the old man. And I think that's where we're going to have to basically create the old man state. So here in the state folder, let's create a new one, call it old man state.js. Now I think the M is lowercase in my original code base. Let me look. It's not old man state, it's old man global state. Global state. All right. Okay. Now that we have this, we're going to follow the exact same pattern that I've shown you with the singleton. So I'm just going to paste it here. So in the end, there isn't much we need to keep track of thinking about it. Now it's really up to you if you want to create a whole separate manager for this, or keeping this inside of the global state. Now, depending on if you decide to expand the game further after this tutorial, then this might come handy to have it separated. So that's why I'm going to keep it. So yeah, really just copy this code, old man global state manager, export it. And then in the state managers, we're going to create another constant, export const old man state, and then equal. I'm just going to make sure I have the proper names. I really want to follow the names exactly as I did them before, just to not have any issues later on. So yeah, it's the correct name. And then I'm just gonna call old man global state manager. Same thing, make sure to have the .js in the import statement, and then get the instance. Now the instance here, we can use it. So let's go back to so just to go over the code in the old man global state.js, we have the number of times we talked to the old man, which is number talked old man function variable. Initially it is set to 0. The reason we need this in a state manager is because we want to keep track of this independently of the current scene, because if we were to keep this logic only within the current scene or within the game object, this information would be lost when we exit that scene, because the way it works is that every time you enter the house, we recreate the game objects. So we recreate the old man. So if we were to keep track of the data for this, the number of times that we have talked to the old man, it would be lost when we exit the room and come back. So that's why we need it, because we want the old man to say different things when the player talks to him again, even if they exit the room and then come back. So that's why it's necessary to keep this state outside and global, basically. All right, let's go to oldman.js. And then in oldman.js, right before the dialogue, right before the dialogue, we're going to have to make an if statement, and this if basically a variable and then if statement. So let's do just that. Now we're going to need to keep track of, like I said, the number of times talk to old man. So let's create a variable, local variable within the oldman.js start interaction function here, and we get the state from the old man state that is imported, so it should appear here. And then we're going to have a dot and then get a number. What's the name of the function? I don't remember. Get number talked old man. The name is a bit weird, but let's keep it that way so as to not as we don't want it to get too long. So we have this, the number talked to old man, basically. We get the current value for that, and then if this value, number talked old man, is superior to I think responses, so number of responses, the number of dialogues there is, dot length minus 2. So basically we want the dialogue, so response.length is the number of dialogues there is. So if I go back to the content folder and then the old man.dialog, we have 1, 2, 3, and 4. So so it's going to be a length of 4. But what we want to check here in this if statement, we want to make sure that the number of time we've talked to the old man is superior to 4. Is it 4? Yeah, 4 minus 2. That means we've talked to it, well, 2 times, basically. The reason I'm doing this is basically to know when to reset the dialogue to being here. So the reason behind this is the first time you talk to the old man, we want to display this dialogue. So he tells you that it's dangerous to go alone. Take this sword, press space to use it. Please save my son. He's captured in a dungeon towards the west, and I will reward you handsomely. But when you end this dialogue and talk to him again at any point, we want to start from here and not here. So that's why we increment the number of times you've talked to the old man, and we set it to 1. And then this will be displayed, and then you'll have, once this is displayed, this, if you talk to the old man again, this will be displayed, and then if you talk to the old man again, this will be displayed. And then if you exit the room or talk to him again right after, we want to go back to here. So that's why there is a 1 here. So let's work on that. So I'm going to write the inside of the if statement in the oldman.js. So here, I'm going to paste it here. So old man state, we set it to 1. And then the number of talked old man is going to, basically, we get the state. Now, the reason we get this is we could have decided to just put 1 here, I think. But it's for later on when we, right below, we have another if statement. So this if statement is when to reset the dialogue to 1, basically. So we reset the dialogue to this dialogue, not the actual first one. Because the first one, we want to only display it when it's the first time the player talks to the old man. So that's why this is here. And that's why we have the response.length minus 2. We want to make sure that the player has talked 1, 2, and then 2 times. Now I think this might be a bit strange, because as long as this is superior, then we want to set it back. Okay, I might play with this around live just to really understand what I want it to do. I don't think it's ideal to have this condition because it's not that clear what it does. So let's first write the if statement that comes right after. So in our responses array, here is how we decide to select which, this is how we decide which dialog to select. And so we have this first if statement, the second if statement, sorry, where we first try to fetch the dialog that corresponds to the index here. We first check if it exists. If it doesn't exist, this would not work, and that means we would just move on. Now here I'm gonna call the await dialog. So I'm gonna take this line of code that I've written previously, paste it here, and then here I'm going to replace the response with number talked old man. Number of times talked to the old man would be a better name, but I think it's too late for that now. And then after that, we have, if I go to line 43, we can set the old man state to being the set number of talk to old man, and then it's just the current value plus 1. So we first display and then move on. And then remember, we need to await this. We need to await because we want to display, we want to change the number of talks to the old man only after the current dialog has been displayed. And that's why we use the await keyword here, because this anyway is asynchronous. So it's going to execute while the JavaScript code will continue on this function, the rest of the body here. We want to prevent that, so that's why we use the await keyword. Now, so we have the old man state here that is incremented, and I think that's the whole logic. We don't need much more than that. So I can remove the dialog here, and let's test it out. So I go here, I talk to the old man. It's dangerous to go alone. Take this sword, press space to use it. Please save my son. He's captured in the dungeon towards the west. I will reward you handsomely. Then I go and talk to him again. You forgot how to use your sword. Press the space key to attack. Please now go save my son before it's too late. And then if I go and talk to him again, please save my son. And if I look back to the code for that, in the dialog, this is please save my son is here. And I understand why we have the response -2 is because the fourth and last dialog is only to be displayed when the son is saved. That's why it's -2 here, because usually you would do -1 for the last index of an array, because response.length they give you the number of elements, but since index in an array starts with 0 and not with 1, you would always have this offset where you would have for an array of 4 elements, it would be 0, the maximum index would be 3 and not 4, because it starts with 0, 1, 2, 3, and for your 4 elements. So that's why you would, if you wanted to check, make sure that your index is superior, you want to make sure that your index is superior to the maximum index or inferior to the maximum index possible. You would take the length of your array and subtract 1. We want to subtract 2 because the last element of our array, we don't want to display it until a specific condition, the son is saved. We're going to later on write the logic for that. But yeah, so if I go back to the code, the game, I talk to the old man. It's dangerous to go alone. Take this sword, press space to use it. I'm just going to skip over the dialogue. The thing I just want to show you that if I talk to him again, things are going to be different. But now what I want to show you is if I exit the scene and then go back. Please save my son. You see, it continues. You forgot how to use your sword, etc. So it remembers the situation. All right, so that's about it for this part of the tutorial. Hope things were clear. Next part, we will continue working on. I think it's time to implement the sword attacks. And once we have this done, we're gonna write the logic for damaging enemies and taking damage. Then display this on the screen. Once this is done, we're going to display the dungeon. This is a whole other logic we haven't done. So yeah, let's do that. And then I think we're gonna deal with a lot of states. So the order isn't yet decided, but there's still a lot of work to do. So see you next time. Hi everyone, welcome to this fourth part of the Zelda-like JavaScript tutorial. So in today's episode, we will work on implementing the sword fighting, so giving a sword to the player, unlocking that said sword, and also dealing damage to both the slimes and receiving damage, and also displaying the hearts, the number of hearts. Now, if we have some more time, we will do the last part of the tutorial, so basically work on the dungeon
and the ghost enemy, etc., and keeping all of the states. I estimate that this might not be the last part. There might be another one, but after that, I think maybe I could end the tutorial in 2 episodes of 2 hours. So let's see how it goes. I don't know as I'm recording this, so we'll see in the editing process, and you on your side if you see a final in the title, so you've got the answer basically. Let's jump right back into our code base, and let's I need to try to remember where we left off. So I think we're going to go to the player.js and start implementing the sword attack basically. So to do something like that, we will go to the set player movement function. This is where we're going to on a after maybe I'm trying to figure out if we should do this after the on key down and after the key on release. So yeah, let's do it between. So it doesn't matter. Basically, it shouldn't matter at all. Just in terms of organization, we put all of the keys that do something, and then at the last we do the release. So on key should be near another on event listener, on key down. I think it's on key press this time around. Yeah, on key press. So yeah, you can decide to organize this however you'd like. It doesn't matter in the long run, or even in the short run, basically. All right, so I'm going to use the on key press event listener, and in there, I'm going to basically follow the same pattern where I put the key, and then here within, we need to basically check for the space key. So basically, now the way I made the game, there isn't another way to attack. So both when playing with WASD and when playing with the arrow key, you should just press the space key. So what we want is basically have a first if statement that checks if the key is indeed the space key. And if it isn't, so basically the contrary to an equal, so this, then we return early. By returning early, we will not run the logic that comes afterwards, which is the logic that is going to handle the sword. So now there's another check we need to do actually. We need to check if the player is in a cutscene, because if they're in a cutscene or in a dialogue and they're talking to the old man or something like that, we don't want when they press space to launch a sword attack. We want the player to be able to move on to the next dialogue if there are any. So that's why we need to also check if, using the game state management thing here that we created, my state manager, we want to check if first we get the freeze player attribute, and if it's true, then we also return early. Now that this is done, I think we can basically write the logic. I think that there is another third statement here, is we only want to launch this attack if the player has unlocked the sword, basically. So we haven't created the player state. So we have a global state, an old man global state, and we should also have a player state. So let's create our state manager for the player. So here in the state folder, I'm going to create a new file. Here. I'm going to call it player global state.js. Inside of this file, it's going to take the same structure that we've seen previously with the old man. So instead of like typing this out slowly, to save some time, we're just going to copy paste. I'm just going to copy paste it, and then you can just either pause. Here is the code. So first we create the instance, same patterns basically. We have the set sword equipped. So here are a couple of variables that we're going to need later on for the health, displaying the health and keeping track of the health on the various scenes. So we want the player max health here, which is basically a constant that we're not going to modify, but the health variable here is only for is where we actually keep track of the actual current health of the player. And then the has key variable here is going to be useful later when we are going to write the logic for the dungeon where the player is fighting off a ghost. After the ghost is defeated, he should drop a key, and when the player collides with that key, we need to set this to true because this is going to be important to deliver the sun, which he's locked in the prison, basically. So here are all the appropriate getters and setters, nothing new here. And then just so you can see the entirety of the code, we have this place, the return, and the get instance. So I'm going to hit save. I haven't hit save. So yeah, so that's the code. Here, pause. You can also pause here, and of course the instance. Now we need to add this to our state manager. So here again, I'm just going to copy paste it from my original code base because I don't think we benefit much from typing it out on your side. I think by this time you have understood the concepts. So basically the same. Oh, I pasted it twice. I'm going to remove that and let's okay, so here we go. All right. So now we have the player state exported as well. Let's save. We also need to add the import statement for it. So something I forgot to do. So player global state manager. Don't forget to add the .js at the end. All right, now I need to go back to the, I think it's the player file where I didn't hit save. Yep, it's here. So now what we want to do in the player.js file is we basically want to write another if statement. I'm going to call it player state dot get. Now I don't remember actually all the field. What's the name of the field? Can I find it here? Player global state is sort equipped. So I'm just going to copy it so to avoid making any typos. I have too many files open, so let's remove a lot of them that aren't needed currently. All right, so here I'm going to paste this. So get, actually, you need to use the getter to get the variable. So if the player state dot, if not, so if the player did not unlock the sword, so this should return false and then become true because of the bang sign here, and that's when we need to return early because the player has not unlocked the sword. Now, once all of these assumptions are proven to be false, that means we can continue on. And this is where the logic for the sword attack is going to go. Now here you might have noticed that we have a is attacking boolean here, and the reason it's here and not in the game state is simply because this is an attribute we don't need to track outside of the current scene. So for health, this is important because the player health will carry over regardless if you are in the house scene or you go out to the world scene or you go to the dungeon scene. So that's why we keep track of it in a game state, a global game state. All right, so here we're going to have player is attacking. We're going to set that to being true. So that later on, some other system in our code base will know that, hey, the player is attacking, so let's deal some damage if, for example, the slime collides with the hitbox of the sword, for example. And this is something we're going to have to add the sword, the hitbox. And we're going to do it just right here. So here, what comes after is another if statement. And then in this if statement, we're going to have the following code. First, the condition. What's the condition? The condition is we're going to use the get function of Kaboom. So Kaboom allows you to get any game object on the screen that has a tag, a specific tag that you pass in to the get function here. So here we want to check and we want to get all game objects that have the sword hitbox tag. And because this returns an array, we want to make sure that this is equal to 0 before creating another hitbox. So the way it's going to work is basically when the player hits with a sword, we create a hitbox near that sword that is going to be used to check if the slime is colliding with the sword. As soon as the attack is over, the sword hitbox will be destroyed. But because the player can press the space key, so the attack key, in multiple successions, and not leave like really right after the other, we can arrive in a case where two of those hitbox would be created instead of just one. And because of that, we need to really make sure that we don't add a new hitbox, sword hitbox, if there is already a one existing. So that's the logic behind this if statement. So within, we're going to create the sword hitbox position x. So basically, this is an object that is going to keep track of which position to use for the sword hitbox, depending on the direction the player is attacking from. So, for example, if the player attacks from the right side, we're going to move the hitbox, we're going to place it to the right side. And to do something like that, it's a bit complicated. So that's why I'm just going to keep track of all of these positions in these objects. So let's first start with the left side. So first, I'm going to take the world position of the player, and we're going to offset this. Now, you might be wondering, why did I not create a child game object to the player for this hitbox instead of creating a separate a separate game object with a position that we're going to do this calculus manually. So if the sword hitbox was a child of the player, we wouldn't have to first get the position of the player and then subtract the offset. The reason for this is that I had a bunch of issues with that, and I think it's due to the fact that I don't think you can destroy a child object without destroying the parent. And because of that, it's not handy in this specific situation. So now I'm just going to copy and paste everything here to speed up the process. And all of this might seem a bit abstract for now, but follow me through and then you'll see the result in the game, actual game. And we'll use the debug mode from Kaboom to see the various hitbox that gets created. So the right key here is the same thing. Now, why the values 10, why 5, etc. This is what looked good. So yeah, it's a bit hard to explain, but you need to experiment with those values. Try when we get it working to just modify those values, and you're gonna see how the box moves. The hitbox moves depending on the direction, etc. And then you're gonna see that, hey, if you put more than 2 here, the hitbox is going to be too far away from the sword, from the player sprite with a sword attached. So the sprite we're using for the sword attack is not a separate sprite. It's the same like player sprite, just drawn with a sword pointing left. So that's why you need to move the hitbox so that it actually fits with this new animation. Hope it was clear, and if it wasn't, don't worry, it's going to be clear in an instant. Now, you may not notice that this is what we did for the X positions, but we also need to configure everything for the Y positions. So when the sword hitbox is supposed to be on the left, here's the Y coordinate we're going to use here. So by using those key left and left, we're going to get a vector 2 where we have the X coordinate of where to put the hitbox and a Y coordinate of where to put the hitbox. All right, so now right below here is where we do the creation of the game object. Here again, nothing new. We use the add function. Here I'm going to again copy paste the code to go faster, and then explain it. So basically here nothing new. We create a rectangle as the shape of the area, and it's going to be of a size 8 by 8. And if you remember here, it's the position and it's 0. So it's really the same position as the game object that is using the component, and therefore there aren't any offsets here. Now the position of the game object is going to change and is going to change according to the player direction. So if the player is going left, we're going to take the sword hitbox X and take the X position for the left direction. So this, and this is what is going to be placed here. Same logic for the Y. Now that we have this, we need to write the logic for when we're going to destroy the hitbox. And here we do this by using a wait function that comes from Kaboom. It's going to wait 0.1 seconds. It's basically a easier to use, I guess, a more syntactic, sugar friendly set timeout function that is offered by Kaboom. So it's called wait. So we're going to wait 0.1 second and then run this function. So basically we use the destroy all function from Kaboom to destroy every game object that has the sword hitbox. Now there should be only one because of this if statement, but there isn't a destroy. Well, I think there is a specific. You can destroy a specific hitbox, but just to be safe, we destroy every hitbox that every game object with a sword hitbox. Now right below we have an if statement. Now this if statement has it's going to check if the player direction is either left or right, and if it's left, it's going to play the player side. If it's left or right, it's going to play back the player side animation, but immediately stop it. This is so when we attack, let's say you attack to the left, you're going to run the animation to attack to the left, but as soon as the attack is over, we want to go back to the idle state to the left. And a way to do that without having to create some other like idle animation is just you play the side animation and immediately stop it. So it's going to stop on the first frame of the player's side animation, which is basically our left idle state. Yeah, for our player, left idle animation. So that's why we do this here, and we return early so that this won't be executed. In the case that the direction is not left or right, we're going to play the player the specific direction, either up and down, and then immediately stop it because of the same logic I explained, where we want to end up on the same idle animation. So here the player stop on key release. We want to also add to it that if we want to set actually the player that is attacking attribute to false, regardless if it was true. Well, actually we could it doesn't matter, let's just set it to false always when any key is released. Basically it's only when we press the space key, then the attack is set, is attacking is set to true. So that's yeah. All right, so now we need to actually, I think we got everything we need for the attack logic, but we actually need to display that animation. Yep. Okay. So if I go back to my code base and I'm going to look where I did that, first we need to unlock the sword, and unlocking the sword, so basically setting this, is done in the house scene. It's done by the old man. So here in start interaction, we need to actually go to the old man code. So here, if basically we set it here. So in player state, set is what was the name of the state variable? Is sword equipped, and the get setter is set is sword equipped. So I'm just gonna copy that over. So if I copy that and I paste it here, and we set it to true, so now we have access to the sword. Now let's test it out. Let's test. I don't think the animation will be displayed first, but okay, it's dangerous to go alone. Blah blah blah. Thanks. If I did I just lag the... Yep. Player state is not defined. I did not import things properly in player. Okay, maybe that's
player state. Now let's look up. All right, we're in. Let's talk to the old man again. All right. All right, if I open, you see? The headbox is displayed. When I press the, whoops, this looks bad. All right, so here, unlock the sword. And then if I go in debug mode, you can see the hitbox for the sword being placed. Now if I go out, you can see I still have access to it. No, we haven't written the logic for any damage, so that's something that's going to come later. So basically when the hitbox of the sword hits the slime, he should blink, basically. All right. Now that this is done, let's look at the first importing the animations for the sword attack. So to do that, we need to go to main.js. In main.js, let's go, I think, because I have player idle down and then slime here. I imported twice. Sorry if I imported this twice and you noticed the mistake. Probably you didn't. Okay, at the end of the last player animation we added, we're going to add another animation. It's going to be player attack up, down, and left. Let me just bring that to the screen. Here again, nothing new. It's a single frame animation derived from tiled again. I looked at the numbers. I've explained this multiple times now, so I hope it's clear now. And I'm not going to bother you with more explanation on the same thing again. So here, now we need to actually set the animation when the player attacks. So here, we have the on key press here. So at the end of it here, we're going to actually run the animation. So play anim if not playing, and it's very simple. You basically have the player, you pass the player, and then a template string that is going to change depending on the direction. So if I save this, we should have a working animation. So let's test it out. Let's look at the actual output. I'm going to talk to the old man to unlock the sword. So yeah, this state management only works during a single game. It won't work when you come back to the game or reload the game, because if you would like to have saved data, you would probably have to use either local storage or have a server that's going to keep track of that data. So yeah, okay, now we have our beautiful sword and it actually works, and that's pretty nice. I'm glad we arrived to this point. And now here, yeah, nothing, no damage for now, but it's soon going to change, hopefully. So everything works, and that's the most important part. So at the end of the file of utils.js, because it's also going to be used the same logic for the ghost, for when we attack the ghost. That's why we're going to first export a function. I'm going to call it on attacked, like you saw earlier. And here it's going to take in an entity. So it can be either a slime or a ghost. And of course, at first we need to pass in the context. Once this is done, we need to so have a entity.onCollideListener, and then here sword hitbox. So basically, when the entity, whatever it is that is passed here, collides with the sword hitbox, we run the function. And this is a listener, so every time this happens, we run that function, not just once. Yep. And then here, and that's where the if entity, oh, okay, so never mind. I confused my own self. Here, the entity is the entity attacking. Wait a minute. Is it? I have confusingly named. Did I name this blink effect? Which entity it's supposed to be? I think I made a blunder. I wrote this function. If you were to read it, you would think it's the contrary. It's the slime that's being attacked that we pass here, and not the player. So I'm gonna look into it, and if I notice that it's indeed it's the slime that is passed here. So here checking whether or not. Okay, it makes sense. It makes sense. It doesn't make sense to you right now because we haven't added the is attacking property attribute state to the slime or the ghost. But basically, the logic behind it is that if the slime was already attacking you and they collide with the sword hitbox, we don't count this as an attack, a successful attack from the player side. That's why it's entity dot is attacking and we return early. Attacking. Whoops. And then we return early. That's why it's like that. Now here, if I go back to my utils.js, now here, if we continue on, if we continue on, this is where we're going to check for the HP. Now this is something that comes from Kaboom, the HP thing. And if we look at the slime.js file, you will notice that we had, oh, I did not add it yet. Okay, so there's a component in Kaboom.js that allows you to keep track of HP. It offers you the HP attribute, where you can just get the value of the HP and a hurt function and heal function, so that you don't have to do it yourself. The reason I did not use it for the player is because it's not global. It's just when the player, the entity, the game object is within the given scene. So here, but for the slime, because they don't move, they don't go from one scene to the next, it works here. So by the way, let's just add this in slime.js. Let's add the HP component so that it's available and we can use the HP function. Actually, it's called health, the component when you use it. So here right below line 14, at line 15, I'm going to add k.health. And here you set the value, how much health you want. And here health is just 3. We're also going to need the opacity in a moment. Okay, we already have it, so that's great. But here the health, we set it to 3. And therefore, every time we hurt, we're going to remove 1. Or 0.5, I don't remember actually. I think the player's attack power is 1. Let's go look it up. So player.js, the attack power is 1, but the slime attack power is 0.50, 0.5. And that's because it's just going to take you half a heart every time. So that we're going to have to deal with that state as well later on in when we're going to do the UI part where we need to display the hearts. All right, so let's go back to utils and continue on where we left off. So in utils.js, we're going to have to do a k.destroy the entity. So here the slime or the ghost when the HP is inferior or equal to 0. And that's basically it. And then here, we're also going to have the await and call the blank effect. This is a function we haven't written yet. So let's call it here and write the function right after. So what this function does, it's just going to give a blanking effect to the entity you pass as a para. Now, because this is await, we need, of course, to have this as async. And then right below, so after blinking, this is where we actually entity.hurt. We hurt and remove 1. So if the HP is completely 0, we destroy the entity. And basically we should also return early. I did not do this in the original code base, it didn't matter, but I think it makes more sense. It makes more sense, right? Because if the HP is inferior or equal to 0 and we destroyed the entity, we should not make it blink and reduce the entity further because it no longer exists. So that was probably an oversight on my part. in the original code base I made. All right, so now I have this, and then the blink effect. Let's write this. It's going to be again in the utils file we're currently in. I'm just gonna put it right on top. Here's the code. I'm gonna go over it instead of typing it out. So blink effect and a sync function because it's using the tween. Now I'm using the await version of the tween, the sync version, so that what happens here is that we tween from the current opacity of the entity to 0, so that the entity gradually disappears from the screen in 0.1 seconds, following a linear function, easing function. And this is the function that sets the new value at each iteration. And the reason that why this is await is because we don't want to move on to the next, because tween, the tween function in Kaboom is asynchronous by default. So if you just call it without calling await in front, it's your code, your JavaScript code will continue executing even if this is not done. So that's why we want to first wait here, or wait for the opacity to go from 1 to 0. So initially it's set to 1. So the opacity in Kaboom.js is a value that is between 0 and 1. The reason we can use the opacity property here is because in the slime components, when we created the slime, we have added the opacity function, opacity component, sorry. So that's why it's available. And now once the first part is done, so from fully visible to invisible, we do the reverse. So we take the current opacity, which should be 0, and we go back to 1 in 0.1 second in a linear fashion. So that's how the logic works. And here we call it basically. So now we just need to add this to the world.js. We need to add it here. So on attacked. And it's also going to be used for the player, I think. Or maybe I wrote a specific function for the player, because the player logic is going to be different. All right, so we have an on attacked function. We're going to set it for all slime. And let's save. Why it's not highlighting this properly, I have no clue. But basically we're passing this here. So now let's test it out. So I need to wait a minute. On attacked is not defined. Oh, that's why. We have to import the on attacked from the utils.js. On attacked, and then here we go. So did I export it? Export on attacked. Everything should work normally. So if I enter, I talk to the old man, unlock the sword, start using it. Now if I go and I start attacking, yeah, you see it blinking. So let's just try it out, and it disappears instead. Now there's one hiding here. We destroyed it, and just to make sure that it works for everyone. Now we are not taking any damage. It's just us doing the damage to the enemies. All right, it works. Okay, so now let's do the other side of the equation, which is the player taking damage himself. And then once this is working nicely, it's time to actually work on the UI. Once the UI is done, then we can deal with the last portion of this tutorial, which is the dungeon. And I'm starting to think that it's going to be enough so this might be the actual last part of the tutorial. By the way, if you have any ideas of any other games you want me to build, to try to show you how to build in Kaboom.js, feel free to use the comment section for that and suggest ideas. I'm open to them. I don't promise that I'm going to do any of them, but it's good to collect feedback and ideas. So I could get inspired, as we say. All right, so now if I go back to the world.js file, we need a separate different function for when the slime collides with the player, because now it's going to be the slime doing the damage to the player. And because in the utils.js, we were doing. Actually, I just realized something is that we're hurting the player once, but we're not using in the player.js the attack power at all. It's as if it's not happening. So yeah, that's a blunder. So we need to fix this. We need to fix this. So fix this. It's not an issue in the sense that your game will still work, but if you were to expand this into a larger game, you would immediately realize that, hey, I cannot modify the attack power of the player. So that's an issue. So to do something like that, we're going to have to pass the player. So it's pretty much mandatory. There's no way around that. So we're going to have the player passed in as well. Is there a way around this? I don't think so. Maybe you have a better idea in the comment section. I'm going to go with this, but if you have a better idea, feel free to share. So here I'm going to just pass the entities.player. As the third argument, I'm going to also put the here instead of 1, I'm just going to pass in player dot attack power. That way it's going to be scalable, it's going to be modifiable. So if I go and talk to the old man again, get the sword again, I know it's a bit annoying, but yeah. Anyway, so can I attack? Does it actually work? Yeah, it does. All right. Okay, sometimes wait a minute. Does it actually work? Yep. All right. Okay, there's still there seems to be a little glitch where I can attack when I press so much the attack button while moving that it basically do this. That's an error that's an issue that wasn't in the original code base. That's because I wanted to support more than one control scheme. For example, it actually worked with WASD. I can not attack. Wait a minute. Yeah, so basically, it's going to take some time to solve. I would say that's an exercise left to the viewer because I don't want to deal with this right now. I know that I should probably have stuck with my original scheme, but the idea behind it was that when you move, you shouldn't be able to attack. It's only when you're stationary that you can attack. But that's something that is debatable because I don't think maybe top-down Zelda games do this or not. I haven't played a top-down 2D Zelda game in a long time, so I don't actually remember how it was. So yeah, depending on if you want to allow the player or not to attack, you'll have to change the logic here. But let's move on to the rest of the project. So right below in utils.js, I'm going to create export function. Here again, instead of typing it out to go faster, I'm going to use the onCollide with player. So this function is something I have named it onCollide with player. So when the entity here collides with the player, we have this entity onCollide with the player tag instead, which gives us access to the player here instead of having to pass it around. We cannot do this here because the tag we're looking for is the sword hitbox and not the player. So here you would have access to the sword hitbox game object itself, but not the player game object. That's why we are pretty much stuck with passing it inside of this function as a param. Now here, if the player is attacking, we return. So that's basically mean that if the slime, so if the slime was attacking, but the player was also attacking, then basically it cancels out, so no damage is dealt. Here in the player state, we set the health and we reduce it, so we get the current health minus the entity that is colliding with us, with our player. Its attack power, we reduce that. So for example, for slimes, it's 0.5 their attack power, so that's why they don't do a lot of damage. And then we destroy all health containers. So this is something that's going to come up later. It's where we're going to actually do the logic for. Let's comment this out. But this is basically where we're going to basically wipe out the whole UI for the health and then re-update it with the correct numbers of hearts and half of hearts. I thought it was easier to do this than granularly, I guess that's a term, to or surgically to just remove the portion we don't need. I thought it was much easier to just wipe out everything and then just set the correct number. So yeah, that's something you could work on improving if you want. Here, health bar. This health bar function is what will create the health bar after having destroyed all the health. We're going to add this in an instant. So I'm going to comment those out for now. And of course, the player must blink. And then here for actually when the player dies, so when the health is 0, I have preferred to put this here as a function. So it's called watch player health. Now it's debatable whether or not it's a better pattern than just. It seems to me that I should just get the I should just do this logic here. So I'm just gonna copy what I had initially and just do that. So it seems better that you blink if the player state health is 0, then you set back the health to the max health and then you go to the world scene. Basically, it's like a respawning, because remember, when you use the go function to go in a new scene, I'm going to basically use the spawn point to put the player there and recreate the game object, etc. So that's basically a respawn. Instead of having to create a method, I called initially watch player health and then put it in player.js. I think it would be it makes more sense. Now there is it's debatable if this should go even in the utils.js, because this code is basically very specific to the player. So maybe we should just put all of this inside of the player.js, but maybe this is going to be more generalizable later down the line. Let's say you have 2 players, etc., or some kind of other situation. So yeah, feel free to put this wherever you want. For the tutorial, try to follow as closely as possible. Maybe play around and then come back just in case you get stuck later on. But yeah, so I'm gonna keep it here. It doesn't matter for this project, but it's definitely some questions you should ask yourself where to put things. And here I just I probably had something else in mind, but I kept it here. I don't have the added context, and maybe that's why I should add comments. I should add more comments. So yeah. All right. Let's go back to world.js. Here, let's call our onCollide function. It's onCollide with player. onCollide with player. That's the name. We pass into K. We pass in the slime. Is it the slime that we pass in? Yep. Yeah, it's the slime. All right. But now that we have this, I forgot to hit save, I think, or maybe it's not here. It's here. Okay, what did I change here? I don't think I changed anything. All right, never mind. It's just I forgot to hit save. All right, so now we have onCollide with player. We need to go to world.js, have it here, but don't forget to import it here right below onAttacked. So onCollide with player. Now we should be able to take damage and basically die and respawn as a player. So let's try it out. So here's the game. Let's go here. Let's wait for being. Oh, I see an error. Player state is not defined. Oh, why is that? I forgot to import it in utils.js. Okay. So I need to import player state. Don't forget to add the .js, otherwise nothing's gonna work. .js. We are ready to test it out. So I'm not gonna bother getting the sword. I'm just gonna see if I take damage or not. Okay. Okay, I took damage. Took damage. And then I respawn. Basically, that's that. Let's take some damage again. and then again, and then I respawn. It works. So now let's work on the UI. So basically we're going to use the UI components folder, and in there we're going to create a healthbar.js file. So I'm going to go here, I'm going to call it healthbar.js. In that file, what we're going to do is basically have all of our logic for creating the health bar, basically, depending on the current health of the player. So this function, I think, again, it's going to be much quicker for me and you to just paste the code and explain it to you. There's no new concepts here, but I'm just gonna, yeah, there's no new concept in terms of Kaboom APIs. So here I'm just gonna go line by line and explain to you. So first, create a function, call it healthbar, and pass in the context, of course. Now don't forget to import this at the top. We're gonna need that. So what it does, okay, we create at line 4, we have a variable called numbers of full hearts. Number full heart, number full hearts, sorry. And what we do is we get the current health by using the get health function from the player state manager, and we floor it. So let's say the player has 4.5 health. Well, we are only interested in the full hearts. So we're going to get the full hearts by just flooring using the math.floor function from JavaScript. Now we're also going to have this Boolean that tells us whenever or not to add half a heart. And here, this first if statement is going to determine wherever it's going to be the case. So you get the health, you you subtract by the number of full hearts. And if this is equal to 0.5, because remember in our game, people can only attack in 0.5s and full numbers, basically. That's how I designed it. So if you were to attack in 0.25, this logic wouldn't work. So here, if the subtraction of the current health minus the number of full hearts is equal to 0.5, that means we need to add half a heart to the health bar. Now, I think you could, maybe it would work to simply do a if get health modulo 0.5 is not equal to 0, that would be the same thing, being that modulo is the remainder of the division. I don't know why I didn't do it like that. That's just on the top of my head. Maybe it won't work, but I think why not? So let's keep it like that, and then once we fully finish, if we have time, if I have time, I'm going to replace this with a modulo 0.5, but this logic is much more clear for someone who's not used to the modulo operator. However, I think if you're a programmer, you usually have seen at least once in your life the modulo operator. All right, so now here's the number of empty hearts that we need to keep track of. So basically how we derive this is basically the way the health bar is going to be displayed is that we have the number of full hearts and also the empty hearts, the hearts that have been emptied. We need to display them as well. So to get this, we get the max health that the player can have minus the full number, the number of full hearts, minus whenever or not we needed to add half a heart. And this Boolean, this ternary operation basically tells us that if we indeed need to add half a heart, then we're going to return 1 and subtract by 1. So the reason we subtract by 1, that means we need to display a... Wait a minute. Does it work like that? Okay, I have confused myself. So we have the max health. Okay, that's straightforward. We subtract the number of full hearts. Okay, so that means if I had 4 hearts and I took 2 hearts of damage, 2.5 hearts of damage, that means I'm going to get 1.5 as the resulting. And the reason it was subtract -1 is because what? Oh, okay, because we were going to display less hearts. So that's why. So we have the max health, we have the number of full hearts. Let's say you have 4 full hearts. And you had what? Wait a minute, I'm confused. I probably needed to do a drawing. All right, so let's say these are full hearts. So let's say we have 4. And then we took some damage, and now we're left with 3.5 hearts. So the max health here, the max health is, let me just move the drawing here. So the max health is 4, minus the number of full hearts is going to be 2, minus 1, because it's half a heart, but I don't understand why. So that makes no sense. I don't get it. 4, yeah. Minus 2. All right. So that means okay. Because when it's half a heart, we don't need to display one more empty heart. That's why. Because this is the number of empty hearts that we need to display. So initially, the max health is 4 hearts. We subtract those 2, but then because we're having half a heart, that means we don't need to display 2 empty heart. We just need to display 1. That's why we subtract by 1, and it should be equal to 1 empty heart. So I hope that was clear. Yeah, I got confused by my own thing. All right, so now that we have this, so if we indeed need to add half a heart, that means we need to display 1 less empty heart. That's why it's 1 here. We subtract by 1. Otherwise, we subtract by 0. That means nothing changed from this operation. All right, now we create the heart container, the hearts container. Now, something I should have probably be consistent with is to name this hearts containers as well. Makes no sense to have health and then hearts. So I'm going to put hearts container here, and then in our utils, back to here, it's going to be k destroy all hearts containers, just to be consistent, All right, so here we create a container, which is a game object that is going to be the parent of all the hearts, and it's positioned at 2020, which is the top left corner of the canvas. It is fixed, so it's not affected by any camera movements. Now here we have the previous x. So the reason I'm keeping the previous x here is to know where to place the next heart. And so basically this for loop adds to the container a new full heart. So and then as the position basically puts the x as the previous x. But remember, this is relative to the container. But it doesn't matter that much here. What matters is that after putting 1 heart, after adding 1 heart to the health container, the hearts container, we need to increment the previous x position by 48, because each heart has a 48th width, the sprite for it. Now, if we need to add half a heart, we're just going to add this sprite half a heart instead of full heart. And again, we use the previous x to know where to place it. And then, of course, we need to increment it as well. And finally, the number of empty hearts is, if it's superior to 0, we need to have the for loop here. Now here it doesn't matter, basically. I don't think you need this if statement at all. If the for loop, if there is 0 of them, then this will just not display it anyway. So maybe it's going to be needed. So yeah, let's keep it that way, and then let's see what happens. Okay, so now we have everything we need, our logic for that. And let's go back to the utils.js where we wrote the onCollide function, uncomment out the health bar. Now we will need to import, is it a default export? No, it's just a normal, again, name export. So let's import the health bar. Remember, from the UI components folder and the healthbar.js file. So .js, remember that. And that should be it. The logic should work. Let's try it out. Oh, I realized one thing. We didn't, in our main.js, import the necessary sprites for that. So to do something like that, I need to create another load sprite function. I think we're going to have to do that. Maybe I did it in the same. Let me just look it up quickly. Yeah, we're going to need a sprite atlas. So that's a new concept if you're not familiar with my previous tutorials on Kaboom.js. So let's do it right below the first load sprite. So here's the code for it. So what happens, what is the load sprite atlas function? Basically, it allows you to delimit specific portions of your image to be sprites. So for the full heart, you basically tell it as an object the x and y coordinates from where to start cutting and the width and the height. And therefore this portion, this zone, is going to be your sprite, named full heart. Same thing with this, same thing with this. Now how I figured this out, basically I was testing values. I was basically, the way I usually would do it is basically I create a dummy game object that display the specific sprite I'm trying to achieve, and then I just play with those values to see if I'm in the correct zone, basically. So load sprite atlas, very useful function. It's useful when you want to put all of your sprites, all of your assets in a single image, and being able to cut out and just keep portions of them and name them so that you can use them as sprite is very handy. All right, and with this, you don't have to have a specific like tile width, tile size, because you're no longer thinking in tiles, you're just thinking in zones. So on the image, where is the starting point and which width and height I need to basically have a cutout that is this specific full heart sprite that I'm gonna name it that way. All right, now that this is imported, it should be displayed. Maybe I forgot to call the health bar in world.js and in all functions and all scenes. So usually I think I've put it at the end of every scene. I'm going to verify that and then we're gonna add it. Yep. So at the end of every scene, health bar, we import that. So in world.js, make sure that the health bar is imported properly. Add it also with the .js at the end. And let's also add it to the house scene at the end. So health bar. Now you shouldn't lose health in the house, but it's important to display it basically. And then here health bar is indeed imported correctly, so that's great. Now let's look at the result. Oh, K is undefined. Healthbar.js. Okay, why is that? Because I forgot to pass in K here, the context. Same thing with world.js. We need to pass the context as well for it to be able to draw anything on the screen. And here we go. You see our health bar to the, let me refresh. All right, we have our health bar here. Now let's go inside. You can see that it is here. Let's take the sword. Now what I'm going to do is I'm going to take some damage on purpose just to see how it updates. Oh, half heart is gone. Another half is gone. Another half is gone. Does it work with every enemy? The one hiding behind the tree? Yep. And let's go at half heart. Now I'm going to test if it carries over to the next scene, and it does, and that looks great. What happens now if I completely die and it's refilled? All right, nice. All right, so we got this going, and that's pretty great. I think the last part of the game is really the dungeon. All right, so now that what is left is basically the dungeon, and let's jump right into it. We're going to go to the scenes folder, create a new file, call it dungeon. Whoops, not dungeon. Dun. Oh, whoops. Did I forget how to write dungeon? D-U-N-E. I have a blank. All right. Okay, now I know. Never mind. Sorry. Dungeon.js. Here we go. Now here the logic for displaying the map is exactly the same as we've used to. So just to look at the dungeon map, just to show you, it's basically a 2-room space. We need the prison door, the sun here, which is basically drawn as the same layer as I think the ground, the items, because we don't need to create a game object and place it with a spawn point, etc. It's not necessary for this purpose. Here we have a spawn point for the prison door where we're going to spawn it, and this is needed because the player is going to be able to open it. So that's that. We have this 2-door exit, and we're going to have this transition, the camera transition, etc. So it's going to take a bit of time to get all of this, but let's jump right into it. So in the dungeon.js file, I'm going to copy over the basic, the code that comes like that we have already done like 3 times. Now there's always some small variations that we need to have, but yeah, that's something I'm going to have to deal with later. So I'm trying to think of what's the better way for this to be manageable so that you understand everything I'm doing. Now I would be tempted to just copy paste everything and then go over it, but I think it's not going to be good this way. So let's first write the function export function async function. Export async function. Export default async function done and then of course we pass the context, and that we have our function. Now what we need is basically the same thing we're used to, where we need to colorize the background with a specific color, load the tile map, draw it, etc. So this logic is something I'm just going to copy and paste. Here we go. So that's the logic. Now there's a bunch of function and methods you also need to import. So that's why I'm going to simply do that as well. So I'm going to take this import statement. So here are things that we haven't yet used, but we're going to use them. So here, just to explain the logic and so that you can go over, we're going to go over it line by line so that you can also have the time to copy them as well. So here we have the colorized background, which is going to take a darkish color, the same color that we had in the house, the background of the house. This is derived from basically using the color picker tool in the original tile set and etc. and figure out the RGB values. You can put whatever you'd like here, but it's suggested to just stick with what I have. Now here we have the fetch map data to basically get the specific data for this map. We have here the actual map object, the entities. This is something that has been already covered before. It doesn't change. We have the layers, the for loop, and then we draw the boundaries first, and then depending on the spawn points, we're going to have this for loop. So for the spawn points layer, we enter here. We're going to do all of these drawings. So basically this again is the same thing, except what changes is we have the player components. This doesn't change. We have a ghost now. So we have the ghost, which generate ghost components, and this isn't yet added to our code. And we only draw this if the ghost is defeated. So there are a bunch of things we need to actually add, the ghost logic, etc. So for this, I'm going to comment that out. So, and then we're going to comment that back in when we're going to actually write everything we need for it. So this is something that has been already written previously in the previous scenes. By this point, you might be starting to think of functions, a reusable function. I haven't decided to go with this approach because I don't think it's necessary for this project, but definitely there's a bunch of things that are coming back and you could abstract some of them some way. Now here for the object, so within the spawn point layers, if the prison door, we need to draw that. And here here it's something different. And instead of having a specific sprite called prison door that points toward a specific number, like we used to here, I opted to do something else. You can use the frame property of the sprite component. So you pass in the name of the sprite, the actual sprite sheet that we had imported early on, and you can use the frame and get a specific frame that is going to be displayed instead of having to create it as a one frame animation in main.js. Now, why did I not do that early? Because this is an approach that is better, I think, because for organizational purposes, it's easier to switch between animations, etc. when you have many, especially for the player. I could use a template string to go from up, down, left, or right attacks, for example. But because in the prison door, we really only have two, and so in that case, it works. It's more convenient to just use the frame property, check if the player state we have the key. So this is not another property we'll have to create. And then whenever or not the player has a key or not, we're going to open the door or not. So yeah, that's more important when the player goes out from the dungeon and then comes back in. We want this to reflect the whether or not they have already unlocked the key and opened the door of the prison, for example. Here, what this does is if the player has the key, that means we're going to put the area component. We're going to add the area component if the player does not have the key. So that's the reason we're doing this, is that we need to make it solid. We need to make the prison door non-passable so that the player cannot pass through it to go and save the sun. So only in the case when they don't have the key, the player doesn't have the key, then we add the area component and the body component with is static true. We need the area component because without it, we cannot use the body component to make the actual sprite, this game object solid. And finally, we have the position, which is the object X, object Y thing that we used. And finally, we add the prison dash door tag so that when the player has the keys, goes to the door, they collide with the door, then we can actually have this logic, this event listener, to unlock the door by using this tag. Now here at the end we have the boulders. Now, what was the reasoning behind this? I think in the end I did not use it. Let me just look at the map. Yeah, I think I didn't use the boulders. Let me look at. If I look at the sprite, what numbers? 392. Yeah, so initially I thought that maybe I would put a puzzle section in the game, like an actual Zelda game, but it took too much time, and I forgot to remove the code for it. So yeah, let's remove it. It's not necessary. All right, so now we have seen that we need the player state. So that's something we need to add into our import statements. So I'm going to go ahead and basically get everything we need. Here we go. Now we have imported this. We have the player state. Later on, we're also going to need the game state. That's why I put it here. Now let's, without further ado, go back again to the player global state and add the has key. Okay, we already had it, so that's nice. We had the get has key and set has key, so that's great. Okay, now we can go back to the dungeon, and then I think we can. Did I have the logic to display the player? Yeah, good. We have this logic to display the player. That means we need to import the generate player components. That's another import statement we need to add at the top of the file. So let's do this. So I'm going to take this. We also need to set the player controls so that the player can move when they arrive in the scene. So here, right below the utils, we can put it here. Now we don't need this. This doesn't exist, actually. I decided to remove it in this project. So set player controls is something we're going to call in an instant. I think we need to call it right below here. So, yep. Let's add also the logic to exit the door, the dungeon, basically. So right below, right after this for loop, I'm going to do this. I'm just gonna put the text a bit upward so that the YouTube player doesn't prevent you from seeing the code. So here we set the player controls. This is again code that has been repeated for both the house and the world scenes. And here again, the door exit is basically the same logic as the dungeon, but this time around we set the previous scene to the dungeon instead of the house. Did we do this in the house? We didn't. Okay. This is important. The reason it's important to set the scene, the scene here, so in house.js, I don't think it's important to set it in-house, but it's important to set it for the dungeon because when the player goes out, yeah, I'm gonna add it also to the house. So basically, just to make sure. So here at line 64 of the house.js, we basically, when the player exit the house, we need to set the previous scene as being the house. If we don't do this, when the player is going to exit the dungeon, he's going to spawn near outside the house instead of outside the dungeon. That's why I needed to keep track of the previous scene. Now, I'm not sure I added this to my global state. I don't think I did. And we need to also add the getters and setters for that. So in global state.js, we're going to need, in, I think it's here, previous scene, we need to add this previous scene variable. And we need to add the getters and setters for that. So let's do just that here. All right. So this is important for that purpose so that we can know where to spawn the player. And I think in dungeon, in the world.js, we didn't add the logic for this, I think. Because we need to also add a logic that is going to place the player depending on what was the previous scene in different places. So here in world.js, we need to write this logic. So I'm just going to go to world.js, and here where we have the player, we need to add another check, another condition, I think. This condition is, well, actually we need another if statement completely. We need to go here on top, paste. So what this does, we need to check if the object, the spawn point is called player dungeon, and if the previous scene was the dungeon. And if that's the case, we're going to actually draw the player and add it to the map where the player dungeon spawn point is instead of the player. That's because the continue statement will just continue to the next iteration and skip everything that comes after. Let's see if it actually works. Whoops, what happens? Whoa. There's an issue. Previous scene is not defined. Okay, previous scene is not defined, then why is it not defined? Okay, that's the reason it's not defined is because I forgot to store the previous scene in a variable called previous scene. So let's do that at the top of the world function, right before colorizing the background. You can do it after, it doesn't matter. As long as it's done outside of the for loop, it should work fine. And even within, basically, it should work fine. But it would be wasteful to create a variable every iteration, so might as well just put it outside here. Okay, so there's another error. Game state is not defined. That's because we haven't imported game state in our world.js, so that's why we have this error. Let's import it right after, let's put it right after here. All right, now if I look, okay, we have our working code. Now I'm just gonna try to go to the dungeon, enter the dungeon, and then exit out. If it is at all possible. Yeah, I don't have, I haven't written the logic to actually enter the dungeon in world.js as well. So we need to add that as well. So here, here you have door entrance, and we need to add another one for the world.js for the dungeon. I think I called it dungeon door. I'm not sure if it was actually that, so let me just look it up. dungeon door entrance, and this is coming from, of course, the tiled editor. So here I'm gonna paste it right before drawing the health bar. Doesn't matter actually. This could have gone afterwards because those are event listener. They will just fire at when the event happens, so not like sequentially like that. Okay, so dungeon door entrance. Okay, if the player collides with the dungeon door entrance, we're going to go to the dungeon scene. Now, just so you aren't confused, if we go back to world.json map and I go here, you see that I've put a boundary and named it that way. So is it here? Yep. The boundary is named dungeon door entrance. And if you remember the logic we wrote for drawing boundaries, it's in utils.js. If I go to draw boundaries, we put the object name as part of, we pass it to the generate collider components, and it's passed in as the tag, basically, of that specific component, game object, not component, game object. But yeah, collider box components for the game object that is added here. So yeah, the object name is the tag used. All right, so I think we have everything we need to test this out. I'm just gonna go close this, everything that is not useful, just to declutter everything. And now let's test it out. All right, let's move on and let's try to enter the dungeon. Scene not found dungeon. That's because we didn't add the dungeon scene to main.js. And yeah, because we need to go back to main.js. And then you see here, house, you should also have dungeon. Now you need to actually import dungeon like that, and everything should work fine. If you remember, here is where we stored our scenes, and then we iterate through them and use the scene function from Kaboom to create it. Okay, ambiguous indirect export, set player controls. Okay, I made a mistake somewhere. Why is it a mistake? I don't get it. Set player controls. It's from here. If I go to the player.js, maybe I should. Okay, I called it. I changed the name to set player movement in this tutorial, so that's why it's not working. So go back to dungeon, set player movement instead, and remove controls here. All right, let's go. Here we go. Now I can move, and let's see if it actually works. Hopefully it will. And yeah, we are in the scene indeed, and it actually works. And you can see that I can go here. Now, of course, there's a bunch of logic related to the camera and how we need to zoom it a bit. But if I go out, I spawn outside of the dungeon. That's great. Now, if I go... Oh, I got scared by my own game. Like, there is this other... Okay, now I see game state is not defined. Okay, whoa, I did not expect to see my player character here. Anyway, okay, let's fix two errors. First, in house.js, sorry. We need to actually have the game state because we're using it somewhere. Where are we using it? So reference game state is not defined, and it's at line 64. 64, line 64, where is it? All right, yeah, so we need to import the game state as well. Let's do it here. Doesn't matter where. Import game state. Here we go. Now that game state is imported, we have the state manager, so this shouldn't be an issue. But the other issue, of course, is that we have 2 players instead of 1, and I don't get it. Why is it drawing 2 players instead of just 1? All right, so let's add the condition that I added in my original code base, where we want to make sure that the previous scene is not equal to the dungeon. So this statement should be enough. In the original code base, I did 2 things. I first checked that the previous scene wasn't the dungeon, and also wasn't null. The reason I did that was because by default, yeah, it should work. It should work like that. Simple condition. Okay, now it's gone, and then if I can go out. Now, if I go out, I need to make sure that the player isn't drawn in front of the castle. And yeah, so okay, so it works. All right, now that we have done this, let's continue on with the code for the dungeon. So we can exit out and in, but now we need to actually deal with the camera system. And then once the camera is dealt with, we can simply let me check. We have to, okay, in our dungeon, let's first zoom in the camera, and then after we do this, we'll have to add some logic for the camera sliding. So when the door is hit, the upper door to the next room, we want the camera to hit that, to gradually, slowly move towards the top. This was something I wanted to include in this project, just to like show you how to do that. So at the end of the code for the dungeon function, so dungeon.js, let's use the cam scale function like we did in the world. Set it to 4 so that the camera is zoomed 4 times. Let's also add the health bar. So we want to display it at all times. And that's basically it. We need only those 2 things. If I go here and I go to the dungeon, immediately we should notice that the camera is much bigger. Now let's work on the transition towards, when I hit the door here, it moves upward to go and puts me on the other side. To do something like that, we're going to create a function that is going to take care of sliding the camera. Now, since this function isn't going to be used anywhere else in the project, I just created it within the dungeon code here. So slide the cam Y, pass in the context, the range, the duration. You could feel free to put this in the utils.js if you want. It doesn't matter, but for this project, so basically we take the current camera position, we use tweens again to modify it by a certain range that you pass here, and with a certain duration you want. And then here we use the campause method here to also set the new camera position. So we use the same X, but we use the new pause Y to gradually change it using a linear easing function. Once this is done, we actually need to actually do it. And the way we're going to set this up is through 2 onCollide function event listeners. So the first one, if we hit the door entrance, if I go to tiled, you can see that within the dungeon.json, the door entrance is this object, this boundary has the tag door entrance. Now I'm going to call the game state and set freeze player true, the same set freeze player we used for the dialogues, but this time around we're going to use it for the transition, because when the camera is transitioning up, we don't want the player to be able to move, as we're going to teleport it to the next room. So there was a bug where you could escape this. So while it was sliding, you could simply move to the left and then find yourself outside the boundaries of the map, and you don't want that. And here you use the slide cam Y that we just defined here. So we want it to move at a minus 180 range. So it's going to be subtracted to the current cam position pixels, and in 1 second. and we want to move the player. So the way you could basically forcefully move a player to a specific point is just to modify their positional component directly. So what I did was just subtract 50 to it, so that it moves further up. And then once this is done, we can just unfreeze the player by using the setFreezePlayer method and call false instead of true. Now, yeah, so we have the game state. Everything should work fine. Now we have the other side of the coin. So when the player wants to exit, wants to go back to the room, the original prison cell room, we have the door exit 2. Door exit 2, if I look at the map, is this one. It's not a door, but it's a boundary that is called this way, so that when the player hits it, it's going to do the same thing but in reverse. And the way we achieve that is by using, again, an onCollide event listener. We freeze the player. Instead of moving him 180 pixel upward by subtracting, we add 180 pixels, which is going to put the player down, put the camera down slowly in 1 second. And then we spawn the player by adding to its Y position 50. So it's going to basically land in the same place it was before we subtracted 50 pixels to go up. And then we set the freeze player back to false. All right, hope those explanations were clear. Now it's time to actually look at the result. So here I'm going to go to the... All right. So we have the game. Let's move. And then let's go to the dungeon. And you're going to see hopefully the nice transition. So we are in here. And then if I hit, I cannot move left, right, or center. And then I come to the boss room. There's no boss now, but it's going to be cool in a moment. And then here I spawn up, down, up, down, etc. All right, so there's only now 2 things left. There is the ghost AI, the ghost himself, the AI for it. There is, and then all the logic associated to the prison cell and the kid and the keys. So those two we can separate out into 2 sections basically. So let's jump into. I'm trying to think that maybe the dialogue would be best first, and then we do the ghost last. That way, we get to deal with all these state things earlier on, and that's going to be better. So let's do that. So here I'm gonna add another onCollide here right below line 104, and this is basically when the player collides with the prison door, we get the prison door via the event listener here, and we create the dialogue, and this dialogue is going to have this thing called sun lines, basically the dialogues for the sun. It's going to get the current language, and then whether or not the player has the key or not. If the player doesn't have the key, the dialogue is going to be different. You're going to see in an instant. Now, if the player has the key, we're going to replace the frame of the door to being the opened version, and unuse the body component, unuse the area component. So the unuse function can be used to basically remove a component that was used to create a game object, and you just have to pass in the name of that component as a string. And then we're going to set this game state as set is sun saved to being true. Now there's a bunch of dependencies here things we need to change in our code base for this to work. So the first one is the sun lines. So we need to go to content and create a new file. This file is going to be called sun dialog. So create a new file, call it sun dialog.js. Now it's going to follow the same structure we did for the old man. So I'm going to just paste the code here, the text. Feel free to replace with whatever you want. Also, don't forget that the GitHub repo is available in the description, so you can just move to this file and copy the content instead of having to type it out by watching the video, by pausing, etc. So here is the dialogue. So if you, at index 0, you have this first dialogue where the son tell you to help him, that he's held prisoner and that the keys are held by a ghost in the next room. Now, once you get the keys, it moves on to the second, to index 1, which is the second dialogue. So it doesn't redo this. And this is the French version. And same pattern here as the old man. Now, if I go back to dungeon.js, we have game state get locale. I think we added this already. Let me look. If I go to global state, you have a locale, okay, already. So that's nice. And what's left is get has key. I think we already added that to the player state global state. Has keys is already there with its getters and setters. So I think that should be it. It should all work. So we display the dialog. So we need to actually import the dialog from the UI components. So import dialog. Here you go. So this is nothing new. We already went over how to display dialog box. So this is what it's going to do. Display it here, etc. So let's try it out. So here I want to drive home that if the player has the key, then we skip over immediately to index 1 of the son dialogues, which is going to skip over this first part and go immediately here. If the player does not have the key, then it's going to start from here. And only here. It's going to only display here. And the third thing is only going to be displayed when you talk to the son directly by colliding with him, not the prison door. All right, let's go. Let's try it out. I'm going to go here and go above and then purposely collide. Oh, there's a sun line is not defined. Oh, okay, I forgot to import this in Dungeon. So I need to import sun, or it's sun lines. Here you go. Now let's look at the game again. So here we go. We move to the left, move forward, then talk to the NPC. Help me. Intermediate set is sun saved is not a function. Oh, that means there's some missing state. So in global state, I'm gonna add a couple of variables that I forgot to add earlier on. So global state, go there, and we need the set is sun saved and get is sun saved, setter and getters, and also add the properties for each of them. By the way, to not have this error again occur, let's do the same thing for the ghost. Set is ghost defeated, and right before here. So set is ghost defeated and get is ghost defeated. Same thing for the sun, and then add, of course, the variables for that for let is ghost defeated, initially set to false, and then let is sun saved, initially set to false. All right, we should everything should be working. Let's try it out. All right, so I can move to the left, etc. Okay, that's great. Let's go to the dungeon, and then let's talk to the guy. Help me. Okay, another error. What's that? Set is a sun saved is not a function. But wait a minute, we did set is sun saved is a function. So let's go to dungeon. Let's go back here. Where's the issue? Game state set is sun saved to true. And did we import game state? We have imported game state. If I go to, oh, I added this to the wrong place. Let's copy this. Let's remove it. Save. Go to global state, not player global state. That's a mistake on my part. Paste it here. So set is ghost defeated, get is ghost defeated, set is sun saved, and get is sun saved. And also go back to the player global state and take those two state variables, remove them, save in player global state so you don't have a mistake, and go to simply global state.js and add them there. That's sorry for the error. All right, so now if I go here, I go to the left and try to go to the dungeon. Oh, I took some damage. And here we go, no errors. Help me. Now if I press space or even try to move, it won't work. So if I press space, it will go to the next dialogue. I'm held prisoner here, the next sentence in a specific dialogue. The keys are held by a ghost in the next room, and that's it. And if I talk to him again, help me, I'm held prisoner here, the keys are held by a ghost in the next room. If I go here, nothing happens because we haven't implemented the ghost logic. All right, so I think we're finally ready. Let's add the when the ghost is saved. So just to test that actually the ghost is defeated, let's put it to true. That's just for testing. I'm just gonna make sure that if I try to enter the prison, it's going to allow me to do that because we wrote the logic for it, but don't forget to set it back to false. Here, help me, I'm held prisoner here, etc. Okay, we haven't written the logic to check if the ghost was defeated anyway, so let's put it back to false, and we do that later. So in dungeon.js, at the bottom, we have the prison door, etc. So that's great. Get has key. Okay, so the state for whenever or not you have the key is defined in the player global state rather than, so if I go there and set it to true, in theory, it should open the prison door, let me go in and talk to the sun. Now, if I talk to the sun here, I didn't add the logic for it. So let's add it right here in dungeon.js. So just so you understand, this piece of code that we're going to write now will only work when we actually defeat the ghost, enter the prison door, and then collide with the sun himself. And this dialogue, the third in the sun dialogue, this will run. All right, so if I go back here, I go to, which is it? Okay. All right, in dungeon.js, the last one is this one. So I'm going to copy and paste it. So if we collide with the sun, so just so you know what I'm talking about, this boundary has a tag named sun, since the actual sun sprite is just drawn on the same layer as the items, because I didn't want to deal with creating another spawn point. It's not necessary. The sun will not do anything in this game anyway. So yeah. So what happens is if the player collides with the sun, we open the dialog box, we start a dialogue, and we do the last dialogue in the language that the player has decided. So later on, we're actually going to need one last thing, which is the menu, to change the language. So that would be the last thing we do. So now the only thing left is the ghost.
All right, it's time to finish our game. And the only thing that is left, like I said earlier on, is really the ghost AI and the fighting. And the AI, the ghost and the AI for it, and the dropping of the keys, and finally the menu. So let's jump right into all of this. And yeah, so first of all, let's write the code for the ghost. We want to actually position the ghost on the screen. So in our dungeon.js scene, but actually in the entities folder, we're going to create a new file. And this file is going to be the ghost.js file. I'm going to call it this way. It makes sense and it's pretty straightforward. So ghost.js. Once this is done, it's basically the same structure that you're currently used to. So I'm not going to write it manually. I'm going to write some parts maybe, but I'm going to first copy the most recurrent thing, which is the generate ghost components. So same thing as generate old man components. You put all of your needed components here. So here I just want to cover that we have, yep, so let's first start with the first sprite here. So we use the sprite component to display the ghost down animation. And while we're at it, let's add it to our animations. So here, I'm going to just copy and paste it. So yeah, don't worry, I'll go back to the ghost.js if you haven't had the time to copy over the code. So, and also I need to explain it before you copy it. Don't just copy it without understanding anything. So for the ghost, there's really only one animation, and we're only going to use the down-looking sprite. So that's the ghost down. I forgot to open tiled. All right. Yeah, so just to make sure that we're going to spawn the ghost in the correct place. So in your own file, you should already have a spawn point that is called ghost. This is where we're going to put the ghost actually. All right, so the animation goes down just so I can show it to you. If I go to, again, in tiled, and I'm going to look for the ghost down is basically this one. It's those two things, those two frames. And I thought that it wouldn't be necessary to use these, as you have seen in the actual game, it looks natural. It doesn't look weird that the ghost isn't facing in multiple directions. So that's that. All right, now we have this in our main.js file. So from frame 862 to frame 863, and we're looping, of course. Then we can go back to ghost.js and here add the animation as the default sprite. So the animation is playing by default, basically. Here, the area, it's basically going to be the same pattern we've used, a rectangle that we create with a width and height of 12 by 12 pixels and an offset of 2 to the x-axis and 4 to the y-axis. This is what looks good and made sure that the ghost was really neatly inside of the hitbox of the ghost that is created by this area component. So just if this is still not clear to you, then simply just play with those values once we're going to actually display the ghost. And use the debug mode by pressing the F1 key. Now the body component so that the player can collide with it, but we don't put anything special inside because we want the player to be able to hit it and even push it around if necessary. The positional component, this is something that has been used in previous entities, so no need to go over this. The health component, also I've went over this. We give 9 points of health to the ghost, so it's a boss basically. The opacity, so we can make the ghost blink when they take when it take that damage. And finally, the state, because we're going to actually implement the AI, and we have a couple of states here that I've decided to name: idle, right, backtrack, attack, and evade. So the ghost is not only going to have an idle state, but it can move to the right, it can backtrack and attack, and even evade an attack. So that's the states. We're going to cover this a bit more later on. All right, so now here in the object, here we put in a couple of properties. The is attacking, attack power. Here again, like the slime, it only does 0.5 of damage. You can decide to bump this to 1.5 or 1 if you want. It's really like up to you. And here we have the previous position. So the previous position property here, and we just set it to a vector2 that is of the coordinate 0 by 0. Now this is useful because we're going to store the previous position of the ghost on every, I think, frame or stage change, so that the ghost can evade an attack. So what is an evasion? It basically goes back to a previous point in time, so it can basically backtrack against an attack. So it's going to all be much more clear in an instant. Now we need to add a couple of other functions and methods in this ghost.js file. So let's just do that. I'm going to basically create this. Actually, it's only one function and it's a big one. So I'm just going to copy and paste it. But it doesn't use any new concepts. So that's why I'm going to go over it line by line here instead of typing it out. So here we have the set ghost AI function. Same pattern that I've used with the other, the slime AI. It takes the context, of course, the ghost entity itself and the player as well, because we need to have access to the player. Here I create something called an update ref. Now, this is just a name, but in Kaboom, if you remember, I don't think we've done this a lot in this project. You can hook into the update loop of the game by using the onUpdate function. This onUpdate function takes in as a param a function that is going to be called on every frame, basically. And here we want to, at every frame, check whether or not the distance of the player, so the distance between the player and the ghost, is inferior to 30. So how this is computed is simply like you have seen all of our game objects that use the positional component has the pause property. And we also have access, therefore, to the dist function that allows you to calculate for you the distance between the player position and some other kind of position. So here it takes in a vector 2, I think. And here we pass in just the ghost position by using the dot pause property as well. And the reason why 30 here and not 20 is just a value that worked well in practice. So the distance was sufficient for the logic to not, the logic we're going to run here to not look weird. So here what we do is, so basically when the player gets too close, I think, to the ghost, and 30 was the value that looked all right, we can play with those values. We enter the state called backtrack. So backtrack, what happens in that state is we're going to go make the ghost go backwards. So initially the ghost is centered, it's positioned here, and then as the player tried to go towards him, the ghost, then the ghost will enter the backtrack state if the player is at 30 units of distance between the ghost and himself. And then it's going to enter the backtrack state and then start going backward and then to the right, and then it's going to launch an attack on the player. So just so I make this understandable, so as soon as we enter this backtrack state, we're going to cancel this update loop. And that's the reason why I stored this onUpdate, the result of the onUpdate function, inside of the constant that I called update ref, because this is how you can cancel an update loop that you created. And this is pretty handy because it can be used also to cancel a lot of other stuff, like for example, if you have a state machine like we are going to create here, then you're going to be able to cancel everything when you leave the scene. And the reason why this is useful, because state machine seems to persist between scenes. So if you were to play sounds between in those state functions, then you would still hear them even though you've moved on to another scene. I discovered this behavior in my previous tutorial where I made a platformer. It's a 7-hour tutorial. I recommend that you watch it if you have the time for it. Otherwise, feel free to do whatever you want. But in that tutorial, I discovered a lot of things about Kaboom, and really, I think it's if you're interested in more object-oriented approach to Kaboom, to using Kaboom, then I think it's a good idea to watch this. All right, so now that we have this, so basically we update, we cancel, and then here you don't need to return early. It doesn't matter in the end. It doesn't matter because it's the only thing that's left. We don't have any more logic here, so no need to add it. Now that we have this, we also have right below a loop. So this loop, the loop function, basically is like the set interval function, but just in a neater syntax offered by Kaboom. It allows you to just specify a interval, and after that interval elapse, it runs the function, and then it calculates another interval, so it waits another time the interval, and then runs it again. Basically, it runs this function every 5 seconds here. And here, what we do is we store the current position at the time of this is when this is called in the previous position property that we created initially in the generate ghost components. So this is useful because once let's say the ghost wants to evade an attack, instead of just storing this value at every frame, basically the ghost will not be able to evade anything because the previous position is just too close to the current position. So you won't see any difference. But by having this delay of 5 seconds, so only every 5 seconds do I update the previous position to being the current position, then we have a position that we can go back to, tell the ghost to go back to, in order to avoid a player attack. Hope that was clear. Now here we create our first state logic. So as I said, as I mentioned, I have shown you in the Slime AI, to create an AI, you work with state machines, and you have your state here. So a couple of states I have created, and then you write the logic for each of those states by using the onStateEnter function, that method that comes with because you have used the state component in the creation of the game object, the ghost game object. That's why you can use the onStateEnter. And then here you have the name of the actual state, and then the function you're going to run. And here what we run in backtrack is just we use tween this time around for movement. So it's going to modify the position of the ghost from the initial ghost pause y to ghost pause y, the current position, minus 40 in 0.2 seconds using the linear easing. And then once this is done, we of course use the await because we don't want to move to the next state unless this is done. And because this tween function is asynchronous, that means it can run while the code continues to execute by default, we need to use the await keyword here to prevent it from doing so, and to just force JavaScript to wait for this to run before this can run. What comes next can run. And then here at the last line of that function, we just move on to the right state. So we want basically the ghost to backtrack and then go to the right. And here, the same thing. Now, the reason I stored this again into a constant, and the same thing for all the state logic here, is to cancel them if the player leaves the scene or if the game switched to another scene. That's important if you were to add audio to your game. That would be one case, but also just not to be wasteful of the resources. I think if you're the Kaboom maintainer and somehow you're watching this tutorial, please fix this. That would be great if you have time, of course. Now, okay, so now same logic to the right. I explained it. Okay, so yeah, basically the same logic. We use a tween to move the ghost this time around on the x-axis, adding 50 pixels to the current position and doing so into 1 second, doing this movement in 1 second, following the linear function easing. And then once this is done, because of the await keyword, we can go to a ghost enter state attack. And now after having gone to backtracked and then gone to the left, it's time to attack. So here, the attack state, we are going to set the ghost is attacking equal to be true. The reason for this is, as I've mentioned earlier on, is so that if the ghost is attacking you and the player attacks at the same time, we don't want the ghost to take some damage. We basically want to cancel out the attack, the attack basically. And the same thing for the player. If the ghost attacks while the player attacks, the player shouldn't take damage. Now we have, so that's just a logic I have a design choice I've decided to make. It might not make sense to you, so feel free to decide on playtest your game and try to figure out better rules. Now what comes next is we define a constant, an array that contains the attack speeds.
So 0 0.5, 0 0.8 second, and 1 second. So we're gonna select a random attack speed to basically tell the ghost how fast the attack should be. And by adding those three values, so either sometimes it's going to pick 0 0.5, sometimes it's going to pick 1, it's going to make the attack varied, and the boss will be more challenging. Now here we use again a tween to move the ghost to the player position this time around, and that's why the player position was important to pass here at the beginning in set ghost AI. So now the ghost position, so this tween within the attack, its goal is to move the ghost towards the player in a speed that is randomly selected from the attack speeds array. And here we use the math floor function. So basically the way you can select a random element from an array, a standard way to achieve that is to use the math.random function from JavaScript, which gives you a value between 0 and 1, multiply it by the length of your array, and then floor the value so that you only get an integer and not a decimal number. And then same thing, linear easing as well. And now what comes next here is that we want to check for something. If the ghost collides with anything, basically, we want the ghost to enter into the evade state. And the reason we want to do that is, for example, let's say the ghost successfully attacks the player and hits the player. Then we want to immediately go into an evade because, the player could decide to swing their sword right at that moment. So by having an evade, it basically the ghost is being smart, and that's And now you could tell me that, hey, this logic does not take into account like specifically when the player gets hit or not, and I thought it just didn't matter. So for example, even if the ghost hits a wall, he's just going to evade as well and try to attack the player. And it looked nice in behavior, like while playing. So I thought I would just not overcomplicate the code for nothing. And then here it's important to have the return statement, because in the case that the ghost hasn't collided with anything, we just want to go to attack again. So let's say what happens here is when you enter this state, it takes the current position of the player, but the player could move between in that time, and that's why once it's going to basically arrive at the one of the previous player positions, the player position at the time of the ghost entering the state, and not the actual current time of the current position of the player. And that's why in the case there is no collision, that means the attack was not successful, and that means we just enter back the same state. So by entering back the same state, we basically have this loop where the ghost is going to try to attack until they hit something, and then they're going to evade instead. And then here the evade state is basically it's basically in the evade state where the ghost is vulnerable. So that's why we set the is attacking to being false, and then we move the ghost to one of the previous positions. So the latest previous position that was stored, this is where we're going to move the ghost to. And 0.8 second. Now you could decide to have this like the same thing here. So have a variety of how fast the ghost will evade the attacks. But yeah, feel free to add this if you want. And then, we have a linear easing as well. And then after this is done, we go into the attack state again. And then finally, we have this to basically cancel all of these state listeners when the game leaves the scene or the player leaves the scene. For example, let's say the ghost, you're fighting the ghost, and then you don't want to do that anymore. You just go away. You exit the room, and then if you enter back the dungeon, you're gonna find the ghost being at the same position, and basically respawn basically. All right. Now that we have this, I think we can. I think we need a one last function. This time around, I think let's add it right now, and then let's use it. Let's use all of these functions right after instead of
gradually adding all of these into our dungeon.js file, calling them into dungeon.js. So the function we're going to need is simply, I called it, let me just paste it here. So this function is called onGhost destroyed, and it's a function I made that is going to basically use this Kaboom function called onDestroy. It comes from the Kaboom context, so you have to pass k as a parameter as well. And basically, it allows you to listen on when a game object is being destroyed. And here, the ghost is, you pass in the tag of the object you want to listen on, and here it's the ghost. So here, if you remember, we have the ghost in the generate ghost components. So that's how we're able to get the ghost from to listen on this when the ghost is destroyed. And what we want to do is basically spawn a prison key. And to do that, we just create a game object. I called it key. And then here again, like with the prison door, I don't need to have a named sprite from the sprite sheet. I just took the specific frame 99. If I go here, the key is this one, is here. So yeah, and then we, of course, for the positioning, I just put it at the center. I called the center function from Kaboom that gives you the actual center position vector 2, and then you can just select the X property and then do the offset you need, and then this is how I placed the key in the proper area. And then of course we need the area component and a tag for it because we want the player to collide with it, and this is how we were going to keep track of the fact that the player has taken the key. So here in prison key, that's why I stored this into a reference prison key here, so I can use the onCollide with the player tag and set the player state to set has key true, and then destroy the prison key itself because we don't need to have it around anymore. And then also, even regardless when the ghost is destroyed, we also set the ghost to defeated to being true. So I hope that the logic was clear. Now let's add all of this into our game. And the way I'm going to do that is, first we need to draw it. So let's go to dungeon.js. Let's go to here. And then you see the logic that I commented out earlier on, right below the player if statement. I'm going to comment it back in. What it does, and save, of course. It's basically, it is going to check for the object name being ghost. If the ghost is not defeated, then we're going to store the ghost into the entities object, and by using the generate ghost component, and this is basically logic that is basically the same as this. Now, one thing we need though is to import the ghost logic. So generate ghost components. This is what we need. Oops, that was not what I wanted. Now that we have this, we have the ghost being drawn, and now we just need to go maybe right here at the end, right before the cam scaling. It doesn't matter really, but we're just going to have an if statement. And here, this if statement, what is going to check for is, as long as the ghost is actually defined, so it's not null, then, because in the case where you have defeated the ghost, you can go back to the boss room, I guess, and in that case we should be able to draw the room without errors. So that's why in that case we don't want to run the functions related to the ghost. So here are the functions we're going to need. So we have set ghost AI, we just created that with the AI. On attacked, which is a general function, basically. When the ghost is attacked, it's going to blink. On collide with player, this is the reverse. The player is going to blink, basically, and take damage. So on attacked is the ghost that is going to take damage. On collide with player, it's the
player that's going to take the damage. And if I go to the definition, just to make sure I remember this correctly, yeah. So when the entity collides with the player, if the player is not attacking, so we proceed, and this is how we basically reduce the health of the player. As for the other one, the unattacked is the reverse for the player attacking. So if we were using object-oriented programming, this would be like player dot unattacked, and it would be much more clear, I think. So there are some merits into having methods like that, using at least using classes as state containers, not necessarily using any inheritance or anything like that. Now finally, we have the onGhostDestroyed that we call. You could have called it anywhere else, like here, it doesn't matter the order, because those functions create events, listeners, so it's not executed immediately. It only executes the logic when the event that we're looking for happens. Most of the logic, of course, the function that sets up the event listener is running immediately when this is called onGhostDestroyed, for example. All right, so I think the only thing left is really the import statements. So set ghost AI and on ghost destroyed. I save all of this, and I think that's it. I think that's basically it. We might have missed a couple of variables, but like state variables to update them, but I think it should work. Let's test it out. So I'm gonna talk to the old man. Take my sword. Here we go. Now I'm going to not bother with the slimes. I'm gonna go to make sure that this works. Help me. I'm held prisoner here. The keys are held by a ghost in the next room. And then if I try, yeah, and he's attacking me. Yep, it works. I take damage. Now does he take damage? Yep, he does. And yep, so let's try defeating him. Now I'm spamming, but I think I'm not gonna survive, or maybe died. Yeah, so it's a bit hard because the hitbox is a bit too close, I think. So that's something you could improve upon. But the reason I kept it is just to have an easy way to reproduce the state. So I'm just gonna need to attack on a given interval. So here we go. And has so many lives. Is he taking any damage? I realized that he's not taking. I forgot the logic for damaging, for any damage. Yeah, so yeah, so in that case, let's fix that. Why do I not take any damage? No, why does the ghost not take any damage? So let's look at the function. Where is it? Go to definition, and then here. Okay. Entity.hp is inferior to 0, destroy. Otherwise, you hurt the entity with. Okay, it should technically work. So you know what? I'm gonna console.log the HP of the entity. So the ghost in that case, and then I'm gonna see if it actually works or not. So let's skip the dialogue. Maybe the hitbox is not appearing properly. Everything seems to be working all right. And then let's move on upward. All right, let's fight. All right. I forgot to open the console. Oh, there's an error. Type player is undefined in utils.js, line 101. So that might be the error. So if I go back to line 101, you have the I forgot to pass the player. to the function in dungeon.js. So that's why I'm going to remove my console.log, go back to dungeon.js, and here on attacked, I actually need to pass the entities dot player. Now it should work. Let's test it out. Let's first get the sword. And then it's going to also give us the opportunity to see if the end game works. Those a bit. So when we talk to the sun, etc., if everything works. All right. All right. So I'm gonna go here. Let's fight. And all right. All right. Now if I pick the key, it should work. Now if I go back, and then I go here. Whoa, you got the keys. Thanks for saving me. Now can I pass? Yes, I can. Can I talk to the guy? Thanks for again for saving me. Go talk to my father. He'll reward you handsomely. Nice. Now if I go back to the father, let's see if he changes his dialogue and basically reward us. Let's talk to him. You forgot. We didn't write the logic for that. Okay, so let's do that. Okay, so we need to go back to the old man. Old man, not dialogue, oldman.js. And then here, so yeah, once this is done, it's basically done. The project is done. There's only one thing left, is the menu to change the language. And this is something that's really optional. You don't have to do it if you don't feel like it's a bare bones menu. So I'm not gonna spend too much time on it. So here in the start interaction function, what we need to actually add is, okay, we have this. Do we have everything we need? Old man state. All right, the issue is that in oldman.js, I forgot to add the following if statement right before the response. So really, like right after here, we should have a if statement that what it does is basically we check if the son is saved, and if he is, then we display the third dialogue, the fourth dialogue, which is the actually you saved my son, blah blah blah, etc. You can keep the sword as a reward. That's basically the reward. So now before going back to the game, let's just write the actually last scene, which is the menu. And this way, so just go to scenes, create, yeah, so this way we're gonna finish the tutorial, the project for once. And so that means this is the actual last part of the tutorial. So a series of 4 episodes. All right. So yeah, we create a main.menu.js file. In that file, I'm going to create a bunch of I'm gonna copy paste the code and explain it. So basically, what happens here is we have the game state, okay, corollarized background to basically put a black background. We have locales, but it isn't used at all. So we don't need that. There you go. So we have menu text coming from menutext.js, and this is something we need to actually add to the content folder. So let's create a file, call it menutext.js, and then in there, in menutext.js, I'm going to simply have the same structure that I've used previously for the dialogues, which in hindsight, I think it would be better to probably either put dialogues in the CSV file and parse it. That would be great than going with an object approach like that, using records like that. So const English title language indication, basically telling you that press F to switch between French and English. Play indication, press enter to start the game. Now same thing here. The yeah, it's basically the same thing but in French. And then we export that, etc. Now if I go back to main menu, we just create a game object. We don't need the reference. We put the text being in the current locale. And if you remember, in game state is where we get the current locale. And we have the title key. So from the menu text here. So title. And if I go here, size 32, font Game Boy, etc. Now for the, I think we're going to, I think I forgot somewhere to set. Okay, it's going to be set here anyway. We need a different font size for the French language, for the actual dialogues, because it's too big to fit in all the dialogue we want. So that's why I just opted to reduce the font size in that language when the player is playing in that language. So here we have a text component that displays text, an area component. This is just so we can use the anchor component and position the game object from the center. So it's going to be drawn from the center of the position, the coordinate, instead of from the top left corner. And here we use this center function from Kaboom to get the center X of the canvas, center Y -10, -100, so that the title is going to be a bit further above than the actual center Y position. And then right below, we also create another game object for the language indication, telling the player basically to press F to change language. Same logic here, just a bit less. We add 100 so that the text is going down, is going to be displayed a bit down. Same thing here, which is basically the play indication, telling the player to press enter to start the game. And here two event listeners. One is the F key, listening on the F key, and then if the current locale is not French, then it sets it to French. If the current locale is not English, it sets it to English. So yeah, and that's a bit weird. So if the current locale is not French, then it sets it to French. That means here it arrives here and it's going to be not English and it's going to set it back to English. So this might not work actually. So yeah, this might not work. Oh, okay, it doesn't matter because the current locale you get it using here the get function, so we don't get an updated value. So when we set it, this doesn't change because we stored the value in this constant. However, if you were using directly gamested.getLocale here instead of the storing it earlier on, you wouldn't get a working toggle. It would just remain in English always. And then finally, once the language is selected, we just go back to the main menu scene. By doing this, we just basically redraw this scene completely. So that way, this is how we're going to redraw it with the correct language, etc. And then here for the enter key, basically, this is where the player starts the game, and only if here we actually get the current locale. If the current locale is French, then we set the font size to being 28 instead of 30. And then we go to the world and the game starts. All right, so now the last thing we need is basically to go to main.js. And in main.js, we need to actually add this main menu scene. So I need to add it here, and I need to also import it. So import main menu from etc. And our game is done. Let's try it out and see if everything works all right. So I'm going to talk to the old man, get my sword. We're going to test everything. So I have my sword. What happens if I come back? He tells me, oh, you forgot how to use your sword. Press the space key to attack. Please now go save my son before it's too late. If I go back again, please save my son. And then he basically says the same thing, but not starting from the first time first dialogue when we talk to him for the first time. Now I need to test that I can actually hit and kill those slimes, and yep, I took some damage from them. Yeah, the sword is is a bit too short. Okay, I don't think I'm gonna survive the ghost boss. So here, attack, help me. I'm held prisoner here. The keys are held by a ghost in the next room. If I talk to him a bit again, help me, I'm held prisoner. The keys are held by a ghost in the next room. And then if I enter here and get ready to fight, and then I simply spam like that at the correct interval. Here we go. Take the key, go down. Here. Whoa, you got the keys, the door open. Thanks for saving me. Thanks again for saving me. Go talk to my father. He'll reward you. He'll reward you handsomely. All right, let's go talk to his father. We must not die here, otherwise the game is going to consider this a game over and I'm gonna have to restart everything. So I enter here. I talk to the old man and he tells me, as a reward for saving my son, you can keep the sword I gave you. But one thing I realized, I didn't test the actual language stuff because we didn't hook up the first scene as being the main menu. So I need to go here, main menu, instead of world. And then here, start the game. And here you can see the legend of JS. Press F to switch between French and English. Press enter to start the game. Let's press F, and then it's in French. And then press F again, and it's English. And then let's go with French and press enter. Now let's talk to the old man and see how the text is displayed. C'est dangereux de s'aventurer seul. Prends cette épée, presse la touche espace pour l'utiliser. S'il te plaît, sauve mon fils. Il est capturé au donjon situé à l'ouest. Je te récompenserai généreusement. Alright, so it works. It's displayed properly. So thanks for watching. That was the tutorial. Hope you liked it. And if you enjoy JavaScript, game dev related content, tutorials like that, making games in JavaScript, gamified apps, or anything like that, feel free to subscribe to my channel. I'm near 1,000 subscriber, so that would be really nice to get 1K soon. And yep, so hope you enjoyed this tutorial. And if you have any suggestions of projects to do or libraries to check out, or making games with a specific tech stack, for example, make a game with React or something like that, feel free to comment that in the comment section. All right, thanks for watching. Bye.